You're watching the Blender Materials, Textures and Notes course. This course is a compilation of 22 chapters that will make you understand about all the concepts of materials, textures and nodes available in Blender. Throughout this course, we have covered a total of 45 plus nodes related to materials and textures. Not just that, we have also learned about creating our own material library so that we can save the materials there and use them for the future Blender projects. Each chapter of this course will basically be divided into two parts. First of all, we'll understand about the concept related to materials and textures, and then we'll again use the concepts practically by creating a retro gaming arcade scene that will begin in the chapter number 1 and it will be finally completed by the end of this course. So if you are ready to master the skills and concept of materials, textures and nodes in Blender, then now let's begin with the chapter number 1 of this series. So I have opened this new file with the default Blender layout, and the first topic for today's chapter is to understand about the basics of materials. So whenever we open a new Blender file, we have this default cube added along with the default material, and in order to make any changes to the color or to be more specific to the material of this cube, we have to open the material properties, and it can be accessed by clicking on this icon in the properties editor. Over here you can see that we have this default material added to this cube, and in this material properties section we have a variety of settings that we can change to give our cube a different material. For example, the most fundamental property of a material, which is the base color, is set as the white color by default, and to change this color I have to click here, and then this color wheel will emerge from where we can change the color of the cube. However, the reason why we can't see any changes in the 3D viewport is that right now we are in the solid mode, and in order to see the changes we'll be entering the rendered preview mode. So click on this icon on the top right corner, and now we are in the render preview mode, and you can also see that because of changing the base color in the material properties, the same change in color is also being applied to the default cube. Now even though we can change most of the properties of the materials by using the material properties, but the options that we have here are kind of limited, and as a result we have a better method of working on materials in Blender, which is to open the shader editor. So to create a window of the shader editor, I'll take my cursor on the top of the 3D viewport, and then this double-headed arrow will appear, and if I right click and select horizontal split, then by using this line I will be able to create a new window. So I'll left click here, and now we are having two windows. And now to change the above 3D viewport into the shader editor, click on this icon on the top left corner, and from this list select the shader editor. Now if I use the scroll wheel to zoom into the shader editor, then you will notice that we are having these two nodes. The first is the principal BSDF and the second is the material output, and both of them are connected together with this wire-like thing which is named as the link. It is basically used to connect two different nodes together with the help of these colored dots, which are called the sockets of that node. Also, for any node in the shader editor, if you are having the sockets on the left hand side, then they will be used to connect some other node as input, and on the right hand side for the output. You will be understanding about all these things as we further understand about the functioning of different nodes in the upcoming chapters of this course. Now although we can use this cube for understanding about all the materials and different type of textures, but it's always better to have a proper scene with the perfect lighting and a background that we can use to understand about the different type of shaders throughout this course. So first of all, I'll delete this cube by pressing X, and we'll be adding a UV sphere in the scene. So press Shift plus A, then go to Mesh and select the UV sphere. Then right click and apply Shade Auto Smooth. Let's also move it slightly upwards in the Z axis and place it over here. After this, we'll now be creating a background for this object. So press Shift plus A, then go to Mesh and add a plane. To increase the size of the plane, press Tab to enter the edit mode, and we'll scale it up by pressing S. Let's also scale it up slightly in the X axis like this. After that, press 2 for the edge select mode. Select this edge. I'll move it slightly backwards in the Y axis, and let's also extrude it up in the Z axis. So press E and Z and extrude it up like this, and left click to finalize. Also, to make this middle part slightly curved, we'll be applying the bevel tool. So press Ctrl plus B, then move the cursor away, and to increase the number of segments, we'll be using the scroll wheel. After this, click the left mouse button to finalize. Now return back to the object mode, and to make this smooth, right click and apply Shade Auto Smooth. Now press 0 on the numpad to go to the camera view, and to adjust the view properly, we'll turn on the lock camera to view by clicking on this lock icon. After this, to adjust the camera view, we'll be using the scroll wheel or the middle mouse button. So let's adjust the camera properly according to the position of the UV sphere and the plane at the background. Also, if I press N, then the side toolbar will open from where we can change the location and the rotation of the camera. But for that, we need to select this camera object in the scene collection. So I will left click to select it, and now in the location, I'll change it in the X axis, and we'll round off to -0.5, and we'll keep the same values in the Y and the Z axis. Then in the rotation, I'll round off the X axis rotation rotation to 90 degrees. Then in the y-axis, I'll change this to 0 degrees, and similarly in the z-axis also, let's round it off to 0 degrees. Now let's move the camera down in the z-axis like this, and let's also change the location in the x-axis, and now it looks perfect. After all this, I'll select the UV sphere, press tab to enter the edit mode, and let's scale it up slightly, then return back to the object mode, and we'll move it up in the z-axis. After adjusting the scaling and the location of the UV sphere, we'll disable the lock camera to view by clicking on this icon. And now let's work on the lighting part. But before that, I'll open the render properties and we'll change the render engine from EV to cycles. This will help us to get a more realistic view of the different type of materials. Now to get a proper lighting, click on this icon and turn off the scene world. After this, I'll select the background plane and we'll change the color of this plane to dark grey or dark blue. And to do this thing, I'll go to the shader editor, click on the new button to create a new material. And now you see here that we again have this default principal BSDF applied to the background plane. To change the color, I'll go to the base color, click here, and I'll reduce the brightness with the help of this brightness slider. Also, I'll change the color to slightly blue, and now the background plane looks perfect. After this, I'll zoom out, and over here, I'm having this default light placed over here. So I'll move it down in the z-axis. Let's also move it slightly in the x-axis, bring it closer to the UV sphere. Now to change the color of this light, click on this icon, which is the object data properties. Now in the color, we'll change this to slight pink color, then press G to move it, and I'll place it over here. Also, let's go to the top view by pressing 7 on the numpad, and we'll adjust the position of the light properly in the scene. Let's also adjust the color of this light, and after that, I'll create a duplicate of this light by pressing Shift plus D, and we'll move it in the x-axis and place it over here. Then for the color of this light, I'll change this from the pink color to light blue. Now press 0 on the numpad to go back to the camera view, and finally this is how our scene is looking. And yes, we'll be using this file with this particular scene of the UV sphere and the lighting along with the background in all the upcoming chapters of this course to understand about the different type of materials, textures and nodes. Now let's come back to our topic of understanding the principal BSDF node. So I'll select the UV sphere, and then in the shader editor, if I click on this icon, then you will notice that we are having a list of two materials. The first has the name material and the other one has the name material.001. This material.001 is the same material that we have used for the background plane. However, if I click on this icon again and select the first material, then this one is the material that we used on the default cube before creating this scene. So we understood about the base color, which simply helps you to change the color of any object. But then the next useful thing that we have in the principal BSDF node is the metallic value, and as the name suggests, it controls the amount of metallic strength of a particular material. By default, its value is set to 0, but if I increase this to its maximum value of 1, then you will notice that the surface of the UV sphere on which we have applied this red colored material is now looking like a metallic and a shiny surface. It is properly reflecting the light that is falling on its surface. So when the value of metallic strength is equal to 0, in that case, the material will be less metallic, and as a result, the reflections will also be less. Then as we begin to increase the metallic strength, the amount of reflections will increase since the metallic strength of the material is also increasing. Then the next one that we have is the roughness, and as the name suggests, the roughness value will control the amount of roughness of the surface on which the material is applied. For example, if I reduce this value to 0, in that case, we are having a very smooth surface, but as I begin to increase the roughness value, the amount of smoothness will reduce and we'll be having a very rough look on the material. Then the next one that we have is the IOR, which means index of refraction, and it allows you to control the bending of light when it is passing through a transparent material. You must have seen the bending of light when it enters water or glass, and this happens because of the refraction effect. Every object or material has a different value of index of refraction. For example, the value of index of refraction for air is equal to 1, for water it is 1.33, then for glass it's somewhere around 1.50, for diamond it's around 2.42. So whenever we are working on transparent materials, we can use this value to get a perfect refraction effect. Now the next one that we have is the alpha, and this one controls the amount of transparency of a particular material, meaning that if I reduce the alpha value to 0, then in that case the material will turn completely transparent, and if I begin to increase the value of alpha in the principal BSDF, the amount of transparency will reduce and the material will begin to reappear. And yes, before moving forward, almost all of these options that are available in the principal BSDF, like the subsurface, transmission, sheen, emission, all these can also be controlled with the help of their individual nodes that Blender has provided us. For example, if I press Shift plus A, then go to shader, then here you can see in this list that one of the nodes is the sheen BSDF, which is exactly the same as the sheen in the principal BSDF. Similarly, we also have the subsurface scattering, the emission, the refraction BSDF. So even if you can't understand about all these options in the principal BSDF node, then you need not worry, because we'll again cover them up in the upcoming chapters while individually studying each of them in detail. But for now, let's continue with the subsurface. Now this particular parameter controls the amount of light scattering within the material. You must have noticed that when light hits an object, for example the hand of a person, then some of the light penetrates the surface and gets scattered. The scattered light re-emerges from the surface at various points, contributing to the overall appearance of the material, and this is known as the subsurface scattering effect. And the same effect can be obtained by using the subsurface in the principal BSDF. To see that effect, I'll go to the weight value, which is by default set to 0, and if I increase this, then the amount of effect of the subsurface scattering will increase for the material. But right now, that particular effect cannot be seen on this UV sphere because we are not having any particular option for controlling the color of the subsurface scattering. In the previous versions of Blender, there used to be an option of controlling the color directly in the subsurface option of the principal BSDF. But now, Blender has added another node in the shader, which is the subsurface scattering, and in this node, it has provided us the option to control the color. And so there is no option to control the color directly from the principal BSDF. But yes, there are a few methods which can be used to set a particular color in the subsurface option, but they are a bit complicated to understand in the first chapter of this course. So for now, I'll close this menu of the subsurface and will also delete the subsurface scattering node, which we'll be understanding in the upcoming chapters of this course. So with this selected, I'll press X to delete, and now the next one that we have here is the specular, and this one controls how shiny your material will look. To understand this parameter in more detail, I'll left click to select the principal BSDF node, and then in the side toolbar, I will click on reset node. This will reset all the changes that we have applied to the principal BSDF node so far. Now in the metallic strength, I'll keep the value to 1 and will reduce the roughness to 0.1. The reason for doing this is that to understand about the specular, we need to have a smooth and a reflecting surface. Now the IOR level in the specular controls the amount of specular intensity, and the tint controls its color. For example, with the IOR level set to 0.5, if I try to change the specular tint to some specific color, for example the red color, then you will notice that we are having a slight tint of the red color on the boundaries. In fact, if I try to change the angle with the middle mouse button, then you will notice that this red colored boundary is still appearing because of the specular tint. Similarly, if I change this color to the green color, then now we are having the green color as a specular tint. Then over here, we also have two more options. The first is the anisotropic and the next is the anisotropic rotation. So you must have noticed that on aluminium vessels, like in these images, you have these circular reflections, and these can be achieved by using the anisotropic option in the principal BSDF. So first of all, I'll go to the camera view by pressing 0 on the numpad, and then in the anisotropic, I'll increase this value from 0 to 1. And when I'm increasing it, you will notice a slight reflection on this top part, and this is the result of the anisotropic parameter. Similarly, if I go to the anisotropic rotation and try to increase it, then the anisotropic effect will begin to rotate, and at a value of equal to 1, we'll again have a complete circle. So you can try to change these values in the anisotropic rotation and the anisotropic to control its effect and the rotation. And again, we'll understand all of these settings when we individually study about them in the upcoming chapters. But for now, we'll understand about the next one, which is the transmission. But before that, I'll click on the reset node button to remove all the changes. Now the transmission helps to make the material of an object look like glass. So if I go to the transmission weight and increase this value to somewhere close to 1, then you will notice that now we are having a glass-like material applied to the sphere. So whenever you want to create a material which looks like glass, then you can use the transmission value, and to make it smoother, you can go to the roughness value and reduce this to 0. This will make the glass less rough and a lot smoother. Now the next one that we have in the principal BSDF node is the code settings. So to understand it, I'll first click on the reset node to get the default principal BSDF, then go to the code settings, and in this we are having some useful options like the weight, the tint color, and this allows you to create a coating of a particular color on your material. For example, by default, the base color in the principal BSDF is set as the white color. However, if I change this to the red color, then the material's color will also change to the red color. Now in the coating, if I change the weight to a value of 1, and in the tint, if I change this to the blue color, then in this case, even though the original color of the material on the UV sphere was red, but we have applied a coating of the blue color on the same material, and that is why it looks like this. Similarly, if I reduce the weight value to somewhere around 0.5 or 0.4, then we'll get a mix of both the colors on this material. To see it in a much better way, let's increase the weight further. So around 0.7 or 0.8, you can clearly see the red base color along with a slight coating of the blue color. Then from here, you can control the roughness value of the material generated. After this, the next property that we have in the principal BSDF is the sheen. However, this property is not something that we very often use while creating materials. So we'll not be covering this right now, but as I told you before, we also have a separate node which is called the sheen BSDF. So we'll understand about it in complete detail in the future chapters. Then over here, we have the emission, and this helps to add a glowing effect to our material. By default, the emission color is set as white, but the reason why we can't see any glowing effect is that the emission strength is set at 0, but if I begin to increase it, then you will notice this glowing effect applied on the material of the UV sphere. Similarly, if I go to the emission color and try to change it, then the color of the glow will begin to change. Now to see the glowing effect in a better way, I will hide both the lights from the scene collection by clicking on the eye buttons. After this, click on this icon and turn on the scene world. And now you will notice that we are not having any lighting in the scene except for this glowing material because of the emission values. And with this, we have learned about almost all the important functions in the principal BSDF node. Now in the shader editor, you can also see that we are having one more node connected to the principal BSDF, and this is the material output node. The function of this node is to output the material information for a specific material which is to be applied on the object. Now let's move to the next topic for this chapter, which is to create our own material library. But before that, I'll first unhide both the lights in the scene and also click on this icon and turn off the scene world. Now a material library is basically a collection of materials which you save on a particular location of your device, and then you can use the same materials in your other Blender projects. But before creating a material library, let's first create a basic material that we'll save in our material library. So for this, I'll first select the principal BSDF node in the shader editor and click on the reset node, and now we'll be creating a material which looks similar to the brushed aluminium metal. So first of all, since we are creating the aluminium metal, so I'll go to the metallic value and increase it from 0 to 1. Let's also reduce the roughness to give it a more shiny appearance. So I'll keep the roughness value to around 0.1 or 0.2, and now to create the brushing effect, we'll be using the anisotropic option in the specular category. So over here, we have the value of anisotropic set as 0, but I'll increase it to 1 to create this brushing effect. Then in the anisotropic rotation, let's keep it to somewhere around 0.4 or 0.5 for a perfect rotation. But right now you can see that the metal that we have created is reflecting a lot of light that is falling on it. So to avoid this problem, we have to increase the roughness value. So I'll increase this to around 0.4 or 0.5, and this will give it a perfect look just like the aluminium metal. Now to save this material that we have created in our own material library, we first need to change the name of this material, which is written over here. By default, its name is material, and to change it, simply left click over here, and now we can change its name to anything that we like. So I have renamed the material to brushed aluminium, and now let's finally work on creating the material library. So go to the edit option on the top left corner and select preferences, then go to file paths, and in the asset libraries, click on the plus icon. Now we have to create a folder in order to save our material library. So right click in the Blender file view and select the new folder. Now let's rename this folder to materials, and alternatively, you can also click on this icon to create a new folder. After this, open that folder by double clicking on it and then click on the add asset library. Now in this asset libraries option, we are having this material library that we just created. So now I'll close this window, and now to view the material library, click on this icon, and from here, select the asset browser. Now click here, and in all these categories, we are having the materials, which is basically the material library that we have created. But right now, it's empty because we need to save the material that we created in this library. And to do this thing, go to the scene collection, then with the sphere selected, click on this drop down button, then click here, and now you will find this brushed aluminium material that we have applied to the UV sphere. Now to save this material in the material library, right click and select mark as asset and click on the refresh button. And with this, we are having the brushed aluminium metal added in the material library. Now it might be possible that even after clicking on the refresh button, you're not able to see the material that you created in this library. And if that happens, you need to ensure that the specific file on which we are working right now is saved in the same location as the folder that we created to save the material library. So if you're having this file at a different location, then simply open the file explorer and change the location of the specific file to the required folder. And with this, we have now completed the first section of this video. We learned about the shader editor, the principal BSDF node, the material output node, and even created our own material library. And so now let's move to the second section of the video, where we'll practically use the materials for creating a retro gaming arcade scene. So I've opened a new Blender file, and yes, as I already told you before, we'll be working with two files throughout this course. The first one was that file on which we are working till now to understand about the different type of shaders, and the second file is this one where we'll create the retro gaming arcade scene. And also, you can get the final versions of both the files with all the materials and the complete scene ready by joining the Patreon of this channel, whose link is added in the description of this video. Now we'll first begin with modeling a simple gaming arcade machine. And so with this cube selected, let's go to the edit mode by pressing tab, and we'll model the machine in such a way that this part of the cube will be the bottommost part, and we'll keep editing and extruding it in the upward direction to complete our model. So first of all, I'll press 2 for the edge select mode, select this edge, let's move it slightly forward in the x-axis like this, and this will be the bottommost part of the machine. Now press 3 for the face select mode, select the top face, press E to extrude it up slightly, and left click to finalize. Then with this top face selected, again press E to extrude it, and after this, press 2 for the edge select mode, mode, select this edge on the front side and we'll move it backward in the x-axis. Then left click, again press 3 for the face select mode, select the top face and let's extrude it up by pressing E. So this will be the bottom part. Then over here we'll be having the controls and this will be the screen of the gaming machine. Now to make some adjustments, I'll press 2 for the edge select mode, select this edge loop and we'll move it down in the z-axis in order to make the area for the controls slightly smaller. Similarly, press 3 for the face select mode, select this face at the top and we'll move it down slightly in the z-axis like this. Let's again extrude it up for the top part of the machine. So press E to extrude it up, left click. Now press 2 for the edge select mode, select this edge on the front side and move it backwards in the x-axis. And with this, the basic 3D model of the machine without much detailing is ready in the scene. Now to work on the detailing, let's again enter the edit mode, press 3 for the face select mode and we'll be selecting these 3 faces on the sides, then select these 2 faces on the front part and similarly I'll also select these 3 faces on the other side. Now press I to insert and again click I to individually insert the faces, then left click and to extrude them along their normals, press Alt plus E and in the extrude menu, select extrude faces along normals. Now I'll take my cursor away from the faces and left click to finalize. With this, we have now applied the insert faces effect and also extruded these faces inwards in order to add some detailing. Now return back to the object mode and to get a better view of the 3D model, click here and turn on the cavity. By doing this, we'll be able to see the empty spaces in the geometry in a much better way. Now let's also increase the size of this machine in the y-axis. So press tab to enter the edit mode, press A to select all and to scale it up, press S, Y and increase the scaling in the y-axis. Then left click and after adjusting the scaling, we'll return back to the object mode. Now the next thing that we'll do is to create some gaming controls for the machine, and for this I'll first bring the 3D cursor at this point. So with the shift key holded, I'll click the right mouse button at that position where I want to place the 3D cursor. Now press shift plus A, then go to mesh and select the cylinder. The cylinder will get added at the position of the 3D cursor. Now press tab to enter the edit mode, press S to scale it up in the Z axis and left click to finalize. Now we'll rotate it in the Y axis like this and let's scale it down according to the size of the game controls. After this, let's go to the front or the side view to adjust the position of the game control. Now let's change the angle and we'll now place a UV sphere on this front part. So with the shift key holded, I'll click the right mouse button at this position in order to bring the 3D cursor over here. Now press shift plus A while being in the edit mode and select the UV sphere. Press S to scale it down and left click. Let's change the angle. Now go to the front or the side view and adjust the position of the UV sphere. After this, return back to the object mode, right click and apply shade auto smooth. Let's create a duplicate by pressing shift plus B and move it in the Y axis over here. Now the next thing that we'll do is to work on creating the materials for this arcade gaming machine. So let's go to the rendered preview mode and also change the render engine in the render properties from EV to cycles. To get a proper lighting, click on this icon and turn off the scene world. Let's also disable the scene lights and now we'll select the body of the machine. With this selected, we'll now apply some materials to it. But instead of using the shader editor, we'll apply the materials by going to the material properties. So I'll click on this icon and by default, we have this white material added, and in the surface option, you can see that the default principal BSDF node is selected here. And as a result, all the properties that were available in that node can also be controlled from this menu. For example, in the base color, I'll change this to the purple color. Let's also bring down the brightness slider to make the color darker. Then to increase the metallic strength, I'll go to the metallic value and increase this from 0 to somewhere around 0.5 or 0.6. Let's also bring down the roughness value. So we'll keep it to 0.3 or 0.4. And with this, we are having a simple metallic material applied to the body of our machine. Now the next thing that we'll do is to create some new materials for some specific parts of the machine. And to do this thing, let's first go back to the solid mode, press tab to enter the edit mode, and now we have to select all the faces where we wish to apply some new material. So first of all, I will select this face loop by holding Alt and left clicking here, and then to select multiple face loops, I will keep holding the Alt button, but along with that, I'll also hold the Shift button. Now left click here to select this face loop. Let's select this one also, change the angle, then with the Alt and the Shift key holded, select this face loop, this one also, and just like this, let's also select these 3 face loops on the opposite side. And yes, if you want, you can select or deselect any face loop depending upon the geometry of your model. Now with all these faces selected, we have to create a new material that will apply to the selected faces. So go to the material properties, and to add a new material slot, click on the plus icon, and to create the new material in this slot, click on the new button. Now the default principal BSDF is applied, and if I go to the rendered preview mode, then you will notice that this new material is not yet applied to the selected faces. So to apply it, click on this assign button with all the selected selected faces. And now in this material, I'll first change the base color to yellow. Let's also increase the metallic value to around 0.4 or 0.5, and let's also bring down the roughness value to give it a smoother appearance. Then scroll down, and in the emission, we'll use the emission color and the emission strength to create a glowing effect. So in the color, let's choose the yellow color, and in the emission strength, let's enter a value equal to 1. After this, return back to the object mode, and then if you want, you can adjust the metallic strength or the roughness value to give this yellow material a better appearance. Also, you can go to the emission strength value and increase or reduce the strength of the emission. But for now, I'll keep the value to somewhere around 0.8 or 1, and then moving ahead, the next thing that we'll do is to apply the bevel modifier to this object to give it a realistic appearance. So go to the modifier properties, click on add modifier, and in the generate, select the bevel modifier. Now in the number of segments, we'll increase this to 3 or 4, and in the amount, I will keep this to the default value of 0.1. Now moving ahead, let's now work on creating a black colored screen for the front part of the machine. So press tab to enter the edit mode, select this face, go to the material properties, and to create a new material, click on the plus icon and click on the new button. Now in the base color, I'll reduce the brightness to change the color to black, and let's also reduce the roughness value to give it a smooth and shiny appearance. Now click on the assign button and return back to the object mode. Now to control the amount of reflection on this black screen, you can go to the metallic value and increase this. So I'll keep it to somewhere around 0.2 or 0.3 in order to have some slight reflections on the screen. Then I'll select this control, create a new material in the material properties, and I'll set the base color to red. After this, if I zoom in, then you can see that the material applied on the surface is very rough, and to give it a smoother appearance, I'll go to the roughness value and we'll bring it down from 0.5 to 0.1, and by doing this, we are now having a smooth and shiny surface. Now press tab to enter the edit mode. Let's also go to the solid mode by clicking here. Now in the edit mode, I'm having this UV sphere selected, but if in your case the UV sphere is deselected, then simply keep the cursor over the UV sphere and press L, and this will select all the vertices linked to the UV sphere. Now go to the material properties, click on the plus icon and create a new material. After this, in the base color, I'll change this to the yellow, and let's also bring down the roughness value to 0.1. Now return back to the render preview mode. Let's also click on the assign button and return back to the object mode. If you want, you can change the base color to any color of your choice for the game control. For example, here I have selected a combination of red and the pink color for this particular game control. Similarly, I'll select this one, and now suppose I want to apply the pink material that we created for this object to the other game control. And to do this thing with this game control selected, I have to go to the material properties, click on this icon, and this will display a list of all the materials that we have made in this file. Now select the required material, which in this case is the material.004, which is pink in color, and by doing this, we are having the pink material applied to this game control. Similarly, for the spherical part, I will apply this red material. So click on the plus icon, then click here and select the material.003, which is the red material, and to apply it, press tab to enter the edit mode, and with the UV sphere selected, click on the assign button, and with this, we have now applied some very basic materials to the different parts of this arcade gaming machine. Right now, it is looking very simple because the only node that we have learned in the chapter number 1 is the principal BSDF node. But as I told you before, we'll be learning a lot of new shader nodes with every new chapter, and we'll be making the changes to the materials on different parts of the arcade gaming machine and also to create the rest of the scene. But for now, let's finalize the scene for the first chapter by adding a plane below this arcade gaming machine. So for this, let's first select all the parts of the machine including the game controls, go to the solid mode, press 1 on the numpad, and we'll move it up in the Z axis like this. After this, press shift plus A, then go to mesh and select the plane, and right now it is being added at this position because of the 3D cursor. So I will delete it, and to reset the position of the 3D cursor, press shift plus C. Now press shift plus A, then go to mesh and again add the plane, press tab to enter the edit mode, and let's scale it up 5 to 10 times. Now return back to the object mode, and let's now apply a very basic material to this plane object. So go to the material properties, click on the new button, and in the base color, I'll reduce the brightness, and let's also change the color to the green color. You can also increase the roughness value in order to make the surface of the base have a less smooth and reflecting look. And with this, we now arrive to the end of this chapter. Today we learned about the principal BSDF node, the shader editor, creating the material library, and then in the second section of the video, we used our knowledge of the principal BSDF node to create some very simple and basic materials for this gaming machine. So I have opened this file that we created in the last chapter to understand about the different type of shaders. We first understood about the principal BSDF node and used it to create a brushed aluminium material. But now it's the time to move to the first topic of this chapter, which is the glossy BSDF node. To understand about it, we first need to create a new material. So in the shader editor, first of all, click on this cross icon to remove the brushed aluminium material from the UV sphere. Now click on the new button to create a new material, and now to add the glossy BSDF node, press shift plus A in the shader editor then go to the shader category and select the glossy BSDF. Now left click to place it over here, and right now it is not connected to the material output, and as a result it's not yet applied to the UV sphere. So to connect it to the material output node, we'll first remove this principal BSDF node. So left click to select it and press X to delete. After this, to connect the glossy BSDF node to the material output, we have to connect this BSDF socket to the surface socket in the material output. So for this, left click on the BSDF socket and drag your cursor to connect it to the surface socket in the material output. And by doing this, we are now having the glossy BSDF material applied to the UV sphere. Now this glossy BSDF is used to add reflections on your material. You can use this shader node while creating materials like metals and mirrors, and in this node you also have options like the color, using which you can control the color of this glossy material. Similarly, we also have other options like the roughness value, which by default is set at 0.5, but if I try to reduce it, then the sharpness of the reflection on the surface of the material will begin to increase. At a value of 0, the reflections will be perfectly sharp, and at a value of roughness equal to 1, we are not able to see any reflections on the surface since it has now turned into a smooth material. So ideally, for a metallic surface, it's advisable to keep the roughness value at around 0.4 or 0.3 depending upon which particular metal you are trying to create. Similarly, the next option that we have is the anisotropy, and as we learned in the last chapter, you can use it to create the stretching effect of the reflections along the surface of the material. So if I begin to increase this value of anisotropy, then you will notice the stretching effect of the reflection, and by using the rotation value, you can change the rotation of these anisotropic reflections. So whenever you want to create the stretching effect of reflections on the object's material, then try to change the value of the anisotropy and the rotation until you get a perfect result. So now we have created this material with the help of the glossy BSDF, and so now we'll save this newly created material in our material library that we created in the last chapter. Also, if you wish to download this complete Blender file with all the materials that we create in the upcoming chapters of this course, then you can consider joining the Patreon of this channel, whose link is available in the description of this video. Now to save this material, I'll go to the shader editor, and first we'll rename it from material to glossy, and to indicate the color, I'll also type red. So now the material name is glossy red. After this, to save this material, go to the scene collection, and in this sphere drop down, we have this option to select the glossy red material that we have just created. So I'll select it, then right click and click on mark as a set. And yes, if you want to learn about creating your own material library in Blender, then watch the chapter number 1 of this series where we understood about it in complete detail. Now to view the material library, I'll change this window from the shader editor to the asset browser. Now click on the refresh button, and now here we have the brushed aluminium material that we created in the last chapter, and this glossy red material that we created in today's chapter. And after this, let's now move to the next topic of this chapter, which is understanding about the diffuse BSDF node. So first of all, I'll change this window from the asset browser to the shader editor, and after this, to create a new material, I'll select the UV sphere, click on the cross icon to remove the glossy red material, and then click on the new button. Also, if it ever happens that you wish to add any material that you previously used in that file to any object in the scene, then you can click on this icon, and here you will get the list of all the materials which are used till now. So in the shader editor, we are having this principal BSDF node, but in order to understand about the diffuse BSDF node, I'll press Shift plus A, then go to shader and select the diffuse BSDF. Left click to place it over here. Now to connect the diffuse BSDF node to the material output, I'll take this BSDF socket, which is the output, and connect it to the surface socket in the material output. By doing this, the principal BSDF node will automatically get disconnected, and I left click to select it and press X to delete. Now the material applied on the UV sphere because of the diffuse BSDF node might look very similar to the one applied by the principal BSDF. And to understand why it happens, we need to understand the difference between the glossy BSDF node that we just understood and this one. As a result, in the shader editor, let's also add the glossy BSDF node. Now if I connect the glossy BSDF node to the material output, then we used to have this material with some reflections, and this was used to create metallic materials. Just the opposite of this is performed by the diffuse BSDF. It is used to create materials for non-metallic surfaces. As you can see, even at a roughness value of 0, we are not able to see any reflections on this material surface. And as you all know, metals are the ones which reflect light, and the effect of lighting also changes the way the metallic materials look. But just the opposite is the case with non-metallic materials. They do not reflect the light in the same way as metals do, and as a result, any change in the lighting of the scene does not influence the way how the material will look in our scene. So in Blender, whenever you have to create metallic materials, then you should be selecting the glossy BSDF node because it will give you the reflections reflections, and whenever you have to create non-metallic materials, then you should go for diffuse BSDF node due to the lack of reflections. Now in this node, we also have option to control the color of the material. For example, if I select the blue color, then the color of the material will change to blue. Then over here, we have the roughness value, which by default is set at 0, but despite having such a low value of roughness, we are not able to see much reflections on this material. In fact, even if I try to increase this value of roughness, you won't notice much difference in the material. Now moving ahead, the next topic for this chapter is understanding about the transparent BSDF node. So first of all, I've selected both of these nodes and will delete them by pressing X. Now in the shader editor, press Shift plus A, then go to shader, and now we'll add the transparent BSDF node. Let's place it over here and connect the BSDF socket to the surface socket in the material output. Now as the name suggests, it is used to create transparency, and that too without any refraction. As a result, we get a completely transparent material, and it looks as if there's actually no material added over here. In fact, if I deselect the UV sphere, then now the material is completely transparent, and this is because of the lack of refraction. If you remember, in the last chapter when we were learning about the principal BSDF node, I told you that by using the transmission value, you can create a material which looks like glass. So for now, if I take the BSDF socket and connect it to the material output, and in the transmission enter the value equal to 1, then you can clearly notice the difference between the kind of transparent material that we are getting in case of the principal BSDF node and the transparent BSDF. The one that is created because of the principal BSDF node looks a lot more realistic as compared to the transparent BSDF node. And as I told you before, this is happening because of the refraction of light, and this refraction can be controlled in the principal BSDF node with the help of this IOR value. For air, this value is equal to 1, and at this value, we'll get a material which is completely transparent, just like the one that we got by using the transparent BSDF node. But in real world, transparent objects like glass, water have the value of IOR greater than 1, that is around 1.3 or 1.4, and this gives them a realistic transparent appearance. Now coming back to the transparent BSDF node, we also have the option to control the color, and by using this option, I can set any particular color for the transparent material. And after this, let's now move to the last topic of this chapter, which is translucent BSDF node. So to understand it, I'll first remove the principal BSDF and the transparent nodes from the shader editor. So press X to delete. Now press Shift plus A, then go to shader and select the translucent BSDF. Let's place it over here and connect it to the surface socket in the material output. Now you must be knowing that there's a category of objects known as translucent objects, and the special thing about them is that they allow some of the light to pass through them. They are different from the transparent objects, which basically allow all the light to pass through them, and they're also different from the opaque objects like table, chair, which do not allow any light to pass through them. So again, in case of translucent objects, we'll be able to see some amount of light passing through them. To understand about this in more detail, I'll go to the top view by pressing 7 on the numpad. Now select this light, press Shift plus D to create a duplicate, and we'll place it at the back of the UV sphere. Now in the color, I'll change this to the red color, and in the power, let's increase this to 1500 watts. Now press 0 on the numpad to go to the camera view, and if I zoom in, then you will notice that even though the color of this material is white, but we are still able to see a slight amount of red light passing through its surface. Now if I go to the shader editor and add the principal BSDF node and connect it to the material output, then in this case, the material which is produced is not allowing any red light to pass through its surface. And basically this is the thing which is unique in the translucent BSDF. Now in this node, you also have the option to control the color of the surface on which the material is applied. And after this, we have now learned about the 4 shaders, namely glossy BSDF, diffuse BSDF, transparent, and translucent BSDF. And now it's the time to use some of these shaders in this retro gaming arcade scene that we started creating in the last chapter. So I've opened this scene where we created this arcade machine and even applied some very simple materials to it. And to continue with the scene, we'll be applying the glossy red material to these side faces. But for doing this, we need to open the asset browser. So first of all, I'll expand this timeline editor and change this window to the asset browser. Now from here, I'll change the asset library from all to materials, and to use the glossy red material on some specific faces of the machine, we first need to create a new slot for material in the material properties. So click on the plus icon, then go to the material library, left click on the glossy red material, then we'll drag and drop it on this empty slot in the material properties. After this slot will now have the glossy red material added to it. Now to assign this material to some specific faces, press tab to enter the edit mode. Now with the shift key hold, select these 3 faces on the left side, and similarly, let's also select the 3 faces on the other side. So with the shift key hold, select these 3 faces also, and after this, in the material properties, select the glossy red material and click on the assign button. Now return back to the object mode, let's change the angle, and now this is how the glossy material is looking on the machine. If you want, you can change this window to the shader editor. Let's zoom in, by using the scroll wheel, and you can change the color by using the color option from here, or the roughness value if you want to change the amount of reflections. But for now, I'll keep the color as red, and in the roughness, I've entered a value of around 0.6. And yes, if I reduce the value of anisotropy down to 0, then in this case, we'll be having a lighter shade of red. After this, I'll also bring down the roughness value down to 0.4 or 0.3, and now it looks perfect. Moving ahead, let's also create a transparent face for this bottom part of the arcade machine. And for this, go to the material properties, click on the plus icon to create the slot for a new material, then click on the new button, then in the shader editor, press shift plus A, then go to shader, and we'll use the transparent BSDF node. So let's place it over here, connect the BSDF socket to the surface in the material output, and to assign this material to the bottom face, press tab to enter the edit mode. Let's also go to the solid mode. Now select this face, and let's also apply the inset tool by pressing I and left click. Now I'll select this material with the transparent BSDF node and click on the assign button. Now return back to the object mode, go to the rendered preview mode, and if I change the angle, then you can see that this particular face is now completely transparent. As a result, we are able to see through this particular face. Also, to see the effect of this yellow emission material that we created in the last chapter, click here and turn on the scene lights and the scene world. Now to make the emission material look realistic, we'll do a few changes in the solid mode. So first of all, press tab to enter the edit mode, and now we'll be selecting these boundary faces surrounding the ones with the glossy material, and then we'll apply this yellow emission material to them. By doing this, we'll be able to create a nice glowing effect for the arcade gaming machine. But to do this thing, let's first go to the modify properties, and we'll disable the real-time display of the bevel modifier by clicking on this icon. Now to select this face loop on the boundary, simply hold on the Alt button and then left click on this edge. Then for the next one, with both the Alt and the Shift key holded, left click on this edge. Then for this bottom part also, I'll hold the Shift and the Alt button and left click here. After this, let's move to the other side, and with the Shift and Alt key holded, select this face loop, then select this one, and at last, let's also select this face loop. Now go to the material properties, select the emission material and click on the assign button. After this, go to the rendered preview mode, and now we are able to see the lighting effect in these inner boundaries of the faces in a much better way. If you want, you can go to the emission strength and try to increase it or decrease it depending upon the object and the lighting in your scene. And also, you can try to change the emission color to something else like green or blue or red, but for now, I will choose the yellow color for the emission. Also, I'll turn off the scene lights and the scene world in the viewport shading menu. And with this, we have now arrived to the end of the chapter number 2. Today we learned about some new type of shaders, some new concepts, and then we also tried to use them in this project of the retro gaming arcade machine. Before ending, let me also enable the real-time display of the bevel modifier for this gaming machine. So I've opened this file where we understand about the different type of shaders and even create our own materials. And now the first topic for this chapter is understanding about the volume scatter node. But before that, let's also delete the translucent BSDF and the principal BSDF nodes in the shader editor. So with both of them selected, press X, now press Shift plus A, then go to shader, and we'll select the volume scatter node. Let's place it over here, and before explaining about this node, I should also tell you that all the 3 nodes that we'll discuss in this chapter are related to volumes, and therefore you won't be using them a lot in Blender. Now coming back to the topic of volume scatter, this node allows us to create a material that allows the light to be scattered as it passes through the volume. To understand this practically, we have to connect the volume socket in the volume scatter node to the volume socket in the material output. However, if by mistake you connect the volume socket of the volume scatter to the surface in the material output, then in this case you won't notice any difference and you will get a black material. Now to remove this connection that we have created between the volume socket and the surface socket, hold down the control button, then right click and drag your cursor like this. Now I'll take the volume socket and connect it to the volume in the material output. By doing this, you will notice a few changes in the material which is applied to this UV sphere. As the name suggests, it's create a volumetric material just like fog or smoke, and by using the color option, you can control the color of the fog or the smoke. In fact, you also have the option to control the density of this volume. So if I increase it, the density of volume will increase, but you will notice that the color of the volume will also change. And this is because the volume scatter node will scatter the light as it passes through it. As a result, its color will also depend on the lights that we are having in the scene. For example, if I select this light on the top which is red colored and press X to delete it, then you will notice a slight difference in the color of this volume. For now, I'll reduce the density value to around 1.5 or maybe 1 in order to get a blue colored fog or smoke. Now moving ahead, just like the volume scatter node, we have another node which is called the volume absorption node. To add it here, press Shift plus A, then go to shader and select the volume absorption. Let's place it over here, connect the volume socket to the volume in the material output, output, and you will notice that the material is now looking completely transparent. As the name suggests, this particular node allows the light to be absorbed, which is in contrast to the volume scatter node, which used to scatter or bounce off the light falling on it. Now in order to use it to create some volume, you can go to the color option, and if I set any particular color, then you will notice that particular color being applied to the volume. Similarly, you can also control the density from here. If I reduce it, the density of volume will reduce, and if I begin to increase it, the density of the volume will increase. For now, let's keep it to 1, and this is how it looks. So you can use both of these nodes to create some volume like smoke or fog depending upon your scene. But again, as I told you before, both of these nodes are very rarely used in Blender. And another reason why we don't use both of these nodes so often is that we have another node which can perform the function of both of these nodes together along with some additional settings. And this particular node is the principal volume node. So to add it here in the shader editor, press Shift plus A, then go to shader and select the principal volume. Let's place it over here. Also, I'll select the volume absorption and the volume scatter nodes and press X to delete. Now in the principal volume node, I'll take this volume socket and connect it to the volume of the material output node. Now over here, you can see that the material of this UV sphere is now changed to a smoke-like or fog-like material. However, to understand about the principal volume node in even more detail, we should use a complex model in our scene. So first of all, with the UV sphere selected, press H to hide. Let's also hide this plane which we added at the back. Now press Shift plus A, then go to Mesh, and for a complex object, we'll choose the monkey object. So I'll select it from here. Let's move it up in the Z axis, and to give it a natural appearance, press Ctrl plus 2 in order to apply the subdivision surface modifier to it. After this, go to the shader editor, and to apply the same material that we used on the hidden sphere with the principal volume node, you can select the sphere in the scene collection. Then in the shader editor, you can see the name of this material, then select the Suzanne model. Click here to see the list of materials in this Blender file. Now select that particular material, and then it will get applied to the monkey object. Now the effect of the principal volume material on this monkey object is much more clear. Now in this node, the most important setting is the density value, and as the name suggests, it controls the density of these smoke particles or the volume particles which are kind of forming the shape of the monkey in the scene. So higher the density, more will be the volume particles, and as a result, it will look less volumetric and more solid. But if I reduce the density value to somewhere around 5 or 6, then in that case, the material of the object actually looks like volume because of the low density. Then over here, you have the color option, and as the name suggests, this can be used to control the color of the volume material. If I set the color to green, then the color of this material with the volume will change to the green color. Now I just explain you the meaning of this color feature in the principal volume node in general terms. However, in terms of volume and lighting, its meaning can be a little complex to understand, because this color option basically means the color of the light which will be scattered by the volume, and whatever color of the light the volume will scatter, you will begin to see that particular color on this volumetric material. This color option is very similar to the color option in the volume scatter node. We understood about this node a few minutes ago, and you can see that all these controls that you have in the volume scatter node are also available in the principal volume node. You can control the scattering color with the color option here. Then for the density, you have the density value here, and similarly for the anisotropy, you have the anisotropy value here. For now, I'll delete the volume scatter node, and now if I add the volume absorption node by going to the add menu, and let's place it over here, then in this node also we have the option to control the color of the light which will be absorbed by the volume. And just like this, in the principal volume node also, we have this option of controlling the absorption color. If you want to see the full name, you can expand this node from here by left clicking and dragging it like this, and now from this option you can control the absorption color. So to see how it works, let's first change the scattering color to black, and now in the absorption color, let's increase the brightness, and I'll change this to the red color. And now what's happening is that this volumetric material is absorbing all the red color from the light. And for those of you who don't know, the color which is absorbed by an object's material is not visible in the reflected light. Because of the absorption color set as the red color, the material of this object is absorbing all the red color from the light. As a result, in this middle area, you will notice that the color is very dark or maybe black, and in these outer or the side areas, you will notice some red color because these are the thinner areas which allow the light to go through or pass through them. But yes, as I already told you before, this concept of light absorption and scattering might be a bit difficult for some of you to understand. So in that case, I would suggest you not to get confused, because in most cases, you will use this first color option which is for the scattering color, because this will help you define the color of the volume material. Now one important use of this absorption color is to create some colored glass effects. To understand about this in more detail, we'll be using a node which is called the glass BSDF node. Till now in this course, we have not studied about it, but we'll learn about it in the upcoming chapters of this course. But for now, while being in the shader editor, press Shift plus A, then go to shader and select the glass BSDF. Let's place it over here, and in short, you can use this node to create some glass-like materials. So if I take the BSDF socket in the glass BSDF node and connect it to the surface socket in the material output node, then here you can see that we are getting a beautiful colored glass effect that we created by using the absorption color. If you want, you can change the colors from here to give it a different look. Also, you can control the density of this volumetric color by using the density value here. If I increase it, the color will get more and more dark, and if I reduce it, the color will begin to get lighter. In fact, if I reduce it to the minimum value of 0, then in that case, the green color will hardly be visible on this object's material. So for now, I'll set the density value to 5. Let's also right click and apply Shade Auto Smooth, and in the absorption color, I'll change this to the red color. Also, I'll be saving this particular material that we created with the principal volume and the glass BSDF node in the material library. So to do this thing, let's first rename this material to red glass and then press enter to confirm. Now to save this material, go to the scene collection, then click here. After this, click over here, select the red glass material, then right click and click on mark as asset. Now to check if this material is saved in the material library or not, click on this icon and let's change this window from the shader editor to the asset browser. Click on the refresh button, and now we have this red glass material added in the library. We'll move ahead and understand about the rest of the functions in the principal volume node. So for this, I'll change this window back to the shader editor, and let's also create a new material. So click on the cross icon, then click on the new button, select the principal BSDF node, press X to delete, and now let's add the principal volume node. Let's place it over here, connect the volume socket to the volume in the material output node, and in the density, I'll enter a value equal to 10. Now we have some more options like the emission strength, emission color, and as the name suggests, it is used to create an emission or a glowing effect on the volume material. Then by using the emission color, you can set any particular color for the emission or the glow. And one more way by which you can control the glow or the emission is to use the black body intensity and the temperature values. So to understand about them, I'll reduce the emission strength down to 0, and in the black body intensity, if I left click here and type 1000, then you will notice that the color and the emission strength for this material has now changed. Also, if I begin to reduce this value of the black body intensity to somewhere around 200 or 300, then now we are getting a much more realistic look of the black body effect. Similarly, by using the temperature value also, I can define the temperature in Kelvin for the black body emission. Higher the value of temperature, more will be the emission, and lower the temperature, lesser will be the emission. And yes, mostly you will be using the black body intensity and the temperature settings while creating the material for fire, because in that case, you will need an orange colored emission which can be achieved by using different values in the black body intensity and the temperature. And with this, we have now understood about the 3 volume shaders available in Blender. The first was the volume absorption node, the second was the volume scatter node, and the third and the most important was the principal volume node. And in this node also, the 2 main functions are the color and the density option. And so now it's the time to use these concepts of the volume shaders in the retro gaming arcade scene that we started creating in the chapter number 1. So I've opened this file where we created this arcade machine along with some basic materials in the last 2 chapters of this course. And in today's chapter, we'll create some text to be added on the wall that will be behind this arcade gaming machine. And for that specific text, we'll use a material with the volume shaders. So to do this thing, let's first come back to the solid mode, select the plane, let's also go to the front or the side view, and I'll move it in the x-axis in such a way that the ends of the plane are close to the arcade gaming machine. Now press tab to enter the edit mode, press 2 for the edge select mode, select this edge, and we'll extrude it up in the z-axis. Then left click to finalize, let's change the angle, and on this particular face, we'll create a text with the principal volume material. But before that, let's increase the length of this face slightly more in the z-axis. So with the edge selected, let's move it up in the z-axis like this. Also, press A to select all, and let's also scale it up in the y-axis. Then left click, return back to the object mode, and now to add some text on this wall, let's first place our 3D cursor over here. So with the shift key holded, if I right click anywhere, then the position of the 3D cursor will get changed to that particular point. Now to add the text, press Shift plus A, then select text, let's change the angle, and first of all, we'll rotate it in the x-axis by 90 degrees. After this, let's also rotate it in the z-axis by 90 degrees, and now to edit the text, press tab to enter the edit mode, Let's also enable the wireframe display. Now press backspace to remove the default text, and now I'll type retro, then for next line press enter, gaming, then again press enter and type arcade. After this press tab again to return back to the object mode. Let's also enable the solid mode by clicking here, and now to change the way how the text is looking, like its font, the alignment, its size, we have to open the object data properties by clicking on this icon. So first of all, in the paragraph alignment, go to the horizontal option and change this to center. This will make the horizontal alignment of the text as per center. After this, click on font, and first of all, let's increase its size to something like 1.2, and to set a particular font, simply click on this folder icon. Then this menu will appear where you will find a variety of different fonts, and from all these, you have to select a particular font which according to you will look the best for the text object. For example, if I select this particular font and click on open font, then it will get applied to the text in the scene. Now moving ahead, let's also give some thickness to the text with the help of extrusion. So for this, in the object data properties, go to geometry and increase the value of extrude. So let's keep it to somewhere around 0.1 or 0.12. Let's also increase the size by going to font and transform, and I'll keep it to somewhere around 1.8 or 1.9, and let's also move it up in the Z axis. After this, if you want to give a more realistic appearance to the text, then in the geometry, you also have an option to control the bevel. In this option, if I increase the depth, then the bevel effect will increase, giving the text a realistic appearance. Then if you want to increase the space between the characters, then for this scroll down, and in the paragraph, you have the option to control character spacing, word spacing and line spacing. So in the character spacing option, let's increase this value to somewhere around 1.1 or 1.15, which will help us to increase the spacing between different characters. Also, if you wish, you can try to change the values of the bevel depth or maybe the extrusion as per the text in your scene. And after all this, we'll now create a volumetric material for the text. So go to the render preview mode, and to create the material, let's go to the material properties, click on the new button, select the principal BSDF node, press X to delete. Now press Shift plus A, then go to shader and select the principal volume node. Let's place it over here, connect the volume socket to the volume in the material output node. Then we'll increase the density value to something like 50 or 60, and in the color, let's change this to the red color. Let's also increase the brightness from here, and right now, after applying the material, it looks like the text font is not perfect. So to solve this problem, let's go to the font, and to change it, click on the folder icon again. Then from this folder, we'll select some other font that will actually look good according to the volume shader, the amount of bevel and the extrude value. Also, I'll reduce the character spacing back to 1 for the new font. So try to play around these values in the text object, try searching for different fonts for the text in your scene. After all this, you can go to the shader editor and change the density value to see the change in the volumetric material. Similarly, also try to change the color of the material in the principal volume node. But for now, I have selected the red color and the density value set at 50. After this, I'll also adjust the bevel depth, and we'll keep it to somewhere around 0.07 or 0.08. And now it looks perfect. So in today's chapter, we learned about the volume shaders and even used them to create a very basic material for the text that we added in the scene. So I've opened this file where we added this Suzanne object to understand about the principal volume node, but right now I will hide this object, and let's also unhide the plane and the UV sphere. Select the UV sphere, and I'll remove this red glass material that we created in the previous chapters. Now to begin with, the first topic for this chapter is understanding about the emission node. So in the shader editor, click on the new button, select the principal BSDF node and press X to delete. Now press Shift plus A, then go to shader, and in this list, select the emission shader. We'll place it over here and connect the emission socket to the surface socket in the material output node. Now as the name suggests, this node is basically used to create an emission or a glowing material to be applied on the object. We also understood about the emission settings in the principal BSDF node, where you have this option which is called the emission, from where you can control the emission color and the emission strength. Similarly, in the emission node also, we have these two options, where the first one is the emission color, which allows to set the color of the emission or the glow, and then you have the emission strength, using which you can control the strength of this emission. Now moving ahead, the next topic that we have on our list is the blackbody node. To understand about it, go to the shader editor, then press Shift plus A, and this time, instead of using the shader menu, we'll open this converter menu. And in this list, the first one that we have is blackbody. So I'll select this, place it over here, and in this node, you can see that as an input, it takes temperature, and as an output, it gives color, which in simple words means that it provides the color depending upon this temperature value. So if I take this color socket in the blackbody node and connect it to the the color socket in the emission node, then now both will get connected, and this color socket will now take the input of color from the blackbody node depending upon the temperature value. Also, I'll reduce the strength in the emission to around 1 or 2, and now you can see in this image that how different temperature values will give you different emission colors, and you can also check the same thing by increasing the temperature value in the blackbody node. By default, this value is equal to 1500 Kelvin, but suppose I type a very high number like 15,000, then in this case the emission color will look like this. So if you want to have an orange or yellowish color, then you can keep the temperature value to around 1500 to 3000 Kelvin. So to conclude, the blackbody node basically converts the blackbody temperature into color, and it is used to create materials that emit light at natural occurring frequencies. Now moving ahead, after understanding about these two nodes related to emission, we'll now understand about the glass BSDF. So for this, I'll first select the blackbody and the emission node, press X to delete. Now in the shader editor, press Shift plus A, then go to shader and select the glass BSDF. Let's place it over here and connect the BSDF socket to the surface in the material output. And as expected, we have this material on the UV sphere which looks similar to the glass. Now this glass BSDF node is very similar to the transparent BSDF about which we learned in one of the previous chapters. This one also created a transparent looking glass-like material. However, the special thing that we have in the glass BSDF node is the IOR value, which is the index of refraction. So for those of you who don't know, refraction basically means the bending of light when it travels from one medium to another, and for every object like glass, water or air, the value of index of refraction is different. But in transparent BSDF node, you don't have any option to control this value of IOR, and as a result, it takes the default value of IOR, which is equal to 1, and this value is basically for air, and that is why when we connect it to the material output node, it looks completely transparent just like air. But to create realistic looking glass material, it is advisable to keep the IOR value to somewhere around 1.3 to 1.5. Then in the glass BSDF node, we also have this option to control the color, and you can use it to simply change the color of glass. Then by using the roughness value, you can set the roughness of the material. If I increase it to the maximum value of 1, then it will no longer look like glass, but if I reduce the value of roughness, then we'll begin to get a glass-like material. Then you can also adjust the IOR value, which is the index of refraction, depending upon which particular material you wish to create with the glass BSDF. But as I told you before, to get a material which actually looks like glass, always keep this value to around 1.3 or 1.4. And with this, we have now learned about all the three topics of different shaders for this chapter. But before moving forward, if you wish to download this Blender file with all the materials that I created and saved in this file throughout this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to use some of these nodes that we understood today in the retro gaming arcade scene that we started creating in the chapter number 1. So I've opened this file where we created this simple scene with this arcade gaming machine, some text with the principal volume material applied, and a simple background. And if you remember, while applying the materials on this machine, we created this yellow emission material with the principal BSDF node. But now that we have learned about the emission shader, so we'll be changing the principal BSDF node that we previously added to the emission shader. So to do this thing, go to the material properties and check for that material that you created for the emission material. Then go to the shader editor, select the principal BSDF node and press X to delete. Now press Shift plus A, then go to shader and select the emission shader. We'll place it over here. Now connect the emission socket to the surface in the material output node, and in the color, you can choose any color that you wish to assign for emission. Then in emission strength, we'll enter a value of around 2 or 3, and in this way, we can use the emission shader instead of the principal BSDF node to create the glowing materials. Also, if you think that the amount of glow in this emission material is not very high, then for this, we have to use a special feature which is called the bloom settings in compositing. So to understand how it works, we first have to render an image of our scene. So let's go to the camera view by pressing 0 on the numpad, then click on this lock button to enable the lock camera to view and change the camera view according to the scene. After adjusting the camera view as per the scene, we have to render this image. So click on the render button and select render image. Now the rendering will begin, but for now, we'll close this window, and to work on the bloom settings in compositing, you have to open this compositing workspace. For those of you who don't know, compositing is basically used to enhance an image or an animation with the help of the node systems. So to use it, first enable the use nodes by clicking here, and now to add the bloom node to get the glowing effect, press Shift plus A, then go to filter and select the clear node. Let's place it over here in between the render layers and the composite node. Then click here and change the glare type to bloom. Now in order to see the effect of this node on the image, we have to use the viewer node. So press Shift plus A, then go to output and select the viewer node. Let's place it over here and connect the image socket in the clear node to the image socket in the viewer node. And after this, you will be able to see this particular image that we rendered as the background in the compositing workspace. But yes, if you are not able to see this image, then do ensure that this backdrop option is turned on in this workspace. Also, it might be possible that if you are using the compositing feature for the very first time, you might not understand some of the things that I am doing over here. In that case, I would advise you to watch these chapters of the Blender Master Course series that I previously created in order to understand about the basics of compositing. And now moving ahead, in this clear node, we'll change the quality from medium to high, and to reduce the glowing effect, simply go to the mix value and try to reduce it to somewhere around minus 0.8 or maybe minus 0.85, and now the glowing effect looks perfect. Let's go back to the layout workspace, and in order to see the same bloom effect in the 3D viewport also, simply click here and in the viewport shading menu, go to compositor and change this from disabled to always. By doing this, you will be able to see the glowing effect while being in the 3D viewport. So whenever you're working on some emission materials and you wish to add a glowing effect to the material, then you can use the compositing workspace, then simply add a clear node and adjust the mix value with the bloom selected. And with this, we have now arrived to the end of this chapter. Today we learned about some new material nodes, and then we also used this emission node practically in this scene in order to create the glowing effect. So I've opened this file where we created this particular material with a glass BSDF node, and if you want to download this complete Blender file with all the materials that I save throughout this course, then you can join the Patreon, whose link is added in the description of this video. And now the first thing that we'll do in this chapter is to understand about the Ray Portal BSDF node, and for this purpose I will hide both the UV sphere and this plane from the scene. So with both of them selected, press H to hide them, and now we'll add a plane in the scene. So press Shift plus A, then go to Mesh and select Plane. Now to apply the Ray Portal BSDF node on this plane and to understand how it works, I'll go to the shader editor, click on the new button, select the principal BSDF node, press X to delete. Now press Shift plus A, then go to shader and select the Ray Portal BSDF. Let's place it over here. Also, this particular node can only be accessed in the Cycles render engine. So do ensure that in the render engine, you have selected Cycles and not EV. Now if I take this BSDF socket in the Ray Portal BSDF node and connect it to the surface socket in the material output, then you will notice that this material on the plane is kind of looking transparent. In fact, if I go to this color option and try to change the color, then by using this option, we are able to change the color of material. But in reality, the Ray Portal BSDF node is used to create portals in your scene. Now you must have watched in movies that there is a magical portal through which you can see a completely different place or a scene. And the same thing can be created in Blender also with the help of the Ray Portal BSDF node. To make you understand this in a better way, I will add a UV sphere in the scene. So in the add menu, select the UV sphere. Now it might appear that this plane is completely transparent after adding the UV sphere. But for now, I'll move this plane up in the Z axis by 2 meters. After this, if I try to change the angle, then currently we are able to see through this plane. However, suppose I move this plane in the X axis by 3 meters, and now I want that this particular plane should act like a portal, and when I see through it, I should be able to view the UV sphere. And this particular purpose can be achieved by using the Ray Portal BSDF node. But for that, we need to change the position value. So to do this thing, while being in the shader editor, press Shift plus A, then go to Input and select the Geometry node. We'll place it over here, and right now, we have not yet learnt about any of these sockets in the Geometry node. But in spite of that, you can see that the first socket in this node is the Position socket. And as a result, if I connect this socket to the Position socket in the Ray Portal BSDF node, then it basically means that this Geometry node is now acting as an input for the Ray Portal BSDF node, because it will tell the default position of this plane to this Position socket in the Ray Portal BSDF node. However, in order to see this UV sphere, which is placed minus 3 meters away in the X axis, we don't need the default value of position, but instead make some changes in it. And for this purpose, we have to use another node which is called the Vector Match node. To add it over here, press Shift plus A, then go to Converter and select the Vector Match node. We'll place it in between the Geometry node and the Ray Portal BSDF node. And now what it basically does is that it takes two vector values, the first vector which is connected to the Position socket, and the second vector whose values can be controlled by these three numbers. Then after that, whatever operation you select from this list will get applied to both of these vectors, and then the result will be given as the output by this vector socket to the ray portal BSTF node. Now this might be a little complex to understand if you're learning about the vector math node or the geometry node for the very first time. So to revise everything, we first added the ray portal BSTF node in order to create a magical portal with this plane through which you can see any object present at some different part of the scene. Then to tell this node the particular position where that specific object is present, we first added the geometry node and used the position socket in order to get this particular position where we are having this plane in the scene. After this, to adjust this position according to the UV sphere, we use the vector math node, and now we learn how we can use this node to set the position as per the UV sphere. So for this purpose, first we have to understand the exact position of this plane, and to know the position of this plane, simply open the object properties by clicking here, and in the location you can see that it is 3 meters away in the x-axis and 2 meters away in the z-axis from the world origin. But if I select this UV sphere, then right now all the values in the location are 0 meters, indicating that currently it is placed at the world origin, which also means, in other words, that this particular UV sphere is placed 3 meters in the negative direction of the x-axis and also 2 meters in the negative direction of the z-axis. And yes, if you ever get confused in whether you have to take the positive value or the negative value, then you can use this view manipulation widget, which indicates the positive and the negative x-axis, similarly the direction of positive and the negative y-axis, and also the positive and the negative z-axis. And right now it is clearly indicating that the UV sphere is in the negative x-axis and the negative z-axis with respect to the plane. Then to know the exact positions, we used the location values of the plane and the UV sphere, and now we have to put these exact values that we calculated along with the direction in this vector math node with the AND operation. So in this node you can see that for the second vector we are having these three options, where the first one is for the x component of the vector that you want to add. Similarly, the second is the y component, and the last one is the z component. So in the first one I'll enter -3, then for the second one I'll keep the value to default 0, and now without even adding the z component in the vector, if I try to change the angle, then you will notice that we are able to see that UV sphere that is currently placed at the world origin through this plane. And basically this is how the ray portal BSTF node works. It simply creates a portal which allows you to see any object present at some other part of the scene. In fact, if I select the UV sphere and press G to move it, then you will notice the same changes being applied in the portal also. But for now, I'll click the right mouse button to get the default position of the UV sphere. Now to understand about this concept of the ray portal BSTF node in even more detail, we'll be adding some more objects in the scene. So press Shift plus A, then go to Mesh and first select a cube object. Press G to move it in the x-axis by 5 meters. After this, press Shift plus A again, and we'll now add a cone object. Let's move it in the y-axis by 4 meters. And in the end, let's also add a torus object in the scene. So in the add menu, go to Mesh and select the torus. Press G to move it in the y-axis by 8 meters. Now press 7 on the numpad to go to the top view, and right now here we are having this plane which is acting like a portal and is therefore allowing us to see this UV sphere. But suppose I want to view this cube now. So first of all, I should be knowing the position of this cube with respect to the plane. So in the object properties, we can see that its location in the x-axis is 5 meters, whereas if I select the plane, then its position in the x-axis is 3 meters, meaning that there's a difference of 2 meters in the location in x-axis. Also, to check the direction, you can use this tool where you can see that this particular direction is the positive x-axis. As a result, I'll go to the vector math node, and in the x value, I'll begin to increase it from -3 to +1, which was basically the difference between the location values of both the objects in the x-axis. Now in a similar way, if I want to view this cone that we have placed 4 meters away in the y-axis, then for this, with the plane selected, first check the location in the x and the y-axis, which are 3 meters and 0 meters respectively. And for the cone, the location is 0 meters in the x-axis and 4 meters in the y-axis. Therefore, the difference will be -3 meters in the x-axis and +4 meters in the y-axis. So I'll go to the vector value, and in x-axis, I'll type -3, and in the y-axis, I will enter 4. Now let's change the angle, and with this, we are able to see this cone that we placed over here through this plane or the portal. In fact, if I try to change the angle, then at some distance in the portal, you will also notice this torus object placed over here. In a similar way, if I change the angle from here, then you will observe this particular UV sphere that we placed at the world origin. In fact, you can even increase the size of this portal by pressing S, and in this way, you can increase the size of the portal Now before moving forward, I will again repeat that there's a high possibility that some of you might not be able to understand about the working of this node properly even after having so many examples. But that's completely normal because unlike the other shader nodes which simply added a material on the object, this ray portal BSTF node gives a very complex result, resulting in the formation of portals. So if you couldn't understand about any particular concept related to this ray portal BSTF node, then I suggest you watching that particular part in this video to properly understand it. But again, as a summary or a recap, I will repeat it to you that first of all, the function of ray portal BSTF node is to create portals from where you can see some other part of the scene. Then you have to tell the position to the ray portal BSTF node with the help of geometry node and the vector match node. We use the geometry node to define the default position of this plane or the portal, and then for the object's position, we use the vector match node with the add operation, and in these values, you basically have to tell the position of the object with respect to the plane, like how much far it is in the x and the y axis and in which particular direction. And yes, this vector match node is also having the option to change the z axis, and if I try to change it, then here we see that we are able to move up and down in this portal. And after all this, we have now understood about the functioning of the ray portal BSTF node. And so let's use this node in the retro gaming arcade scene that we started creating in the first chapter. So I've opened this file with the retro gaming arcade scene, and in the last chapter we used the compositing settings to create the glowing effect for the emission material on the gaming machine. And in today's chapter, we'll try to create a simple portal and then we'll place it at different positions trying to get a view of the scene. So to begin with, let's first add a circle in the scene. But before that, let's place the 3D cursor back to the world origin. So press Shift plus C, and now to add the circle, press Shift plus A, then go to Mesh and select the circle. Let's move it in the y-axis and place it over here. Now rotate it in the y-axis by 90 degrees, and let's also move it up in the z-axis like this. Now press tab to enter the edit mode, and with all the edges or the vertices selected, we'll scale it up in the z-axis like this in order to create a portal which looks like a mirror. Press S to scale it up even more, and after this, press F to fill the faces, and let's also give it some thickness. So for this, press E to extrude it backwards in the x-axis. After this, press 3 for the face select mode, select this face, press I to insert it, and left click to finalize. Now return back to the object mode, go to the modifier properties, click on add modifier, and in the generate, select the bevel modifier. Let's increase the number of segments to 4, and let's keep the amount to somewhere around 0.08 or 0.1, and after this, we'll be applying two different materials to the portal. So first of all, go to the shader editor and create a new material, and in this one, I'll change the base color to dark blue. Let's also reduce the brightness from here, and yes, if you want, you can set any particular color that you wish to apply for the main body of the portal or the mirror. After this, let's also increase the roughness value to around 0.8 or 0.9, and with this, the main body of the portal is completely ready. And so now it's the time to use the ray portal BSTF node in order to create a portal for the front face. So for this, go to the material properties, and we'll be creating a new material by clicking on the plus icon and then click on the new button. To apply this material that we just created, press tab to enter the edit mode, and with the front face selected, click on the assign button. After this, return back to the object mode, and to create the portal, go to the shader editor, select the principal BSTF node, press X to delete. Now press Shift plus A, go to shader, and select the ray portal BSTF node. Let's place it over here and connect the BSTF socket to the surface in the material output. And after this, if I try to change the angle, then you can see that by default, we are seeing the back part of the face on which we have applied the ray portal BSTF material, and currently the back part of the portal is having this material.008 that we applied to the body. So to solve this problem, go to the solid mode, press tab to enter the edit mode, and now we also have to select the face at the back of this portal in order to apply this material.009 with the ray portal BSTF. So let's change the angle, and we have to select this face at the back. But to do so, I'll return back to the object mode, select this plane, press H to hide it, and now we'll select this portal, enter the edit mode, select this face at the back, go to the material properties, select the portal material, and click on the assign button. After this, return back to the object mode. Let's also unhide the plane by clicking on this I button. Let's also go back to the solid mode, and now if I change the angle, then we are able to see the plane with the green material through this portal. In fact, if I try to move it by pressing G, then we are even able to see through other objects in the scene. But right now, we need to make some changes in the shader editor in order to see this machine that we have placed here inside this portal. And for this, let's first add the geometry node in the shader editor. So press Shift plus A, then go to input and select the geometry node. Let's place it over here, connect the position socket to the position in the ray portal BSTF. After this, to set the position according to this gaming machine, let's add a vector math node. So press Shift plus A and click on vector math. Let's place it over here in between the geometry node and the ray portal BSTF. And right now, if you notice closely, this machine is placed in the negative y-axis direction with respect to the portal. And also, if I go to the solid mode and then to the top view, let's also zoom out, then you can see that in order to get a view of this machine from the front, we also need to set the vector position in the positive x-axis. So to do this thing, without entering the exact values, let's switch back to the rendered preview mode, then go to the vector math node, and in the add function, we'll first reduce the second value, which is for the y-axis. So let's keep on reducing it until we begin to see some part of the machine inside the portal. Also, let's go to the front or the side view, and for now, I'll set the value of vector in the y-axis to somewhere around -2. Then in the x-axis, I'll increase the value of vector to somewhere around 4 or 5 until we begin to see the gaming machine a bit more in the portal. Let's also adjust the x-axis value to somewhere around -2.5 or -3, and once you have adjusted the values in the x and the y-axis, you will have this portal in which we can view the gaming machine that we just created along with the other things. For example, if I try to change the angle, then here you can see that inside the portal, we are also able to view this text which is present over here in the gaming arcade scene. Also, if you want to increase the size of the portal, then simply press S to scale it up, and by doing this, we are able to see inside the portal in a much better way. Let's also move it slightly upwards in the Z axis like this. And one more thing, if I change the angle like this, then in this portal, you can see that over here, we are having this machine, but on this right side, we have this mirror effect created because it is also showing its own image inside the portal. And this thing will keep on repeating itself because, as I told you before, it is exactly similar to what a mirror does in real life. The only difference is that you get to choose that which particular view will be mirrored depending upon the vector values. Now one last thing, I will move this portal in the y-axis by 3 meters, and after this, because of changing the value of the location, we also have to change the value of the vector in the vector math node. And since I have moved it in the y-axis by 3 meters, I'll go to this value which is -3.5 and will change this to -6.5. After this, I'll change the angle, and we can again see our entire scene in this portal by changing the angles. And with this, we have now arrived to the end of this chapter. Today we learnt about the Ray Portal BSTF node and its practical usage in the retro gaming arcade scene. So in the last chapter, we learned how to create a portal with the help of the Ray Portal BSTF node, and that's why we added all these objects in the scene. But for now, I'll select all of them by holding the shift button, and we'll delete them by pressing X. After this, go to the scene collection and we'll unhide the plane and the UV sphere. Now press 0 on the numpad to go to the camera view, and with the UV sphere selected, let's remove this material and create a new material. And finally, we can move to the first topic of this chapter, which is the RGB node. So to add it, press Shift plus A in the shader editor, then go to input and select the RGB node. Let's place it over here. And now this node with the name RGB, meaning the red, green and the blue channels of colors, allows you to input any particular color with the help of this color wheel and the brightness slider. Now this thing is exactly similar to the option of changing the color that you get when you click on the base color in the principal BSTF node. We have this color wheel and the brightness slider, which is exactly the same as the RGB node. In fact, over here you can see that we even have an option to select the RGB, where we can control the different components of the red channel, the green channel of the color and the blue channel. And for those of you who don't know, all of these colors can be represented by different values of the red, green and blue channels of the color, which also means that on changing these values, we'll get different types of results each and every time. And basically this is the use of the RGB option in colors. In a similar way, I can connect the color socket of the RGB node to the base color in the principal BSTF, and now I can use this particular color wheel and the brightness slider in order to tell the principal BSTF node that which particular base color should be applied as the material. Now you might be thinking that exactly what is the benefit of using this node when you can directly use the base color option within the principal BSTF node, and the answer to this is that while working on a complex system of nodes where you have multiple nodes connected together, then you may require the same color to be connected to different sockets, and in this case you can set the color by the RGB node and then connect this color socket in the RGB node to multiple different sockets. So even though this RGB node is very rarely used in Blender, but still it can be useful when you have to use the same color in multiple sockets or nodes. Moving ahead, the next topic that we have on our list is understanding the hue saturation value node. So for this, go to the shader editor, press Shift plus A, then go to color, and in this category, select the hue saturation value. We'll place it over here, and now let's understand the use of this node. So you can see here that this node is having a color socket as the output, which means that we can use all these parameters in the hue saturation value node and get the result in the form of a color. Now for those of you who don't know, hue saturation value can also be written as HSV, and this is basically a color model which can be used to define any particular color that you want to apply to a material just by using the different values in the hue parameter, saturation parameter, and the value parameter. To understand this thing in more detail, you can look at this image where it's clearly visible that as the value of hue changes, the color will change. Then as the value of saturation changes, the color will turn from white to that specific color, and similarly, the value will change the color from black to the specific color. Now let's use this concept practically also. So I'll connect the color socket in the hue saturation value node to the base color in the principal BSDF. And by doing this, we are getting the white color because right now we have entered the default values. But even if I try to change this value of hue, then still we are not able to see any change in the color of the object's material. And to fix this issue, click here in the color parameter, and with the HSV selected, change all the three values to 1. After this, if I try to change the hue value to somewhere around 0.6, then you will begin to notice the change in color. Similarly, if I keep on changing this value, then you will notice different colors being applied to the UV sphere. So by changing the value of hue, you can change the color. Then in the saturation value, if I enter 0, then we'll get completely white color, and as I begin to increase this value of the saturation, the amount of yellow color will begin to increase. After this, in the value parameter, if I enter 0, then the object will turn black, and if I slowly increase this value, then you can see how the brightness of the color will keep on increasing. So in simple words, first you have to set any particular color in the color parameter, then by changing the hue value, you can change that color, then you can increase or decrease the saturation, and you can also use the value parameter to control the brightness of the color. But yes, in most of the cases, the hue saturation value node is used while working with textures like image texture or the brick texture, because it will allow you to change the color of that particular texture. But till now, we have not started our understanding about the textures, and therefore, we'll again understand about this node while understanding about the different type of textures. But for now, we should move to the next topic of this chapter, which is the brightness contrast node. To add it here, press Shift plus A, then go to color and select the brightness contrast. Let's place it over here, and as the name suggests, this particular node is used to control the brightness or the amount of contrast of a particular color. You can see that it takes the color as the input, then by using both of these parameters, you can control the brightness and the contrast, and then it will give the resultant color with this output color socket. So simply, if I go to the brightness value and try to reduce it, then the object will turn black, but if I try to increase this value of brightness, then we'll get a bright white color. But for now, I'll reduce the brightness value down to 0 in order to get the original yellow color. Then you have the contrast option, and if I try to increase this value, then the amount of contrast in the color will increase, but if I try to reduce it, then the amount of contrast will reduce. And just like the hue saturation value node, this node is also used mostly in the cases when you want to change the brightness or the contrast values of the colors of textures. And now the next one that we have on our list is the gamma node. To add it here, press Shift plus A, then go to color and select gamma. Let's place it over here. Now this node allows you to control the brightness of the color at the midtone regions, meaning those areas where you don't have too much light or even complete darkness. So if I try to change the gamma value in this node, then you will notice that the brightness of color will begin to change, and at the maximum value, the yellow color looks something like red. So whenever you have to adjust the brightness in the midtone areas, you can use the gamma node. And with this, we have learnt about these 4 very simple nodes that can be used to change the way your colors look on the materials of an object. And yes, if you want to download this particular Blender file with all the materials that I saved in the material asset library, then you can join the Patreon by using the link given in the description. And now it's the time to use the concept of these nodes in the retro gaming arcade scene that we started creating in the chapter number 1. So we have created this scene with the portal, the gaming machine, this text with the principal volume BSDF node applied, and a simple background that we created with a plain object. And now let's understand the concepts that we just understood practically also by making some changes in the materials of this scene. So first of all, I'll select this machine, then in the material properties, I'll select this purple material which is for the body of the gaming machine, and now we'll add the the RGB node which will be used as the input for the base color. So in the shader editor, press Shift plus A, then go to input and select the RGB node. Let's place it over here and connect the color socket to the base color. After this, we'll notice a color change from the purple to the grey color. Then by using this color wheel, I can set any particular color that I want to apply as the base color for this material. Then by using the brightness slider, I'll adjust the brightness of the color as per the scene. After this, suppose you want to increase or decrease the brightness of this color that we have applied, then go to the shader editor, press Shift plus A, then go to color and select the brightness contrast node. Place it in between the RGB node and the principal BSDF node, and by using the brightness value, you can adjust the brightness of the color that is applied over here. The color will turn grey or white on increasing the brightness, and if I try to reduce it, then you will get a dark color which looks black. In a similar way, you can also use the hue saturation value node to change the color, but in this case, it's not required because you can directly change the colors from here. Similarly, if you want to adjust the gamma value, then you can use the gamma node in the shader editor. But for now, we'll not be making any further changes in the scene. And yes, all the 4 nodes that we discussed in this chapter might not seem very important at this moment, but once we understand about the concept of textures in the upcoming chapters, you will get to know the actual importance and usage of these color nodes. Also, before ending this chapter, I would like to tell you about an important concept related to the colors, and for explaining this concept, I will make the use of the RGB node. In this node, you can see that we are having a color wheel, and some of you might think that the placement of these colors is completely random in this color wheel. But in reality, this is not true, because the position of these colors in this color wheel actually define a lot of things. For example, the colors on the opposite side will always give the best look together because of their contrasting effect. For example, if I take the green color, then on its opposite side we are having the purple or the pink color, and in the scene also you can see that the green color of the plane and the purple color of the gaming machine are in perfect contrast, and as a result this color combination actually looks good. However, if I change this color to something like yellow, which is placed very close to the green color, then in this case both of these colors are not looking complementary to each other, and as a result the combination of these two colors is not very eye-catching. So you should remember this, that while using the color wheel, do consider choosing the complementary colors or the colors which are on the opposite side in order to get the best possible combination. And with this, we have now completed all the topics of this chapter. So I've opened this file where we created this layout and understood about different types of nodes in the previous chapters. But in today's chapter, our first topic will be to understand about the image texture. And for this, go to the shader editor. Let's delete all of these nodes by pressing X, and to add the image texture, press Shift plus A, then go to texture, and in this list, select the image texture. Let's place it over here. Now this particular node, which is the image texture, is used to apply any particular image that you have saved in your PC to any object in the scene. Now there are plenty of websites from where you can download the image textures, but even if I simply search on Google for some image textures, then it will display a variety of different images which you can use as the texture for your object. For example, if I want to apply this particular image as the texture on the object, then I'll visit this website, select the particular image, and will download it by clicking on the download button and selecting the resolution. After this, the image will begin to download, and I'll also drop the link of this image in the description of this video so you can download the image from there. Also, it is advisable to use websites like pexels.com or Pixabay in case you are searching for some very simple images to be used as a texture. I've reopened the Blender file, and to use that image that we downloaded as the texture on the UV sphere, go to the image texture node, click on the open button, select that particular image that you want to apply as the texture, then click on open image. Then after this, take the color socket and connect it to the base color in the principal BSDF node. And by doing this, you will notice that particular image applied as the texture on that particular object. In fact, you can still change the metallic value in the principal BSDF node if you want to make the surface of the material with the image texture more metallic. You can even control the roughness value, and basically this is how you can use any image as the texture to be applied on any object in the scene. Now this was one way of applying the textures as the material on an object, but in Blender you also have some pre-existing textures like the brick texture, noise texture, magic texture, and a lot more. You can use them and even modify them to create different types of materials. And to begin with your understanding, we'll move to the next topic of this chapter, which is the checker texture. So to add it over here, press Shift plus A, then go to texture and select the checker texture. Let's place it over here and connect the color socket to the base color. Now, as the name suggests, this particular node added a checkerboard texture as the object's material, but it looks a little bit strange because they are using it on a UV sphere, and by default, this texture is not taking the UV map into consideration. So to solve this problem, we have to use a node which is called the texture coordinate node. Now take the UV socket and connect it to the vector in the checker texture. After this, let's go to the scale value and increase it to something like 20, and now we are able to see the checker texture properly applied on the UV sphere according to the UV map. So in simple words, we use the texture coordinate node as the input for the vector socket to tell the checker texture node that we want to apply it as per the UV mapping. After this, we also have some options of changing the colors, and the first color, which is white, is for all these squares which are white in color, and the color 2 is for all these squares which are grey or black in color. So if I go to the color 1 and try to change it to the red color, then the texture will look like this. And similarly, if I go to the second color and try to change it to the blue color, then the texture will look like this. So first of all, you can change the scaling of the texture with the help of the scale value. Then by using the color 1 and the color 2, you can define the particular colors for the checker texture. In fact, in the texture coordinate node also, you're having several options like the generated, normal, UV, object, and all of these will change the way how the texture will get applied on the object surface. Out of these 7 sockets, the most important are the first 4, and you can try connecting each of them with the vector socket to see the changes in the texture applied. Also try to adjust the scale value to notice the changes in a better way. In a similar way, I'll take the normal socket also and connect it to the vector to see how it looks. Similarly, the object socket also, and this is how it looks. But for now, I'll take the UV socket and connect it to the vector, and let's also change the scale value to around 20. And now let's also use this checker texture node on some other object like a cube in the scene. So for this, let's first go to the solid mode. Now press Shift plus A, then go to mesh and select cube. Press G to move it and place it over here. Now let's go to the render preview mode, and with the cube selected, we'll apply the same material that we have applied to the UV sphere. So the name of this material is material.004. So with the cube selected, click on this icon, and from this list, I will select the material.004. And with this, we are now having the same material applied to the cube. In fact, if I try to use the generated socket in the texture coordinate node and reduce the value of scale, then you can see here that even though the texture applied on the UV sphere is not completely perfect, but it is not the case with the cube. Similarly, if I take the object socket and connect it to the vector, then in this case also, the texture applied on the UV sphere is not perfect, but the one applied on the cube looks completely fine. And in most of the cases, you will notice this checker texture being applied on flat surfaces like a plane or a cube. But even if you apply this texture on a UV sphere or some similar object, then you can use the UV socket in the texture coordinate node in order to get a perfect texture. Moving ahead, the next topic of this chapter is to understand about the brick texture node. But before that, I will remove the checker texture from here. So press X to delete. Now press Shift plus A, then go to texture and select the brick texture. Let's place it over here and connect the color socket in the brick texture to the base color in the principal BSDF. Now it will look a little bit complicated for both the UV sphere as well as the cube. But to solve this problem, simply take the UV socket in the texture coordinate node and connect it to the vector in the brick texture. And by doing this, we have the brick texture applied on both the objects. Now as the name suggests, this particular node will apply the texture of these bricks on the object, and in this node we also have many different options to change the way how the texture will look. For example, the first useful setting is the offset value, which is by default set to 0.5, and this value will determine the brick offset of different rows. To understand this thing in even more detail, I'll change this value of the offset to 0, and by doing this you will notice that all the bricks are now having the same starting point. But if I begin to increase this value of the offset, then every other brick will have a certain distance with respect to the other brick in the corresponding rows. So if you want to have all the bricks starting from the same line, then simply set the value of offset to 0 or positive 1. But if you want them to start from alternative ends, then you can keep this value to 0.5. After this, the next useful setting is the color of these bricks. The color 1 will change all the bricks that are currently having the white color. Then the color 2 will change all the bricks that are currently having this grey color. So if I take the color 1 and change this to the blue color, and similarly I'll take the color 2 and will change this to the yellow color. And by doing this, we get a brick texture which looks like this. Now you might feel that even though you chose the blue and the yellow colors for the brick faces, we are still getting some different colors on most of these faces. And the reason behind this is that for each of the brick, the color will basically be a different combination of the color 1 and the color 2. As a result, some of the bricks are light blue in color, some are completely yellow, Some are purple colored, so the color 1 and the color 2, which is the blue and yellow color, will blend together to give different color combinations. But in most of the cases, the brick texture is used to create realistic looking brick-like texture with a combination of red and orange color. So in the color 1, if I take this pointer of the color wheel to the red color, and then for the color 2, if I change this from yellow to something like orange, then in this case we get a texture which somewhat looks like the brick texture. After this, the next important setting that you have in this node is the color of mortar, and this will define the color in between any two bricks in the texture. For example, if I go to the mortar color and increase the brightness, then the color between each pair of bricks will change to the white color. Similarly, you can set any other color that you like to use as the mortar color. But for now, I'll reduce the brightness to make this color darker, and now it looks perfect. Then the next important option is the scale value, and as the name suggests, it is used to control the scaling of the texture applied on the object. If I increase the value of scale, the number of these bricks on the texture will increase, but if I reduce it to something like 5 or 6, then the number of these bricks will reduce. Similarly, the mortar size will control the size of the stack area in between each pair of tiles, and by default its value is set to 0.02, which actually works great in most of the cases. Then the next one is the mortar smoothness, and if I increase it, then the dark area in between each pair of tiles will become smooth and appear like this. So if you want, you can control the smoothness of the mortar with the help of this value. Then the next option that you have is the bias, and this controls the amount of blending of the color 1 and the color 2. By default, its value is set to 0, meaning that there will be an equal blending of both the colors. But if I want more influence of the color 1, then I have to reduce this value to a negative number. For example, at -1, we have complete red color, which is also the color 1, and as I begin to increase this value, the influence of the red color will begin to reduce, and once it reaches +1, we'll be getting complete yellow color, which is the color number 2. But again, to get a balanced color, it is advisable to use 0 as the value in the bias option. Then the last two are the brick width and the row height, and obviously the brick width will control the width of the brick, so if I increase it, the width will begin to increase, and similarly, the row height will control the height of the tiles. So you can try to adjust these values in order to get a different type of result each and every time. But for now, I'll change this to the default value, which is 0.5 for the brick width and 0.25 for the row height. And with this, we have now understood about the three important textures, which is the image texture, the checker texture, and the brick texture. And before moving forward, let's save this material that we created with the brick texture in the material asset library, which we created in the chapter number 1 of this course. So first of all, let's rename this material to brick, and after that, go to the scene collection, and in the sphere, select the brick material by left clicking on it, then right click and select mark as a set. And yes, if you want to download this Blender file along with all the materials that we have saved in this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to practically understand the nodes that we covered today in the retro gaming arcade scene. So I've opened this file with the retro gaming arcade scene, and the first thing that we'll do will be to assign the brick texture on this wall at the back. So for this, I'll first hide this portal that we created in the chapter number 5. So press H to hide it, then select the plane, and let's now create a new material. So go to the material properties, click on the plus icon, and now we'll be using that brick texture that we saved in the material library a few minutes ago. So for this, click here and select the asset browser. Then I'll take the brick texture by left clicking, drag it and drop it into this empty slot of the material. Then to assign this material to this background face, press tab to enter the edit mode, and with this face selected, select the brick material and click on the assign button. After this, return back to the object mode, and now it looks like this because we have to fix the UV mapping of this face according to the texture. And to do this thing, a very simple way is to enter the edit mode, and with the face selected, go to the UV menu and select unwrap. By doing this, we will notice the brick texture properly applied on this wall. But even after doing this, the rotation of the texture is still not fixed. So to solve this problem, we first have to go to the shader editor, and now we'll be understanding about a completely new shader node that we have not yet understood in this course so far, and the name of that node is the vector mapping node. This node will allow us to make the changes in the texture, like the location of the texture, the rotation, and the scaling. So to add the mapping node over here, press Shift plus A, then go to vector and select the mapping node. Now place it in between the texture coordinate and the brick texture, and if I try to change the rotation value in the z-axis, then you will notice that the brick texture applied on this background will begin to rotate. For now, I'll change this value of the rotation in the z-axis to 90 degrees, and now it looks perfect. Similarly, you can also try to change the scaling values in the different axes in order to see the changes in the texture, but currently I'll keep the scale values to the default one, and now we'll move forward to apply the checker texture on this bottom face. So for this, go to the material properties, click on the plus icon and create a new material. After this, to add the checker texture in the shader editor, press Shift plus A, then go to texture and select the checker texture. Let's place it over here, connect the color socket to the base color, and to apply this material to the bottom face, press tab to enter the edit mode, select this face, then in the material properties, select this material, click on the assign button, and by doing this, we now have the material with the checker texture applied on this face. Now in the color 1, I'll keep this to the default white. However, for the color 2, let's reduce the brightness because I'll set this color to black. Let's also change the scaling value. So let's increase it to somewhere around 10 or maybe 12, and now it looks perfect. By doing this, we have created a simple wall texture for the back face and also a checker texture for the floor. Moving ahead, we'll also be using some image textures to be applied on the different faces of this gaming machine. But to do that, we first need to get some images to be used as the image textures. So for this purpose, I searched on Google for some royalty-free game-related images and all the results came up. Let's first explore this pixabay.com website, and in this, we are having a number of different images, out of which some of them can be used for applying the textures. For example, here we have the image of Mario. So let's download this image by clicking on the download button, and I'll select the highest resolution and click download. Also, I will drop the link of this image along with all the other images that we'll download in this chapter in the description of this video. Moving ahead, let's search and download some more images. For example, I'll download this image also of this warrior. So click on the download button, select the resolution and click on download. Similarly, you can search for any image and download it if you think it will actually look good for a scene. Let me download this one also, which can be used for the screen showing the game over display. So let's download this, select the resolution, let's search for some more images. So let's visit some other websites also to get some different type of images. For example, we have the pexels.com, where again you will find a variety of different images that you can use for the arcade scene. For example, this particular image looks good, so I'll click on the download button, and after downloading it, we now have a sufficient number of images to be used as the image textures on our scene. So I've opened Blender again, and to apply the texture, let's go to the render preview mode, and let's first apply the texture with the game over image on this face of the gaming screen. So to do this thing, let's first create a new material. So go to the material properties, click on the plus icon, then click on the new button, and to add the image texture, press Shift plus A, then go to texture and select the image texture. Let's place it over here and connect the color socket to the base color. After this, to use that specific image, click on the open button, then open that particular folder where you saved the image, then select it and click on open image. After this, to apply this material on this face with the screen, press tab to enter the edit mode, select this face, then in the material properties, select the material with the image texture and click on the assign button. Then to adjust the UV mapping with the face selected, go to the UV menu and select unwrap. And by doing this, we are now able to see some part of the image being applied as the texture on this face. And to fix it properly, let's first go to the material preview mode for a smoother experience. And now we have to use the UV editor to fix this problem. So click here and change this window from the shader editor to the UV editor. Now press tab to enter the edit mode, and with the face selected, go to the UV editor, scroll down, and now here you can see that we are having these 4 points in the UV editor, which are nothing but the vertices of this face being placed on the image. So if I select both of these vertices, and after that, if I press G to move them, then you will notice that the image texture in the 3D viewport will also begin to change. To restrict the movement only in a particular axis, simply press X after pressing G, and now we'll get the horizontal movement. So right now, I'll place both of these vertices on the corners, and then if I have to rotate the image, so for this, go to the UV editor, press A to select all the vertices, and press R to rotate. By doing this, you will notice that the effect of rotation is also being visible in the image texture. Now if I press 90, then in this case, the image will get rotated, but in the opposite direction. So this time, let's rotate it by 180 degrees for the perfect rotation. After this, return back to the object mode, and let's also go to the render preview mode. Let's also change this window back to the shader editor. So click here and select the shader editor. Now you can see here that the effect of lighting is too high in this scene, and that's because of this emission material that we have applied to the gaming machine. So I'll go to the material properties, select the material with the emission, and let's reduce the strength to 1. And by doing this thing, we are now able to see the image texture applied on this face in a much better way. In fact, to give this texture an even better look, go to the shader editor, then in the principal BSDF node, go to emission and increase the emission strength to +1. Then take the color socket in the image texture and connect it to the color socket in the principal BSDF node. And by doing this, we have now applied a slight emission to this material, and the color that it takes for the emission will be the same colors as in the image texture. But if you look closely at this image, you will notice that the image is repeating itself. The first image ends at here, then we have the second image, and then the text for the third image is also being visible. And to solve this problem, let's again enter the edit mode, change this window back to the UV editor, press A to select all, and let's first scale it up in the x-axis. So press S and X and scale it up like this. After this, let's also scale it down in the y-axis by pressing S and Y and left click to finalize. So in simple words, we adjusted the size of the face formed by these 4 vertices according to the size of image. And with this, we are now having a perfect image texture applied on this face. If you want, you can even change the colors in this image by using the hue saturation value node about which we discussed in the previous chapter. So to add it here, press Shift plus A, then go to color and select the hue saturation value. We'll place it in between the image texture and the principal BSDF node, and let's also connect the color socket to the emission color. After this, if I go to the hue value and try to change it slightly, then you will notice the change in color being applied in the image texture. Similarly, if I further change this value of hue, then you will notice similar changes in the color of the image. So if you want, you can try to change the color of the image texture with the help of hue parameter in the hue saturation value node. After this, you can also adjust the saturation value, and in a similar way, you can also change the value parameter. But for now, I think that this image is looking perfect for the screen of the gaming machine. Now similarly, we'll also apply other images on the different faces of the machine. So for this, go to the material preview mode, click on the plus icon and create a new material. After this, go to the shader editor, press Shift plus A, then go to texture and select the image texture. Let's place it over here, connect the color socket to the base color, and to import the image, click on the open button. Now select that particular image and click on open image, and now to apply this material on this face, press tab to enter the edit mode, select the face, go to the material properties, select the material and click on the assign button. After this, go to the UV menu and select unwrap, and with this we now have image texture applied on this face. Then if you want to adjust the position of this image, then go to the edit mode, and let's also change this window from the shader editor to the UV editor. Let's zoom out, select these 2 vertices, press G and X and move them like this. Now return back to the object mode, and in a similar way, let's also apply one more image texture for this face. So let's go to the shader editor by clicking here, and let's also create a new material. So click on the plus icon, then on the new button, then in the shader editor, press Shift plus A, then go to texture and select the image texture. Place it over here, connect the color socket to the base color, and to import the image, click on the open button. Then select that particular image and click on the open image, and after this, to apply this image texture to this face, press tab to enter the edit mode, select this face, then go to the material properties, select the material slot and click on the assign button. After this, while being in the edit mode, go to UV and select unwrap. Then to adjust the position of image, we'll change this window to the UV editor. Now press A to select all, and we'll move this face in the x-axis according to the image of Mario. Let me select these 2 vertices also, and we'll move them in the x-axis like this, so that we only have the image of Mario on this particular face. Now return back to the object mode, and with this, we have now learnt about applying the image texture on the different faces of an object. Also, in the shader editor, you can go to the emission value and increase the strength to 1 and connect the color socket of the image texture to the emission color. Let's do the same for the material on this face also. So I'll select the material, go to emission value and increase the strength to +1. Then for the color, take the color socket in the image texture and connect it to the emission color. And with this, we have now completed the chapter number 7, where we understood about the working of 3 main textures in Blender, namely the image texture, the checker texture and the brick texture. Then we also use them in the retro gaming arcade scene. So I've opened this materials file where we created this brick texture in the last chapter, and right now let's start with the first topic of today's chapter, which is the gradient texture node. So to understand it, let's first hide this cube from the scene. So press H to hide it, select the UV sphere, and to create a new material, go to the material properties, click on the plus icon and then on the new button. After this, we'll have the default principal BSDF added in the shader editor, and to apply this material to the UV sphere, press tab to enter the edit mode, press A to select all and click on the assign button in the material properties. And now to add the gradient texture node in the shader editor, press Shift plus A, then go to texture and select the gradient texture. Let's place it over here and connect the color socket to the base color. Now to understand about the working of the gradient texture in the 3D viewport, I'll change the mode from the rendered preview mode to the material preview mode. By doing this, we are able to notice the difference in the texture in a much better way. Now the gradient texture node allows you to create a material showing the transition of one color into another, and by default we can also see that there is a transition between the black color and the white color in the texture applied. Now suppose you want to change the area of this black and the white color Then for this we have to use a node which is called the color ramp node. So press Shift plus A, then go to converter and select the color ramp. Now place it in between the gradient texture and the principal BSDF node. Now the color ramp node will allow you to control the different colors in the texture. Over here, we have two pointers. The first is the black pointer and the second is the white pointer. And if I select the black pointer by left clicking and drag it to move it like this, then you will notice that by moving this pointer, we are able to control the black color in the texture. In a similar way, if I take this white pointer and move it like this, then its influence will be observed on the white color of the texture. Now if you want, you can even change these colors from black and white to some other colors of your choice. For example, suppose I want to convert this white color into red. So to do this thing, with the white pointer selected in the color ramp node, click here and change the color from this color wheel. By doing this, we are able to make the texture in such a way that it shows the transition between the black color and the red color. Similarly, let's select the black pointer and change the color from here. So first increase the brightness with this brightness slider, and I'll change this color to the yellow color. With this, we are now having the gradient texture showing the transition between the yellow and the red colors. In a similar way, you can even add some more colors in this gradient texture. And to do this, simply click on this plus icon in the color ramp, and now we have one more pointer added in between the previous two pointers. Now with this selected, click here to change the color, and I'll change this one to the blue color. And in this case, we now have the gradient texture showing the transition of colors from the yellow color to blue, and then we have the red color. Also, the way how these colors will blend with each other can be controlled by the interpolation method selected. By default, the linear is selected, but if I change this to ease, then you might not notice much difference in the blending of colors. Similarly, if I change this to cardinal, then in this case also, you will hardly notice any difference in the way how these colors are blending. But if I change this to constant, then in this case, all these colors are no more blending with each other, but instead they are simply painted over the UV sphere depending upon the position of different pointers in the color ramp. But for now, I'll change this back to linear, and in a similar way, we can also change the gradient type from here. By default, the linear is selected, but you can try to change it to other types also in order to get different results. So to keep the thing simple, you can understand the gradient texture in this way, that this particular texture is useful to create transition of different colors, and to set those colors and their positions, we use the color ramp node. After this, let's now move to the next topic of this chapter, which is the noise texture. So for this, I'll go to the shader editor, select the gradient texture and the color ramp node, and press X to delete. Now press Shift plus A, then go to texture and select the noise texture. Let's place it over here. And now the noise texture is used to create textures with some noise or detailing added to them. To practically understand this, I'll first take the color socket in the noise texture and will connect it to the base color in the principal BSDF. Now we'll basically get this particular texture with some colors blending with each other, and then we have various controls using which we can change the way how the texture will look. For example, if I try to increase the scale value, then obviously the scaling of the texture will change. Similarly, if I try to change the detail value and increase it, then the texture will become more detailed, but if I reduce it, then now the texture will be less detailed. Then we have the roughness value, which will control the blending of colors with each other. If I reduce it to the minimum value of 0, then we'll have a smoother blending of colors, but if I increase the roughness value, then in this case we'll have a rough pattern or the blending of colors. Then we have the distortion, which will simply distort the texture that is created on the UV sphere. However, in most of the cases, instead of connecting the color socket to the base color, we use the factor socket in the noise texture to connect it to the base color, because that will actually allow us to create some detailed, realistic looking materials with the colors of our own choice. So I'll take the factor socket and connect it to the base color in the principal BSDF node, and by doing this, we are now having a random black and white texture applied on the UV sphere. If I try to change the scale value, then the scaling of the noise on the texture will change, and similar is the case with all the other parameters in the noise texture. Now what if you want to create a noise texture with some specific colors? Then for this, we'll again use the color ramp node. So press Shift plus A, then go to converter and select the color ramp. Let's place it in between the noise texture and the principal BSDF node. Now I'll use these pointers in the color ramp node to change the way how different colors will appear in the noise texture. You can clearly see that if I increase the distance between the black and the white pointers, then in this case we are having the different shades of grey color, which can also be seen in this texture. However, if I bring these two pointers closer, then in this case, the shades of grey between the two pointers will be much lesser, and its impact is also visible on the texture which is applied. Now to change the colors, with the white pointer selected, click here and suppose I change this to the red color, and similarly for the second pointer, I'll select this, then click here, increase the brightness, and let's change this to the yellow color. And by doing this, we are able to create a texture which has some noise and some detailing, and we can control the colors with the help of the color ramp node. Similarly, we can also add some more colors in the texture by clicking on this plus icon and then change the color from here. Then to adjust the way how these colors will appear in the texture, you simply need to adjust the position of these pointers in the color ramp node. Now suppose you want to create a detailed wood texture by using the noise texture. Then to do this thing, I'll first remove the noise texture and the color ramp node in the shader editor. Now press Shift plus A again, then go to texture and select the noise texture. Let's place it over here, and now I'll connect the factor socket to the base color. After this, in order to make the streaks of wood, we have to use the vector mapping node that will allow us to scale this texture in a particular axis. So go to the shader editor, press Shift plus A, then go to vector and select the mapping node. Let's place it over here. Now connect the vector socket to the vector in the noise texture, but right now we are not able to see the texture on this UV sphere in the 3D viewport, and that's because we need to add some input in the vector mapping node. And whenever you have to add an input to the vector mapping node, you must use the texture coordinate node. So to add it here, press Shift plus A, then go to input and select the texture coordinate node. We'll place it over here, and now I'll take the object socket and connect it to the vector in the mapping node. By doing this, we'll again have the texture applied on the UV sphere. And yes, in most of the cases, whenever you're using the mapping node connected to a texture, do ensure to use the texture coordinate node with the generated socket or the object socket connected. Now to create the wood streaks, go to the scale value and we'll try to change it in different axes to see the results. For example, when I try to change the scaling in the x-axis, we got this result of the noise texture being scaled in such a way that it actually looks like the streaks of wood. Now moving ahead, let's also apply some colors to the wood texture. So go to the shader editor, press Shift plus A, then go to converter and select the color ramp node. We'll place it over here in between the noise texture and the principal BSDF. Then with the first pointer selected, let's move it here, and I'll keep this to the black color. Then with the second pointer, I'll change this one to the brown color. So in the color wheel, let's take the pointer to somewhere around the orange color and reduce the brightness to make it look like the brown color. After this, try to adjust the position of these pointers in the color ramp node in order to get a realistic looking wood texture. Similarly, you can also try to change other parameters like the detail value, the scaling, the roughness in the noise texture, and also the scale value in the x-axis in the mapping node. And after all the adjustments are made, we'll have the wood texture created in our scene. Let's also go to the rendered view in order to see how it looks with the Cycles render engine. And with this, we created the wood texture with the help of the noise texture node and the vector mapping node that we used to change the scale value in the x-axis in order to create the wood streaks. After that, we use the color ramp node in order to control the different colors, and then we adjusted some values in different parameters to give this a better look. Also, let's save this material that we created in the material asset library. So for this, click here and we'll rename this material to wood, and to save it, go to the scene collection and with the sphere selected, left click to select the wood material, then right click and select mark as asset. And yes, if you wish to download this particular Blender file with all the materials that we have saved in this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to use some of the concepts that we covered today in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file where in the last chapter we added some simple images as the image textures on the gaming machine. Then we used the brick texture and the checker texture for the wall and the floor. And in this particular chapter, we'll be applying the wood texture that we just created to all these faces in the corner which are currently having the yellow emission material. So to do this, let's first change this window from the shader editor to the asset browser. And now here we have the wood texture that we saved in the material library. Now to use this material of the wood texture, select the gaming machine, then go to the material properties and click on the plus icon in order to create a new material slot. After this, left click on the wood texture, drag it and drop it on this particular slot that we just created. Now in order to assign this particular material to all the faces that are currently having this yellow colored material, we first need to select that yellow material in the material properties, which in this particular file is the material.001. Now press tab to enter the edit mode, deselect everything, and to assign all the faces that are having this material applied, simply click on the select button. By doing this, we'll now be having all those faces selected in the scene. Now in the material properties, scroll down and select the wood material. Click on the assign button, and with this, we are now having the wood texture that we created applied on the selected faces. And by doing this, we can also check how this wood texture is actually looking when it is applied on a 3D model in a particular scene. And currently, I don't think that we need to make any other changes in this wood texture. However, One small thing that I can notice here is that we have not applied the wood texture on this group of faces which is surrounding the screen. So to solve this problem, let's first go to the solid mode and also disable the real-time display of the bevel tool. Now press tab to enter the edit mode, and with the alt key hold it, select this face loop. After this, go to the material properties, and with the wood material selected, click on the assign button. And after this, let's also turn on the real-time display of the bevel modifier. Then go to the render preview mode, and finally this is how the wood texture is now looking being applied on the gaming machine. And with this, we also arrived to the end of this chapter. Today we learnt about some important textures and even other nodes like the color ramp node, the texture coordinate, the vector mapping node, and then we even use their concepts in this particular scene. So I've opened this materials file where we created this wood texture in the last chapter, and for today our first topic will be to understand about the magic texture node. So first of all, let's create the slot for a new material and click on the new button, and to apply this material to the UV sphere, press tab to enter the edit mode, and with all the faces selected, click on the assign button. After this, return back to the object mode, and now let's add the magic texture node in the shader editor. So press Shift plus A, then go to texture and select the magic texture. We'll place it over here, and to see what it does, I'll connect the factor socket to the base color. Now as you can see, the magic texture will create some colorful, abstract and unpredictable patterns which are often used to create artistic effects in materials. In this node, the first option that we have is to control the depth, and if I increase it, then the complexity of the texture will keep on increasing. Then we have the scale value that will control the scaling of the texture applied on the UV sphere. Similarly, the distortion value will add a distorted effect on the texture applied. In fact, to see the effect in a much better way, I'll change the mode to the material preview mode. Now let's zoom in and also reduce the scale value to around 5 or 6. And now if I try to increase the distortion value, then its effect can easily be seen on the material of the UV sphere. It kind of distorts the entire pattern which is created by the magic texture, giving it a complex but interesting look. In fact, in the magic texture also, if you want, you can change the different colors with the help of the color ramp node. So to add it here in the shader editor, press Shift plus A, then go to converter and select the color ramp. We'll place it in between the magic texture and the principal BSDF node. Now by adjusting these pointers in the color ramp node, we can make the changes in color in the magic texture. In fact, to change the color, click here, increase the brightness, and in the color wheel, choose the specific color. Let's do the same for the other pointer also. So I left click to select it, then click here and change the color to something else. Similarly, we can even add some more colors by clicking on the plus icon and changing the color from here. So in this way, you can add different colors to the magic texture simply by using the color ramp node and adjusting the positions and the colors of these pointers. Moving ahead, the next topic of this chapter is the environment texture. But before adding the environment texture node, let's first understand its meaning and its usage. So the environment texture node is used to light your scene with the help of an image file, also known as HDRI. And since it is not related to the object but rather to the 3D world or this 3D scene, so instead of the object type, we have to use this node in the world shader type. So by clicking here, I change the shader type to world, and over here we have this default setup of the background node connected with the world output. This particular node, which is the background, controls the color of the scene or the 3D viewport. But right now, if I go to the color parameter and try to change it, then we are not able to notice any difference in our scene. And this is because we have turned off the scene lights and the scene world. So I'll turn both of them on. And now in the background node, I'll change the color to something else like the blue color, and by doing this, the color of the 3D viewport or the scene will begin to change. Similarly, by using the strength value, I can control the strength of the emitted light. But for now, I'll change this to the default value of 1, and now let's use the environment node. So to add it here, press Shift plus A, then go to texture and select the environment texture. Let's place it over here, and before connecting it to the background node, we first need to download some HDRIs to be used in the environment texture. So I searched for some HDRIs for Blender and see there are plenty of websites that will allow you to download different type of HDRIs for your Blender file. And for now, I'll open polyheaven.com for downloading the HDRIs. So click on browse HDRIs, and here we have many different HDRIs that we can download. In fact, we can even select the category of HDRI. For example, the studio lighting based, then you have the sunrise, sunset, indoor lighting, and a lot more. But for now, I will select the studio lighting, and now you can choose any of the HDRI that you think will be the best for your scene. For example, I'll select this one, and to download it, simply click on the download button. Now I've reopened the Blender file, and to use the HDRI in the environment texture, click on this open button. Then select the particular file that we just downloaded and click on open image. After this, take the color socket in the environment texture and connect it to the color socket in the background. And by doing this, we are now having this HDRI applied to our scene, and because of this, we also have the lighting effect in the scene. In fact, you can control this effect with the strength value in the background node. So if I reduce this, the effect of emission or the lighting will get reduced, and if I increase it, then the effect will increase. But for now, I'll change this value to 0.2, and this is how it looks. And now after all this, we have now covered both the environment texture as well as the magic texture in this chapter. And yes, if you want to download this Blender file with all the materials that we are saving in this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to use some of these concepts that we understood today in the retro gaming arcade scene that we have been creating since the beginning of this course. So I've opened this file of the arcade scene where in the last chapter we applied this wood texture that we created by using the noise texture node, and today we'll change this red colored material applied on these faces to a different material with the magic texture node. And to do this thing, with the gaming machine selected, go to the material properties and select this red colored material that we've applied to the side faces. Now press tab to enter the edit mode, deselect everything and click on the select button in order to select all the faces with this material applied. Now let's create a new material by clicking on the plus icon and then on the new button. Then to assign this material to the selected faces, click on the assign button and also get back to the object mode. Now to create a material with the magic texture, go to the shader editor, press shift plus A, then go to texture and select the magic texture node. Let's place it over here and connect the color socket to the base color. After this, in order to make it look complex, I'll first increase the depth to a value of 4, and then I'll also increase the scaling value from 5 to somewhere around 10 or 15. Then go to distortion and let's increase it up to a value of 3 or 4, and I'll also change the mode to the material preview mode in order to see the changes in a much better way. So we have this magic texture applied on the side faces, and let's also adjust the scaling and the distortion value in order to give it a complex look. After this, to add some colors to the texture, let's add the color ramp node after the magic texture. So press shift plus A, then go to converter and select the color ramp. We'll place it in between the magic texture and the principal BSDF node. After this, move the pointers and also change the colors by using the color wheel. So I'll change the first color to the blue color, and then for the second pointer, let's place it over here and change it to green or maybe yellow color. And then if you want, you can click on the plus icon in order to create a new pointer and change the color by using the color wheel. So for this one, I'm choosing the red color, and now it looks perfect. With this, we have applied this magic texture to the side faces of the gaming machine. And with this, we also arrive to the end of this chapter. Today we learned about the magic texture node and the environment texture node, and both of them are very useful in order to create an abstract pattern effect and HDRI lighting effects respectively. So I've opened this materials file where we created this material in the last chapter by using the magic texture node, and in today's chapter our first topic will be to understand about IES texture node. Now the IES texture is used to match real world lights based on some IES files. To make you understand this in a better way, let's first understand the full form of IES. So IES stands for Illuminating Engineering Society, and this IES texture will use a particular file that we can download online, and it will describe how the light will be distributed in our scene. To understand it practically, let's first add a spotlight in the scene. And yes, because I already told you that the IES texture node is used to impact the lighting in the scene, as a result, we'll be adding the IES node in the node system of the spotlight. So press shift plus A, then go to light and select the spotlight. And yes, it's not compulsory to select the spotlight only. If you want, you can get similar results with the area light or the point light or the sunlight, but just for showing it with an example, I am selecting the spotlight. Let's move it up in the Z-axis and place it over here. After this, go to the shader editor, and with the spotlight selected, we'll now add the IES texture node. So to begin, first enable the use nodes by clicking here, and this will give us the default node system for the spotlight, where we have the emission shader because the spotlight is emitting the light and it is connected to the light output, because of which we are able to see the effect of light in the scene. This is very similar to the material output node that we used to see for mesh objects. For example, in this UV sphere also, we have this material output node which can be used for surface and volume materials. Now let's select the spotlight again, and to add the IES texture, press shift plus A, then go to texture and select the IES texture. Let's place it over here. Now before moving ahead, we first have to download the IES files that we'll use in this node to create the lighting effect. So here we have this website which is ieslibrary.com, and on this website you will find plenty of files that you can download for using in the IES texture node. In fact, with each file you also have this image which shows the distribution of light in the scene for that particular file. For example, I'll select this particular file, and to download it, simply left click here and then click on download IES. After this, the downloading will begin in a few seconds, and now to use the file in this particular node, first click on external and then click on this folder icon. Now open that particular folder where you downloaded that file, then select it and click on accept. After this, take the factor socket and connect it to the strength in the emission node, and to see its effect, click here and turn on the scene world. Also, go to the object data properties and increase the power to around 250 watts, and now let's also hide the point lights that we previously added in the scene, and with this we are getting this particular distribution of light from the spotlight. In fact, you can even control the strength of this texture from the strength parameter here. If I reduce it, the strength of the lighting will reduce, and if I increase it, the strength will increase. Also, I think that we should bring down the power to around 30 or 40 watts, and this is how it looks now. And yes, to see how the spotlight will look without the IES texture, simply hold the Alt button, then left click and drag the node away to remove the connection. And now you can see the difference between this regular spotlight and the one that we created with the IES texture. Now in a similar way, we'll be creating one more light with some other file. So for this, press 7 on the numpad to go to the top view. Let's zoom out, then press G to move the light and place it over here. Create a duplicate of this light by pressing Shift plus B and move it in the X-axis like this. And for the second light, we'll be downloading one more file with the IES texture. So I've again opened this website and will now download this particular file by clicking on the download button. Now to use that file for the IES texture of the second spotlight, simply click on this folder icon, then open the folder where you saved that particular file, then select it and click on accept. And by doing this, we now have a different distribution of light in the scene because of this spotlight. Also, you can try to increase the power or the intensity of the light from here in order to see the distribution of light in a much better way. So you can clearly notice the difference between these two spotlights having different files in the IES texture node. So whenever you want to have some special lighting effects in your scene, then you can use the IES textures for that particular light. In fact, I would suggest you to download some more IES files from that website that we just visited and try to understand the difference between each one. But for now, we'll move on to the next topic of this chapter, which is the Warner texture. And to understand about it, I'll first disable the scene world in the viewport shading menu, and then I'll also delete both of these spotlights. Let's delete this one also. And in the scene collection, let's also unhide the original lights back in the scene. Now to use the Warner texture, I'll select this UV sphere, then go to the shader editor, select the magic texture and the color ramp node and press X to delete. Now press Shift plus A, then go to texture and select the Warner texture. We'll place it over here, and first of all, I'll take the distance socket in the Warner texture and connect it to the base color, and by doing this, we get this texture with some black spots on white background. If I try to increase the scale value in the Warner texture, then the number of black spots will increase and the scaling of texture will change. Then over here, we have the option to control the detailing, and if I increase it, the detailing of the texture will increase. Similarly, with the roughness value, we can control the blending of the texture for the material. After this, we have the randomness, and if I reduce this to 0, then now the texture will have no randomness, and as a result, we are getting this grid light pattern applied on the UV sphere. However, if I keep on increasing this value, then slowly the randomness of the texture will begin to increase, resulting in the formation of this texture with the black spots on the white background. Now do remember that we got this result with the walnut texture when we used the distance socket for connecting to the base color. However, if I now take the color socket and connect it to the base color, then in this case, we'll get a colorful geometric pattern with a number of different faces applied on the UV sphere. Similarly, if I now take the position socket and connect it to the base color, then we'll get a texture with a slight gradient effect where you can see the change of color from blue-green to the pink color. And apart from these colors, you will also notice these geometric shapes applied on the texture, which can be controlled by the randomness value in the Warner texture. If I bring it down to 0, you will only notice these square faces on the texture. However, as I begin to increase this value, we'll begin to see these geometric shapes. Also, I will now connect the color socket to the base color, and after that, if I left click over here, then this menu will appear where you will find different options for the feature output, and with each one you will get a different result, so you can try to switch to different feature outputs in order to get some different results in the Warner texture. Like the smooth F1 is exactly the same as the F1, but the only difference is that the blending or merging of different shapes with each other is being shown with a blurred effect in smooth F1. Similarly, if I change this to distance to edge and then connect the distance socket to the base color, then we get a completely different texture which can be used for creating a scale texture. For example, you can use it to create the skin of a reptile or a dragon. Now moving ahead, if I change this back to F1 and connect the color socket to the base color, then here we can also use the color ramp node in order to change the colors of this pattern. So to do this, press Shift plus A, then go to Converter and select the color ramp node. Now place it in between the Warner texture and the principal BSDF. Now with the black pointer selected, I'll change the color from here. So increase the brightness, and for the first one, I'll select the red color. By doing this, you will begin to notice some shades of the red color applied on this pattern. Similarly, I'll now select the second pointer, and for this one, I'll change the color to blue. Apart from this, you can also add some more colors by clicking on the plus icon here and change the color by using this color wheel. So for this one, I'll choose the green color, and now we have a combination of the red color, green color and the blue color on this Warner texture. Similarly, let's now add two more pointers for some more colors, and I'll change the color of this pointer to the orange color, and for the other pointer, let's change this to the yellow color. After this, it's also important to ensure that all of these pointers are evenly distributed away from each other so that we have an even distribution of these colors on the pattern. And to do this thing, one way is to manually left click and drag different pointers like this, but a much easier way is to click here and select Distribute Stops Evenly. And with this, we now have all the colors evenly distributed on this texture. And if you want, you can also change the color of any of these pointers by simply selecting it and changing it by using the color wheel. Now let's also save this material of the Warner texture that we just created in the material asset library, about which we learned in the first chapter of this course. So for this, let's first rename this material by left clicking here, and I'll change its name to Warnoy. After this, go to the scene collection, and in the sphere, select this material, then right click and select Mark as a set. And with this, we have now learned about the IES texture and the Warner texture in this chapter. And if you want to download this file with all the different materials that we are saving in this course, then you can join the Patreon, whose link is added in the description of this video. And so now it's the time to use the concepts that we learned today in the retro gaming arcade scene that we are creating in this course. So I've opened this scene in the material preview mode, and in the last chapter, we created this wood texture and applied it to some of the faces of the gaming machine. And today, we'll be applying the Warner texture that we just created on the spherical part of the gaming controls. Also, we'll set the color of the cylindrical part of both of these controls to the red color. So to do this thing, with this control selected, press tab to enter the edit mode, then deselect everything, and with the cursor over the cylinder, press L. Now in the material properties, select the red material and click on the assign button. After this, return back to the object mode and create a slot for a new material. Now to use the Warner texture that we created in the materials file and saved in the material library, we have to change this window to the asset browser. So click here and select the asset browser. Then select the Warner texture, drag it and drop it on this slot number 3. Now to apply this material to the spherical part, simply press tab to enter the edit mode, deselect everything, and with the cursor over the sphere, press L, and with the Warner texture selected in the material properties, click on the assign button. After this, we'll do the same thing with this control also. So with the spherical part selected, I'll change this material by clicking here and type Warnoy and select this material. Now return back to the object mode. And finally, this is how this Warnoy material is looking on the game controls. If you want, you can change the properties like the scaling, the colors in the shader editor. So first of all, I'll increase the randomness to 1. Let's also bring down the roughness value in order to give this a shiny appearance. Then for the colors, I'll change the yellow color to the pink color. And let's also change the color of this purple pointer to maybe blue, and now it looks perfect. After this, let's go to the rendered preview mode in order to see how the texture will look in the final version. And with this, we have now learned about the practical usage of this Warner texture. And also, this brings us to the end of this chapter. So I have opened this materials file where we created this Warner texture in the last chapter, and for today our first target is to understand about the mixed shader. So for this, let's first create a new material. So go to the material properties, click on the plus icon and then click on the new button. After this, press tab to enter the edit mode, and with all the faces selected, click on the assign button. Now return back to the object mode, and now as the name suggests, the mix shader node is used to mix two different shaders together. To see how it works, go to the shader editor, press Shift plus A, then go to shader and select the mix shader node. Now place it after the principal BSDF node, and by doing this, the BSDF socket of the principal BSDF node will get connected to the first shader socket of the mix shader, and then the output node of the mix shader will get connected to the material output. Now suppose I change this color to the blue color, then as you guessed, the color of this UV sphere turned into the blue color. But suppose I want that on some areas I should have the material due to this principal BSDF node with the blue base color, and on some other areas I should have another material, for example another principal BSDF node with some other color, and this is where the mix shader node can help us. To understand how it works, I'll first select the principal BSDF node and create a duplicate of it by pressing Shift+D and place it over here. Now I'll change the base color to red, and let's also bring down the roughness value down to 0. Now take the BSDF socket and connect it to the second shader socket of the mix shader, and by doing this you will notice a combination of the red and the blue color which is giving us a purple or pink color as a result. And basically this is what the mix shader node will do. It will simply mix two shaders together that are connected with the two shader sockets, and the proportion of the mixing can be controlled with the factor value. By default it is set at 0.5, meaning that the mixing of both the shaders will be equal. However, if I reduce it down to 0, then in this case it will only display the first shader with the blue color, and as I begin to increase this value from 0 to something like 0.2 or 0.3, then now we'll begin to notice some impact of the second shader. However, until the value of factor is below 0.5, the impact of the first shader will be more on the material. But if I increase this value to something beyond 0.5 like 0.7 or 0.8, then in this case the impact will be more of the second shader which is having the red color in this case. Also, if I increase this factor value to 1, then we'll only see the impact of the second shader which is red in color. But if you remember, I told you that we want to use the mix shader node in order to get a result where on some parts of the UV sphere we'll have the first shader and on the other parts we'll have the second shader. And to achieve such a result, we have to use a combination of the color ramp node and the noise texture, and then we'll connect it to the factor socket. So to see how it works, press Shift+A in the shader editor, then go to converter and select the color ramp. Let's place it over here. Now press Shift+A again, then go to texture and select the noise texture. Let's place it over here. Now take the factor socket in the noise texture and connect it to the factor in the color ramp. After this, take the color socket in the color ramp and connect it to the factor in the mix shader. And by doing this thing, you will begin to notice that some parts of the UV sphere are now having the shades of the blue color and the others of the red color, and this is because the color ramp node connected to the factor will now be controlling the composition of different shaders depending upon the position of these pointers. Also, by using the noise texture, you can change the scale value in order to change the position of different shaders in the material. And yes, if you want that these colors or the shaders should not blend with each other, but instead they should appear as separate shaders on the material, then for this purpose, go to the color ramp node, click here to change the interpolation and select constant. After this, try to adjust the position of the different pointers in such a way that we get the different shaders properly applied on the material. Similarly, you can also bring down the roughness value in the noise texture to make the blending smoother. And yes, not only the principal BSDF node, you can use the mix shader with any type of shader node. For example, in the shader editor, if I press Shift+A, then go to shader and select the glass BSDF node, place it over here, and suppose I want that instead of the red color, I should have the glass material on all these areas. So for this, I'll take the BSDF socket and connect it to the second shader. And by doing this, we are now having a combination of this blue colored material because of this principal BSDF node and also the glass material because of the glass BSDF. Then again, you can go to the noise texture node and change the scaling. That will change the scaling and the position of this texture, and then you can also change the position of these pointers in the color ramp node in order to control the blending of these shaders. After this, let's now move to the next topic of this chapter, which is to understand about the basics of the mix color node. And for this, we'll be creating a new material in the material properties. So click on the plus icon and create a new material. Now press tab to enter the edit mode, and with all the faces selected, click on the assign button. Now return back to the object mode, go to the shader editor, and let's now add the mix color node. So press Shift+A, then go to color and select the mix color node. We'll place it over here, and now this node is used to mix two colors together, which is very similar to the previous node, that is the mix shader, which we used to combine two different shaders together. So in the mix shader, we used to mix the shaders, but in case of the mix color node, we'll be mixing two colors together. So to see how it works, I'll take the result socket and connect it to the base color, and then we have two color options, that is the color A and the color B. So if I left click here to change the color A and select the blue color, and for the color B, I'll change this to the red color. And by doing this, we notice that with the default values in the mix color node, we are getting a combination of the blue and the red color. Then just like the mix shader node, we have a factor value here using which we can control the amount of color A and the color B in the final result. If the value of factor is equal to 0, then we'll only see the color A, and if it is anywhere between 0 and 0.5, then in that case, we'll observe a mix of both the colors in this material. However, the color A will have more influence than the color B. Similarly, if the factor value is equal to 1, then we'll only see the color B, and if it is anywhere between 0.5 and 1, then we'll see more of the red color, or basically the color B. After this, if I click here, then we can change the blending mode that will change the way how the colors will blend with each other. And in each type, you will get a different type of result depending upon the selection. And then just like the mix shader node, you can also use a combination of the color ramp node and the noise texture that you can connect to the factor socket in order to control the position and the scaling of different colors in the material. So I've added the color ramp, and let's also add the noise texture node. Let's place it over here. Now take the factor socket and connect it to the factor of the color ramp. And by doing this, we are again having some areas with the red color and the others with the blue color. To control these areas, go to the color ramp node and try to change the position of these pointers. Also, go to the noise texture and you can change the scaling value like this. So as a conclusion, both the mix shader node and the mix color are very similar to each other. However, the only difference between the two is that you can use the mix color node only to mix two colors and not shaders, but the mix shader node can be used to not only mix different colors but also mix different shaders together, like a principal BSDF with a glass shader or maybe any other shader that you can access in the add menu. And with this, we have now learned about both the topics of this chapter. And yes, before moving forward, if you want to download this Blender file containing all the materials that we are saving in this chapter, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to practically use the concepts that we learned today in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file where in the last chapter we created this Warner texture and applied to the game controls, and today we'll be using the mix shader in order to add some colors on these tiles for the floor that we created by using the checker texture. Right now we are only having the black color, but suppose I want that along with the black color we should also be having some influence of the blue color on these tiles. So to do this thing, go to the shader editor, press Shift plus A, then go to shader and select the mix shader node. We'll place it in between the principal BSDF node and the material output node. After this, select the principal BSDF node, press Shift plus D to create a duplicate and place it over here. In this, I'll change the base color to blue, and after this, connect the BSDF socket to the second shader socket in the mix shader. And by doing this, we are now having this blue color on these tiles. But right now, we are having the blue color on all the tiles of the floor. But in order to create a material where we only have some slight influence of the blue color and actually the tile should be black in color, then for this we'll be using the color ramp and the noise texture, and we'll connect it to the factor socket. So press Shift plus A, then go to converter and select the color ramp. Let's place it over here. Then take the color socket and connect it to the factor in the mix shader. After this, press Shift plus A again, go to texture and select the noise texture. Then take the factor socket and connect it to the factor of the color ramp. Now we'll adjust the position of different pointers in the color ramp node in order to change the composition of the two shaders, the one with the checker texture and the other one with the blue color. Then you can also adjust the scale value in the noise texture to change the scaling, and I'll also bring down the roughness value in this principal BSDF node with the blue color. After this, we'll be having a perfect material on this floor with some influence of the blue color added on these tiles. Also, suppose you want that along with the blue color, we should also have one more material with the red color. And to achieve this result, I'll select this mix shader node, press Shift plus D to create a duplicate and place it after the original mix shader node. Then select this principal BSDF node with the blue color, create its duplicate, place it over here and change the base color to the red color. Now take the BSDF socket in this principal BSDF node with the red color and connect it to the second shader socket in the mix shader. Now to control the amount and the blending of this red color, select the color ramp and the noise texture node, create a duplicate, place them over here and connect the color socket of the color ramp to the factor in the mix shader. And by doing this, you will begin to see both the red and the blue colors mixing with each other. However, to see both the colors individually or separately, you simply need to change the scale value in the noise texture. So for the second mix shader, I'll try to change the scale value, and this will give us both the red and the blue color applied on the checker texture. So as a summary, we first had only the checker texture with the principal BSDF connected to the material output, but then we thought of adding some blue color, so we used the mix shader where we first connected the original checker texture and the principal BSDF as the first shader, and then we connected the principal BSDF node with the blue color as the second shader. Then for factor, we used the noise texture and the color ramp node. Then to add some red color, we used another mix shader where in the first shader socket we connected it to the first mix shader, and for the second shader socket we connected it to the principal BSDF node with the red color. Then again for the factor, we used the color ramp and the noise texture. After this, we adjusted the value of scale in order to see both the colors separately in the scene. And with this, we now arrive to the end of this chapter. Today we learned about mixing different shaders and different colors together. So I've opened this materials file where in the last chapter we studied about the mix shader and the mix color node, which were used to combine different types of shaders together or different types of colors together. And today we'll begin with understanding the concept of normal map in Blender. But before that, we first need to understand the use of the normal map node. So to explain that, you need to understand that in Blender there are two ways of applying a material to any object in the scene. The first method is to create the material manually by using different nodes or through the material properties, and the second way is to download the materials from some external websites and then import them in your Blender project. And whenever you import any materials by downloading them from some external websites, you will get a combination of different images with each one carrying separate data. Like one of them will carry the information about the basic color of the material, then the other one will have information about the roughness, the normal effect. And to practically understand about using such materials in the Blender file, I have opened this website, which is polyheaven.com, from where we can download different textures to understand about the normal map node. So I'll click on browse textures, and yes, this is not the only website where you can get different types of textures, but instead there are plenty of other websites also where you can get a similar variety of textures to download in Blender, and a lot of them will be free as well. And now you can select any of these textures to be used in the Blender file. And for now, I will select this particular texture, so I left click on it and click on the download button. Now after downloading the texture, you have to unzip the folder in the file explorer of your PC, and after that, to apply the texture on this UV sphere, just go to the material properties, click on the plus icon and then click on the new button. After this, press tab to enter the edit mode, and with all the faces selected, click on the assign button. After this, to use that texture that we just downloaded on this UV sphere, we need to add an image texture node. So in the shader editor, press Shift plus A, then go to texture and select image texture. Let's place it over here, and to import the texture, click on the open button. After this, open that particular folder where you saved and unzipped that particular folder, then double click on it. Then inside that folder, we have the textures. Let's open this as well, and in this folder, we are having these 4 different files that we can use in different image texture nodes. The first one is named as Gray Rocks Displacement, and it can be used for creating the displacement effect. Then you have the Gray Rocks Normal that we'll use to understand about the normal mapping. Then we have the Gray Rocks Roughness, which can be used to define the roughness of the texture. And at last, we have this image named as Gray Rocks DIFF, which is to be used as the main image or the one whose image texture node will be connected to the base color. And yes, if you have downloaded some other texture, you might have some extra files or even some particular file absent depending upon the texture. But more or less, in most of the textures, you will definitely find a simple image which is to be connected to the base color, then a roughness image and the normal. So with this one selected, I'll click on open image. After this, take the color socket and connect it to the base color. And by doing this, we now have a simple texture of the gray rocks applied on this UV sphere. To see it in a better way, we'll turn off the scene lights from here, and now this is how it looks. Right now, it looks very simple and it appears as if we just wrapped around this 2D image on a 3D object. But to give it a realistic 3D look, we'll now try to add the roughness image that we had in that folder, and we'll see what particular difference it will create in the texture. So to do this, with the image texture selected, press Shift plus D to create a duplicate and place it over here. Then to use the roughness image, click on the folder icon, then select this image having the word rough to indicate the roughness image and click on open image. But before connecting it to the principal BSDF node, to ensure that in the color space you change this to non-color, and this is because we'll only use the original image which we connected to the base color in order to get the colors of the texture. We are using the roughness image only to adjust the roughness value and not the colors. So in the color space, do ensure to select non-color option. Now to use this image for the roughness, simply take the color socket and connect it to roughness in the principal BSDF. And by doing this, you will notice a very slight roughness added to the image texture. To see the difference in a much better way, I'll change this to the material preview mode, and after this, if I disconnect this node connection between the image texture node and the roughness by holding the control button, then right clicking and dragging the mouse like this, then because of the lighting effect, you can clearly see that initially the image is having the roughness value depending upon the value of roughness in the principal BSDF node. But on connecting the image texture with the roughness image to the principal BSDF, we'll get a different result. However, it's not creating much difference in terms of realism or the 3D effect. So now we'll use the third image that we had in the folder, which is the normal image. So for this, with this image texture node selected, create a duplicate by pressing Shift plus D. Let's place it over here, and to import the image, click on the folder icon, then select this image having NOR in its name, which stands for normal, and then click on open image. After this, in the color space, change this to the non-color, and then if I try to connect the color socket to the normal in the principal BSTF node, we'll get a texture which looks like a disaster. And that is because the way we connected this image texture carrying the normal map image to the normal socket in the principal BSTF node is not correct, because in between this connection we have to use the node which is called the normal map node. We'll be using it to connect the image texture node with the normal map image to the normal socket in the principal BSTF. So to add it here, press Shift plus A, then go to Vector and select the normal map. We'll place it in between the image texture node and the principal BSTF. And by doing this, you will clearly notice that this image texture is now looking a lot better and much more realistic as compared to before. To notice the difference, I'll remove the node connection between the normal map and the principal BSTF node. And initially, the texture used to look very simple with no effect of the normal map, but after we connected the normal image to the principal BSTF with the normal map node in between, we'll get the texture applied along with the normal map, and this will give it a highly realistic look. Also, let's apply this material on this plane to see the difference in a much better way. So I'll select the plane, then go to the shader editor, click here, and I'll select the material.003, and with this we now have this grey rock texture applied on this plane. Now if I go to the shader editor and try to remove the node connection between the normal map and the principal BSTF node, then the difference between both of these results is much more clearly visible on this plane. Without the normal mapping, the texture looks very plain, simple and 2D, but after connecting the normal map to the principal BSTF, we get a highly realistic look. Now moving ahead, the next topic of this chapter is to understand about the bump node, but before that, I'll again apply the original material that we created for the plane. Now press 0 on the numpad to go to the camera view, and to understand about the bump node, I'll select this UV sphere and change the material to the Warner texture material that we learned to create in the chapter number 10. Now as the name suggests, the bump node is used to create some 3D bump effects on the texture. And to see how it works, go to the shader editor, then press Shift plus A, go to Vector and select the bump node. Now place it over here, and in this node, we have to input one socket from the texture, and then it will give the output from the normal socket that will connect to the normal in the principal BSTF. So in this case, we'll be taking the color socket that we even connected to the color ramp and we'll use it for the input in the bump node. So simply connect this socket to the height in the bump node, and after that, to see the results, take this normal socket and connect it to the normal in the principal BSTF. And just by doing this, you will notice a very slight bump effect applied to this texture. To see the difference again, I'll go to the shader editor and then remove the node connection between the bump node and the principal BSTF. So by default, the texture is looking very simple with no 3D effect, but after connecting the normal socket in the bump node to the normal in the principal BSTF, we'll get this result where the texture is now having a 3D look with the bump effect added to it. You can even control the strength of this effect with the strength value in the bump node. So if I reduce it, the effect of the bump will reduce, but if I increase it, the strength of the bump effect of the texture will be more. So finally, this is how the normal map node and the bump node work in the shader editor. And now before moving forward, if you wish to download this Blender file with all the materials that we are saving in this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to use the concepts that we learned today in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the arcade scene where in the last chapter we used the mix shader node in order to create this colorful effect on the tiles, and today we'll be using the concept of bump node in order to change this wood texture that we have applied on this gaming machine. So for this, I'll first select this gaming machine and then press the / button to keep the focus only on this object. After this, let's zoom in, and right now you can see that the wood texture that we applied on this machine is looking very simple. But today we'll be using the bump node in order to make it look realistic. So for this, go to the material properties, select the wood material, then go to the shader editor, and to add the bump node, press Shift plus A, then go to Vector and select bump. Now place it over here, then for input, take the factor socket in the noise texture node and connect it to the height in the bump node. After that, for the output, take the normal socket in the bump node and connect it to the normal in the principal BSTF. And by doing this, you will notice that the wood texture is now looking a lot more detailed and realistic than before. Previously, without the bump node, it used to look very simple and plain, just like a basic 2D texture, but after using the bump node, we managed to create this bump effect on the texture, which is giving it a much more realistic look. Also, let's bring down the strength of this effect in the bump node, which by default is set to 1. So let's reduce it down to somewhere around 0.2 or 0.1 so that we have a very slight bump effect applied to it. Now let's also change the angles to see if the texture is looking good from other sides as well. So from here also, the wood texture looks fine, and similarly from this side also, the texture looks realistic. Also, if you want, you can change the color of this texture from brown to something else by using the color ramp node. So with the brown pointer selected, click here to change the color, and suppose I change it to the gray color, and then also increase the metallic value in the principal BSDF node, and now it will look somewhat like old iron material. So it depends upon you that what particular kind of texture you are creating for your object's material. If you want it to have a metallic look, simply choose that particular color and adjust the metallic value in the principal BSDF node to control the reflections and the metallic effect. And apart from this, you also have the bump node where you can control the strength of the bump effect. But for now, I think that the original wood material looked much better for this machine according to the current scene. So I'll press Ctrl plus Z 6 to 7 times to undo all the changes that I did, and then I'll press the forward slash button to return the focus back to the scene. And with this, we have now understood about the practical usage of the bump node with the help of the wood texture in this arcade scene. And with this, we now arrive to the end of this chapter. So I've opened this materials file where in the last chapter we studied about the normal map and the bump node, and today our first topic to understand will be the Sheen BSDF node. And to understand about its working, I'll first go to the solid mode by clicking here, and we need to create a basic cloth simulation in the scene, and that is because the Sheen BSDF node is basically used to add reflections to materials that have microsurface details, for example cloth or dust. And so we have to add a plane in the scene on which we'll apply the cloth physics. So press Shift plus A, then go to Mesh and select Plane. Press Tab to enter the edit mode, and let's scale it up 3 times. Now press Enter to confirm, return back to the object mode, and we'll move it up in the Z axis. After this, to apply the cloth physics, go to the physics properties by clicking here and select cloth. Then in the quality steps, increase the value from 5 to 8 because this is the factor that will determine the quality of the cloth. After this, scroll down, go to collisions and enable the self collisions from here. But right now, we are not having enough vertices to give the cloth a realistic look. So go to the edit mode, right click and select subdivide, then click here and open this menu and increase the number of cuts to somewhere around 24, or maybe let's keep it to 48. Now return back to the object mode, and now we need to make it interact with the UV sphere and the plane object. So I'll select the UV sphere, then go to the physics properties and enable the collision physics. This will make the cloth interact and collide with the UV sphere. Similarly, I'll select this plane, go to the physics properties and enable the collision physics. Now in the 3D viewport, press the space bar to play the animation, and now you will notice that the cloth will move downwards and it will also interact with the UV sphere and the plane in the scene. Now I'll select the cloth, right click and apply shade auto smooth, and if you want, you can go to the edit mode and right click to apply subdivide one more time in order to make it much more detailed. So I place the pointer again at the frame number 1 and press the space bar to play the animation. Now this time the speed of animation in the 3D viewport will be slightly slower as compared to the previous one because of the increase in number of vertices. But once it is done, we'll go to the camera view by pressing 0 on the numpad. Let's also switch to the rendered preview mode, and by default it is having the white material, and to change it, go to the shader editor, click on the new button, and now we'll be using the Sheen BSDF node in order to see how it works. So press Shift plus A, then go to shader and select the Sheen BSDF node. Let's place it over here and connect the BSDF socket to the surface socket in the material output node, and by doing this, we are having a black colored material applied to this cloth object. To change its color, click here in the color option, and suppose I want that the material should be red colored, so I'll select the red color in the color wheel, and now this is how the material of the cloth is looking. But you might be thinking that we can achieve a similar result by using the color option in the principal BSDF node also. So what's exactly the benefit of using the Sheen BSDF in that case? But in reality, this is not the case, because if I go to the base color in the principal BSDF and change this to the red color and then connect it to the material output node, then you can see the difference between this cloth material and the one that we got from the Sheen BSDF. As I told you before, the Sheen BSDF node will create a material considering the reflections and the microsurface details that we normally want in the cloth materials. So let's again apply the Sheen BSDF node to the cloth object. Now in this node, we are having this roughness parameter, and if I reduce it down to 0, then in that case, the color of this material will be completely black, and this is because this particular roughness value is controlling the amount of color that is reflected back from the material to the camera. So a lower value of roughness would mean a darker material because hardly any colors would reflect back from the material, making it look fuzzy and darker, but a higher value of roughness would mean that more colors will be reflected, giving it a dusty and a realistic look just like a cloth fabric. Now moving ahead, the next topic for this chapter is to understand about the subsurface scattering node. So first of all, I'll hide this cloth in the scene by pressing H, and let's also hide this UV sphere by again pressing H. Now to understand about the subsurface scattering node, we'll be adding a monkey object in the scene. So press Shift plus A, then go to Mesh and select Monkey. Now let's go to the camera view, zoom out and move the monkey up in the Z axis like this. Now press Ctrl plus 2 in order to apply the subdivision surface modifier with the levels viewport set to 2. After this, right click and apply Shade Auto Smooth, and let's also scale it up by pressing S. Now to use the subsurface scattering node, go to the shader editor, click on the new button, then press Shift plus A, go to shader and select the subsurface scattering node. Let's place it over here. Now before using this node in Blender, I should first explain you the meaning of subsurface scattering. So subsurface scattering is a mechanism in which light penetrates through the surface of a translucent object, and then the light is scattered by interacting with the material and exits the surface potentially at different points. This effect is seen in things like wax, skin, and you must have noticed that when you place your hand in sunlight or very close to a particular source of light, it looks something like this, with some of the red color of the light being allowed to pass through the skin because of the subsurface scattering effect. And the same effect can be achieved in Blender by using this node, which is the subsurface scattering node. So to see how it works, I'll first take this BSS RDF socket and we'll connect it to the surface socket in the material output. Now we'll also need some light coming from the back of the monkey object in order to observe the subsurface scattering effect in a much better way. So I'll go to the solid mode, then change the angle, and to add the light, press Shift plus A, go to the light category, and I'll be selecting the spotlight. Now let's move it up in the Z axis and place it over here. Then we'll rotate it in the X axis by -90 degrees. Then move it back in the Y axis like this, and then let's bring it down in the Z axis. Now go to the camera view again by pressing 0 on the numpad, then go to object data properties to change the color and the power of this light. So in the color, I'll change this to the blue color, and in the power, I'll enter value of around 2000 watts. After this, go to the rendered preview mode in order to observe the subsurface scattering effect. Now if I zoom in, you will hardly notice any effect of the subsurface scattering on this monkey object, and that is because the scale value in the subsurface scattering is set at a very low number by default. But if I try to increase it from 0.5 somewhere around 2 or 3, then you will begin to notice this blue light passing through the object's surface. This effect is more visible on the ears of the monkey object and also in the region around its eyes. And the reason for this is that the thickness of the mesh in the region around the ear is very less as compared to the region for the remaining part of the monkey head. You can also see a similar effect on the bottom part, and the reason why you see a very strong effect on the regions around the eyes is the empty space present in between the eye sockets and the eyes of the monkey object. Then if you want, you can go to the color option in the subsurface scattering and change the color of the Suzanne object. By doing this, you can notice the way how the light of different colors will interact with different settings in the subsurface scattering node. And with this, we have now understood about both the Sheen BSDF node and the subsurface scattering node in Blender. And before moving forward, if you want to download this particular Blender file with all the materials saved that we have created in this chapter, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to understand about some of the concepts that we covered today in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the arcade scene, and currently we are not having in the cloth object in our scene on which we can apply the Sheen BSDF node. However, we can understand about subsurface scattering node by making some changes in the material of this gaming machine. So for this, press 1 or 3 on the numpad for the front or the side view. Then with the machine selected, I'll be creating its duplicate by pressing Shift plus D, and we'll move it in the Y axis and place it over here. After this, go to the material properties and we'll be selecting this blue or the purple colored material that we have applied to the body of the machine. So I'll select this material from this list, and to make sure that whatever changes I make in the material for this particular object do not get applied to the material of the original machine, we first have to create a duplicate of this material. So click on this icon in the shader editor to create a duplicate, and after this, go to the shader editor, press Shift plus A, then go to shader, and we'll select subsurface scattering node. Now place it over here, and in the color, we'll be choosing the same color as we are having in the RGB node. And to get the exact same color, simply take your cursor over this purple color, then press Ctrl plus C to copy the color, and after that, take the cursor to this color option in the subsurface scattering node and press Ctrl plus V to paste this color here. Now take the BSS RDF socket in the subsurface scattering node and connect it to the material output. And by doing this, you will notice that this blue or the purple colored material of the second machine is now having a different look. In fact, let's zoom in properly to notice the difference between the two materials in a proper way. So you can clearly see that on the machine, which is on the left side, this purple or the blue colored material is not displaying any reflections of the red light on its surface. However, if you notice closely, on the second machine, we are having this slight effect of the red colored light on this purple material, and this is because of the subsurface scattering effect. In fact, if I go to the scale value and increase this from 0.05 to something like 1 or 2, then in that case, the effect of red light will be much more visible on this material. And the only reason why this is happening is that the subsurface scattering node is simply allowing the colored lights to pass through the surface of the particular object. So it depends upon the scene that whether you want the object to show the subsurface scattering effect or not, and then you have to take the decision of choosing one of these materials as the final one. If you want to have this effect of the lighting, then go for this material with the subsurface scattering. Otherwise, you can go with the original material without any subsurface scattering. And in this particular case, I'll be going with the original material only for the gaming machine. So for now, I'll delete this duplicate that we just created for understanding the subsurface scattering effect. And with this, we now arrive to the end of this chapter. Today we learned about the Sheen BSDF node and also the subsurface scattering node. And then we also understood about the practical usage of the subsurface scattering node in this arcade scene. So I've opened this materials file where in the last chapter we used this monkey object to understand about the subsurface scattering, but for now I will hide this monkey object along with the spotlight by pressing H, and now in this chapter we'll be understanding about the object info node. So to see how it works, let's first add some UV spheres in the scene. So press Shift plus A, then go to mesh and select the UV sphere. Let's move it up in the Z axis and place it over here. Now go to the edit mode and we'll scale this down like this and return back to the object mode. Now right click and apply shade auto smooth, and after this we'll be creating some duplicates of the UV sphere. So press Shift plus D to create a duplicate and we'll move it in the x-axis, and to repeat the same step again, simply press Shift plus R. Similarly, for two more duplicates on the other side, I'll select this UV sphere, press Shift plus D to create a duplicate and move it in the x-axis and place it over here. Then to repeat the same procedure again, press Shift plus R, and now we are having 5 UV spheres in this scene. Now select any one of them and change the mode from solid to the material preview mode. Also, I'll disable the scene lights and the scene world in order to get a very simple look of the object and the material. Now with this UV sphere selected, I'll go to the shader editor and create a new material. Then in the base color, you can choose any color of your choice. For example, in this case, I will choose the red color. Now let's also increase the metallic strength to somewhere around 0.7 or 0.8 in order to make the surface have a reflecting look. And now suppose I want that each of these UV spheres should be having the same material named as material.005, but for each of these the base color should be different. Now one thing to note here is that the material of an object is identified not only by its color but by other properties also, like the metallic strength, roughness value, the texture applied to it, the transmission values and other properties. So I basically want that all the other properties except for the base color should remain the same for all the UV spheres, and only the base color should be different for each one. And to achieve such a result, we have to use a node which is called the object info node. So to add it here, press Shift plus A, then go to input and select the object info node. Let's place it over here, and now the object info node is basically used as an input, and it can be used to generate different colors to different objects having the same material. In this node, we are having multiple sockets. However, out of all these, the most commonly used are the object index socket and the random socket. So first we'll understand about the object index socket in this node. So to see how it works, we first need to add a color ramp node that will allow us to set different colors for different objects in the scene. So press Shift plus A, then go to converter and select the color ramp node. Let's place it over here, connect the color socket to the base color, and by doing this, we'll get the base color depending upon the position of different pointers and their colors in the color ramp node. We'll fix the color later on, but before that, I'll first select all of these UV spheres by holding the Shift button, and do ensure to select this particular UV sphere having this material at the end. Then press Ctrl plus L to open the link menu and click on link materials. By doing this, we'll be having the same materials applied on all these UV spheres, and whatever changes we'll do to any node in the material will automatically get applied to all the objects having this material. Now we wanted to add different colors to different UV spheres having the same material. So to do this thing, we need to have same number of pointers in this color ramp node as the number of objects on which we have to apply this material. So we have 5 UV spheres, and so we need 5 different pointers in the color ramp node. So click on this plus icon 3 times to get 5 pointers, and to place them evenly distributed away from each other, click here and select distribute stops evenly. After this, with the first pointer selected, I'll change its color from black to the red color. Then for the second pointer, I'll change the color to the blue color, so I'll increase the brightness and change this to the blue color. Then for the third pointer, I'll change this to the yellow color. Let's also increase the brightness. Then for the fourth pointer, I'll change this color to the green color. At last, I'll select the fifth pointer and will change this color to the pink color. Now all of these are having the yellow color assigned because of this pointer at the center, which is having the yellow color. But now if I take the object index socket and connect it to the factor in the color ramp node, then what is basically happening is that this socket is passing an object index value which can be different for each of these objects, and depending upon that value, we'll have a different color assigned according to the position of these pointers in the color ramp node. But right now, all of them are having the red color assigned because for this first pointer, the position value is equal to 0 and also the object index value of each of these objects is 0 by default. And to change this value to get some different results, we have to open the object properties by clicking on this icon, then go to relations, and here you have the pass index option, which is basically the same as the object index value, and this particular value is equal to 0 for all the objects until you manually change it. For example, for this UV sphere, I'll change this value from 0 to 1, and by doing this, we get a different color, which is the pink color, and that is because this position value of this last pointer is having the value equal to 1, which is also equal or the object index value of this UV sphere. Similarly, I'll select this one also and we'll change the pass index value from 0 to 2. Let's do the same for this one also. So I'll change the value to 3, and for this one, I'll change the value to 4. Now the reason why the last 4 UV spheres are having the same color is that the color ramp node will only take a value ranging from 0 to 1 as the input, which means that for all the objects having the object index value greater than 1, it will only assign them the color at the maximum value of the position, which is equal to 1, and the color is pink. And to get the colors at these pointers in the middle, like the blue, yellow, green, having the position value in decimals like 0.5 or 0.75, we need to have a node in between the object info node and the color ramp that will divide this value of the object index by a specific number in order to give us numbers like 0.75 or 0.5. And for this we have the math node in Blender. To add it here, press Shift plus A, then go to converter and select the math node. Now place it in between the object info node and the color ramp. Now the math node will allow you to perform a mathematical operation on two values, the value 1, which right now is connected to the object index in the object info node, and the value 2, which we can control from here. Then by default, we have the add function selected, which means that it will take the value as an input and then it will add the second value to it and give the result as the output. But in this case, we need to reduce the numbers like 2, 3, 4 to decimal numbers like 0.5, 0.7, and so we have to use the divide function. Then in the value, we need to enter the number of objects on which we have to apply this material. So in this value, I'll enter 5 and press enter to confirm. And by doing this, you will notice that we are now having 5 different colors on these UV spheres, but all of them are still having the same material applied. One more thing that you can notice in these colors is that they are blending with each other. For example, in the last two UV spheres, you can notice the blending of colors like the yellow and the green color. Then here the green and the grey color are blending. And to fix this, we just need to change the interpolation type from linear to constant. And after this, we are now having different colors in different UV spheres. And yes, you can also try to change the position of different pointers in the color ramp node in order to change the colors of these UV spheres. Moving ahead, let's now understand about the other important socket in the object info node, which is the random socket. And as the name suggests, this one will randomly assign any color in the color ramp to any object on which the material is applied. To see how it works, I'll first remove the math node with the divide operation. So hold down the Alt button, left click and drag it away, then press X to delete it, and now take the random socket in the object info node and connect it to the factor in the color ramp. And with this, you will get completely random results of the colors for each UV sphere. So to conclude everything, we use the object info node in order to assign different base colors to different objects having the same material. And in that, we had two main sockets, where the first one was the object index, which made the use of this pass index value, and then we divided it by the math node because the color ramp node will take the input from 0 to 1. After that, we use the random socket in order to assign completely random colors to the UV spheres. And now before moving forward, if you want to download this Blender file with all the materials that we have saved in this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to use the object info node in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the arcade scene, and what we'll be doing is that we'll create multiple duplicates of this gaming machine, and then we'll use the object info node in order to assign different colors to the machine's body. So for this, I'll first switch back to the solid mode, then go to the top view by pressing 7 on the numpad. Let's zoom out, and we'll create its duplicates by pressing Shift plus D, move it in the y-axis and place it over here. However, along with the machine, we also need to create the duplicates of these game controls. So let's undo this by pressing Ctrl plus Z, then with the Shift key holded, select the game controls along with the machine. Now press Shift plus D one more time to create the duplicate, and we'll move it in the y-axis and place it over here. Now to repeat the same step again, press Shift plus R 2 to 3 times. And with this, we are now having a total of 5 machines in the scene. In a similar way, let's add some machines on this side also. So for this, let's select this machine, and then with the Shift key holded, select the game controls, then press Shift plus D to create the duplicate and move it in the y-axis and place it over here. Then to repeat the same step again, press Shift plus R 2 to 3 times. And after this, we are now having 9 gaming machines in the scene. Now let's go to the material preview mode and to assign different colors to the body of the gaming machine, I'll first select it, then go to the material properties, and we have to find the material, which is the dark blue or the purple colored material applied on the machine. So I'll select this material, and you can see that we have used the RGB node and the brightness contrast node in order to create this color. But for now, I'll select both of these nodes and press X to delete. Now press Shift plus A, go to input and select the object info node. We'll use this node to assign random colors to the bodies of different gaming machines. Now press Shift plus A again, then go to converter and select the color ramp node. Let's place it over here, and we'll use this color ramp node to create different pointers with different colors to be used as the base color. So first of all, change the interpolation type to constant, then click on the plus icon so that we can have 4 to 5 pointers. Then click here and select distribute stops evenly. Now with the first pointer selected, I'll change the color. So I'll first increase the brightness, and let's change this to the red color. Then for the second pointer, I'll select it, click here, increase the brightness, and for this one, let's choose the purple color, and I'll also make it slightly dark. After this, select the third pointer, click here, increase the brightness, and for this one, we'll choose the green color. Then for the last pointer, click here and change this to the light blue color. If you want, you can set any colors of your choice in any of these pointers of the color ramp node. Now to see the results, simply take the random socket in the object info node and connect it to the factor in the color ramp. Then take the color socket and connect it to the base color. And after this, we'll have different colors assigned to different machines, but all of them will still have the same material, which is saved with the name material in this file. And you can also see that for any of these machines having the different colors, if I try to change the metallic value, then the effect will be observed on all of them together. Also, you can try to change the position of different pointers in the color ramp node if you want to get different results of the colors for different machines. And with this, we now arrive to the end of this chapter. Today we understood about the object info node, and we even used the math node with the divide operation. So I've opened this materials file where in the last chapter we created these 5 UV spheres to understand about the object info node. But for now I will hide them by pressing H, and in the scene collection we'll unhide this UV sphere. And now the first topic for this chapter is to understand about the combine color node. So to see how it works, we'll be creating a new material. So go to the material properties, click on the plus icon, and then click on the new button. Now press tab to enter the edit mode, and with all the vertices selected, click on the assign button. After this, return back to the object mode, and to understand about the combine color node, let's go to the shader editor, press Shift plus A, then go to converter and select combine color. Let's place it over here. Now in this node, you can see that for the input, we have 3 options named as red, green and blue. And for the output, we have this color socket that in this case we'll use for the base color. Now the reason why we are getting the black color is that we have a value equal to 0 in the red channel, the green channel and the blue channel. Now for those of you who don't know, all of the colors can be created with different values of these 3 colors. For example, with the green and the blue value set to 0, if I slowly begin to increase the value of red channel, then you will begin to notice a slight red color being applied to the material. If I take this value to the maximum value of 1, then in this case, we'll be having the perfect red color applied to this UV sphere. Similarly, if I try to increase the value of the green channel, then you will notice that we are getting a mix of the red and the green color. And in the similar way, if I try to increase the value of the blue channel, then in this case, we get a result which somewhat looks like white color. And that is because when all the 3 values are equal to 1, then in that case we get the perfect white color. But whatever we did right now is not the actual function of the combined color node, because to actually understand about the working of combined color node, we also need to understand about the separate color node, because it is just the opposite of the combined color. So to understand how both of them will work, simply press Shift plus A, then go to converter and select separate color. Let's place it over here, and this node is just the opposite of the combined color node, because in this case we are getting the color as the input, and for the output it will give the values of the red channel, green channel and the blue channel, which means that if I change all these 3 values down to 0 and then take the red socket in the separate color node and try to change the color from here, then you will notice that for any color other than red, we are getting complete black color. And the reason is very simple. We are only taking the red channel for connecting to the combined color node. As a result, only the value of the red channel will be greater than 0, because for the other 2, we have manually entered 0, and therefore the color that we'll receive will either be black when the value of red is somewhere around 0, or it will be red if the value of the red channel is somewhere close to 1. But suppose I change this color to something like the pink color, and then I take the green socket and connect it to the green in the combined color. Then similarly, I'll also take the blue socket and connect it to the blue of the combined color. And by doing this, we'll get the same pink color that we used in the color input option of the separate color. And this is because we are now using all the 3 sockets together for defining the color. So in simple words, the separate color node will take the color as the input, and based on that it will give out the information about the red channel, green channel and the blue channel of that particular color. Then the combined color node will accept the values of different channels as the input and will give the result in the form of a color that can be used for the remaining nodes. Now these two nodes are something that you won't normally use in most of the cases, but you can only use them when you want that only the value of some specific channels of a particular color should be used to create a new color. Just like in this case, I used the pink color that was formed because of a combination of the red, green and blue colors, and we can even check their values by clicking here, and here you can see that currently for the pink color the value of red is equal to 0.8, then the value of green is equal to 0 and the value of blue is equal to 0.75. As a result, when I remove the node connection between the red channels, the value of the red channel in this node became 0. Then for the green channel, the value was already 0 for the pink color, but we connected the blue channel in the separate color and the combined color node, and here you can see that the value of blue channel is close to 0.75, and as a result, we are only getting the value of blue channel for the resultant color. If you want to understand it in even more detail, then I would advise you to practice using both of these nodes with different combinations of colors and different connections between the red, green and the blue channels. And now the next thing that we'll do in this chapter is to understand about the separate XYZ node. So to see how it works, I'll first select the separate color and the combined color nodes and press X to delete. Now press Shift plus A, then go to converter and select separate XYZ. Let's place it over here, and if you remember, the separate color node used to take a color as an input and then it separated it into three different channels that were red, green and blue channels. And just like that, the separate XYZ node will take a vector as the input and then it will separate that particular vector according to its X, Y and the Z components. Now to understand about it practically, we first need to have an input that we can use as a vector, and for this purpose we'll be adding the texture coordinate node. So press Shift plus A, then go to input and select texture coordinate. Let's place it over here, and before using it in the separate XYZ node, I'll first connect it directly to the material output to see what it does. So I'll take the object socket in the texture coordinate node and we'll connect it to the surface in the material output, and by doing this we'll get a texture on this UV sphere with different colors on different parts. Also, if I take the generated socket in the texture coordinate node and connect it to the material output, then in this case we'll again get a variety of colors, and this time the colors will be more blending with each other. Now let's go to the shader editor, and I'll first delete this principal BSTF node and we'll place this separate XYZ node in between the texture coordinate and the material output node. And by doing this thing, you will notice that on one side we are getting a black color and on the other side we have complete white color. Also, if I now take the object socket and connect it to the vector in the separate XYZ node, then in this case we'll be getting the complete black color on one side and the complete white color on the other side. So to understand what exactly is happening here, we first need to understand a very basic principle of colors and maths. So if you don't know, the black color represents the number 0 as per the color theory, and the white color represents the number 1. In fact, any shades of grey that you see in between the black and the white color also have a value of somewhere between 0 and 1, and in this case also the value of the vector is changing in the x-axis since we have used the x socket in the separate XYZ node. And with this direction tool that you can see here, this particular direction is the negative x-axis, and over here we have the positive x-axis, which means that the value of vector is changing from -1 to +1 from the negative x-axis to the positive x-axis. And for any value of the vector which is less than 0, the color will be black, and as a result, for all the values between -1 and 0, we are getting complete black color. But as the value begins to increase beyond 0, you will notice a slight grey color which slowly turns into the white color. Then over here, the color is completely white because the value of the vector is equal to 1. In a similar way, if I now change the socket in the separate XYZ node from X to the Y socket, then in this case, you will notice a similar thing happening in the Y axis. This time also, the value of the vector on this negative direction of the y-axis is equal to -1, then it will increase, and in the middle, the value will be 0, and after that, the value will begin to increase from 0 to 1 in the positive y-axis. And just like this, if I take the z-axis in a separate XYZ node and connect it to the surface socket in the material output, then again we see that in the negative z-axis, we have a value equal to -1 over here, due to which it is black in color. Then in the middle, the value will be equal to 0, and as a result, for all the values between 0 and -1, we are seeing the complete black color. And once the value begins to increase beyond 0, you will notice some slight grey color, and then the color will begin to turn into the white color, which is because the value of vector over here will be equal to +1. After this, let's also understand about the combine XYZ node. So go to the shader editor, press Shift plus A, then go to converter and select combine XYZ. Let's place it over here, and this node is just the opposite of the separate XYZ node. In this one, we'll take the inputs in the form of separate vectors and then we'll combine them into a single vector that we'll use as output. So if I take the vector socket and connect it to the surface in the material output node, then in this case, you will notice that the object is having the black color in all the directions. And this is because the value of the vector in all the three axes is 0 in this node. However, if I take the x-axis and try to increase it, then you will notice that we are able to see the red color, and this is because the x-axis is represented by the red color. You can also see this in this 3D viewport or this widget or the tool where the x-axis is having the red color, the y is having the green color, and the z is having the blue color. In a similar way, if I go to this node and change the value of x back to 0 and try to increase the value of y, then now we'll have the green color being controlled by the y-axis. Similarly, with the z-axis, we'll be able to control the blue color on the object. Now suppose I take the x-axis in the separate xyz node and connect it to the x-axis socket in the combine xyz node, then in this case, you will notice that for the faces pointing towards the negative x-axis, you will see the black color, and in the positive x-axis, you will notice the red color. And this is because the separate xyz node is telling us that the value of this vector in the x-axis is changing from -1 to +1, due to which in the region between the values of -1 and 0 we are having the black color, and after that when the value of the vector becomes greater than 0, the combine xyz node will tell this material that because of the connection with the x-axis, it will display the red color. In a similar way, if I break this node connection and use the y-axis in the separate xyz node to create the connection with the y-axis in the combine xyz node, then in this case, we'll notice a similar result where in the negative y-axis, the color will be black and then it will change to the green color in the positive y-axis. In a similar way, you can guess that when I'll use the z-axis socket for the connection, then in the bottom part, we'll have the black color and in the upper part, we'll have the blue color. So let's see this practically. So connect the z socket in the separate xyz node to the combine xyz node, and let's also break the node connection between the y-axis sockets. And just like we guessed, the lower part is having the black color and then the color will change to the blue color. Also, if you want, you can try to change the values in the x and the y-axis of the combine xyz node in order to create different types of combinations with different results. And yes, it might be possible that you would not be able to understand this concept in one go just by watching this video. And if that happens, then I would suggest you to rewatch the video from that specific part where you are having any doubts or confusion. And yes, before moving forward, if you want to download this particular Blender file with all the materials that we save throughout this course, then you can join the Patreon, whose link is added in the description of this video. And now is the time to use the concepts that we learned today in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the retro gaming arcade scene, and what we'll do today is to change the material of this text, and there we'll use the separate xyz and the combine xyz nodes. So to begin with it, I'll first change the mode to the material preview mode. Now go to the front or the side view by pressing 1 or 3 on the numpad, and after that we'll create a new material for this text by going to the material properties and clicking on the plus icon. Then click on the new button, and to assign this material that we just created, press tab to enter the edit mode, press Ctrl+A to select all the text and select the material and click on the assign button. After this, return back to the object mode, and let's now work on creating the material for the text. So by default, we have the principal BSTF node added, but let's also add the separate XYZ node in the shader editor. So press Shift+A, then go to converter and select separate XYZ. Let's place it over here. Then for the input, we need to add the texture coordinate node. So press Shift+A, then go to input and select texture coordinate. We'll place it over here and take the object socket to connect it to the vector in the separate XYZ node. After this node will separate out this particular vector that we used as the input into its X, Y and the Z components. So if I take the X socket and connect it to the base color in the principal BSTF node, then we'll get a change in color from black to white in this particular direction, which as you can see in this tool is the Y axis. Now you might be thinking that even though we used the X socket in the separate XYZ node, but still we are getting the change in color from black to white in the Y axis. And this is because when we initially added this text, we made some changes in the rotation of this particular text. And currently, this particular node will not take the modified rotation values for separating the vectors. In fact, if I press Alt+R to reset the rotation, then here you can see that with the default rotation of this text, we are having a change in color from black to white in the X-axis. Similarly, if I take the Y socket in the separate XYZ node, then we'll have a change in color from the negative Y-axis where we have the black color to the positive Y-axis where we have the white color. You can also check this from this widget tool where this direction is the negative Y and this direction is the positive Y. But for now, I'll press Ctrl+Z 2 to 3 times to get back the rotation of the text that we applied for the scene. After this, I'll go to the shader editor, press Shift+A, then go to converter and select combine XYZ node. Let's place it over here, and by doing this, we'll get the red color on this positive side because we have used the x-axis socket. In this node, if I try to change the value of y, then you will begin to get some green color on the text, and if I try to change the value of the z-axis, then you will begin to get some blue color on the text. Now to adjust these colors, we can also use the color ramp node. So to add it here, press Shift plus A, then go to converter and select the color ramp node. Let's place it in between the combine XYZ node and the principal BSDF. Now if I take this pointer, which is black in color, and try to move it around, then you will notice that we are able to change the area on which we are having the black and the white color. In fact, if I now try to change the value of the y parameter in the combine XYZ node, then the same thing can also be controlled with the help of this parameter. And in fact, you can even use it to create an animation where initially the color will be something which we set for this first pointer, and then there will be a change in color because of increasing the value of the y parameter in the combine XYZ node. For example, for the first pointer, I'll change the color, so increase the brightness from here, and let's change this to the green color. Then for the second pointer, I'll change this color to the red color, and after this, if I now try to change the value of the y-axis parameter in the combine XYZ node, then here we have a change in color from green to blue. In a similar way, we can also add some more colors in this node or change the colors in order to create this transition between the green and the red color. And yes, we'll also create an animation scene at the end of this course where we'll insert some keyframes for the y parameter so that we can create an animation showing the change of color of this particular text. And with this, we now arrive to the end of this chapter. Today we learnt about the 4 types of combining and separating nodes, and then we even use the concepts in this retro gaming arcade scene that we have been creating in this course. So I've opened this materials file where in the last chapter we studied about the separating and the combining nodes in the shader editor, and today our first topic will be to understand about the color ramp node. So we have already used the color ramp node a lot of times in this course, but we normally used it for understanding some other nodes. But today we'll again explore the color ramp node to understand each and everything available in this node. So for this, I'll first select this walnut texture material that we created in the chapter number 10 of this course, and to apply it, press tab to enter the edit mode, and with all the vertices selected, click on the assign button. After this, return back to the object mode, and we now have this walnut texture material applied to the UV sphere. And in this material, we used the color ramp node for creating these multiple colors that you can see in this texture. Now if I go to the shader editor, press Shift plus A, then go to converter and select the color ramp node and place it over here, then by default, the color ramp node will have only 2 pointers. The first one will have the black color and the other one will have the white color. And whichever pointer you select, its color and the position will be displayed over here. So if I select the black pointer, then its position will be equal to 0. As you can see here is the black color. Similarly with the second pointer, the position will be equal to 1 and the color, as you can see, is the white color. And yes, you can even move these pointers around by left clicking and dragging like this, and this will also change the position of that particular pointer. But for now, I'll press Ctrl plus Z to undo this, and yes, you might be thinking that what exactly is the use of moving these pointers around in the color ramp node. And to understand this, I'll try to move these pointers around in this color ramp node that we used for the walnut texture. So basically, by changing the position of these pointers, we can change the composition of different colors in the texture. And one more thing that you should keep in mind is that whatever color will have the more area in this color ramp will be displayed more in the texture also. For example, if I try to place all the other pointers very close to each other except for the red and the purple, then in this case you can notice that most of the area is being occupied by either the red color or the purple color. And the result of this is that in the texture also, most of the parts are having either the red color or the purple color. And yes, it is not like all the parts will have this exact red or this exact purple color, because many of them will also have the shades that you can see in between the red and the purple color. And yes, the same thing is also true for all these other pointers in this color ramp. Also, you can see in this color ramp that all of these colors are kind of blending with each other. And if you want to prevent that from happening, then you can go to the interpolation type by clicking here and change this from linear to constant. By doing this, we now have fixed colors that won't be blending with each other, and as a result, the colors that you get in the material will also be fixed and not the shades between any two colors. But for now, I'll change the interpolation type back to linear, and if you want to have all the colors equally distributed in the texture or the material, you simply need to click on this icon and select Distribute Stops Evenly. This will place all the pointers at an equal distribution or at equal spaces away from each other, giving us a texture or a material which has all the colors in equal proportion. And yes, obviously the amount of yellow color will be slightly higher, and this is because it is present in center and is surrounded by the purple color as well as the green color. Therefore, it is blending with both the colors, giving the shades of yellow on both the sides. After this, in this default color ramp node, if you want to add some more pointers, then you simply need to click on this plus icon, which will place a new pointer exactly in the center of the existing pointers. And if you want to delete the selected pointer, then click on the minus icon, and now we have only 2 pointers in the color ramp node. Then to change the color, simply click here and change the color like this. So this was all about the color ramp node available in the shader editor. And now moving ahead, the next topic for this chapter is to understand about the RGB curves node. So to understand how it works, I'll first delete this color ramp node by pressing X, and let's now add the RGB curves node. So press Shift plus A, then go to color and select RGB curves. Let's place it over here, and now this node is used to make some adjustments in the color that you input, and after making the adjustments, it will give the resultant color with the color output socket. So to practically see how it works, we'll place it in between the color ramp node and the principal BSDF. After this, you can see in this node that we have these 4 options named as CRGB. C stands for the combined channels, R stands for the red channel, then G stands for the green channel, and B stands for the blue channel. And whichever channel is selected over here, it will allow you to make the adjustments in the color of that specific channel. For example, with the red channel selected, whatever changes I'll do in this node will only get applied to the red channel colors in the material. Similarly for the green and the blue also, but if I select the combined channels, then in that case, whatever changes we'll make in this node will get applied to all the colors in the material. Now in order to make any changes in the material, you first need to left click anywhere on this curve. So if I left click here, then we'll have a new point created at that particular position. And if I left click to move it around and release the left mouse click, then after that you will notice some slight changes in the object's material and the color. So basically, on moving the graph in the upward direction, the brightness of the image or of all the individual colors will increase, and if I move it downwards like this, then in that case, the brightness of all the colors in the material will reduce. In fact, you can even try to adjust this position of this pointer on this curve at other places also in order to get different results. After this, if you want to have the default position of the curve back in this node, then simply click here and select Reset Curve. Now if you notice closely, then on the bottom and the front part also, we are having 2 different pointers, and each of these has a specific function that we'll just understand. So with this pointer selected, which is at the bottom, if I try to move it up, then the brightness of all the dark colors will increase, and this is because this particular pointer at the bottom is there to control the dark colors in the material. Just the opposite of this is this pointer on the top, which controls the bright colors. So if I bring it down, then in that case, the brightness of bright colors will be reduced. This effect will be noticed more on the colors like yellow and green, because these are the bright colors in this material. Similarly, other colors like red and purple are much darker, and therefore their brightness will be controlled by this pointer present at the bottom. After this, if I select this red channel and make any changes on this curve, then its effect will be more visible on the red channels of different colors in the material. For example, if I bring this completely down, then you will hardly notice any red color in the material. However, if I take this pointer and drag it upwards like this, then in this case, you will notice a lot of red color in this material, which is because of the adjustments that we made in the red channel. Similarly, if I reset the curve and change this to the green channel and then try to make the adjustments like moving the curve up, then they will get applied to the green channels of the color in the material. And the same thing is also true for the blue channel in the RGB curves node. On moving the pointer upwards, that specific color will be displayed more in the texture, and on moving it downwards, you will hardly notice it in the texture anymore. So in the end, I would suggest you to try changing the curve for different channels and notice what changes you see in the colors of the material. But for now, I'll remove this node by pressing Alt, left clicking and dragging this away, and press X to delete. And now let's move to the next topic of this chapter, which is to understand about the invert color node. So to add it here, press Shift plus A, then go to color and select invert color. Let's place it over here. Now the invert color node will basically invert the color that you add as the input, and then it will give the resultant color as the output. See how it works? I'll connect this color socket, which is for the output, directly to the material output node, and after this, you will notice that the color of the UV sphere will turn to the white color. However, in the color option that you see here, we have the black color selected, and since it is the invert color node, so it will invert that color from black to white and give the result as the white color. Similarly, if I go to the color option and increase the brightness, then in that case, the input color will be white, then it will invert the color and change it to the black color. Just like this, if I go to the color option again and change the color to suppose blue, then in that case, we'll get the color which is the opposite of blue in the color wheel, meaning the yellow color. And the same thing is also true for all the other colors in the color wheel. Whichever color you select, the resulting color will be somewhat similar to the color opposite to it in the color wheel. Then you have the factor value using which you can control the influence of the inversion of colors. So yeah, in the end, this node is not something that you would normally use for creating any materials, but you might want to use it in some cases where you have some particular color as the input, and instead of making some changes directly in that color, we can use this node to invert that particular color. Now before moving forward, if you want to download this Blender file containing all the materials that we have created in this course, then you can join the Patreon, whose link is added in the description of this video. And now it's the time to use some of the concepts that we understood today in the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the arcade scene, and in this chapter, we'll be adjusting the color of the brick texture on this wall by using the RGB curves node. So I've selected this plane, then go to the material properties, select the brick material, then go to the shader editor, and to add the RGB curves node, press Shift plus A, then go to color and select RGB curves. We'll place it in between the brick texture and the principal BSDF node. After this, with the combined channel selected, if I add a point somewhere in the middle of the curve and move it in the upward direction, then in that case, the brightness of the colors will increase and we'll get the result where we'll have more of bright colors like yellow applied to the texture. Similarly, if I move this pointer in the downward direction, then in that case, we'll have more of the dark colors like the red color applied on this texture. But to get a realistic look, we have to make some adjustments in such a way that the pointer is somewhere close to the center of the curve only. In fact, if you want, you can even change this from combined to the red channel and then make the adjustments individually in the red color. Also, you can try to do a similar thing with the green channel or the blue channel by changing the curve like this. So it basically depends that which particular colors you want as the more prominent colors for the brick texture of your scene. And using the RGB curves node is definitely a better way to make the adjustments as compared to manually selecting the colors and then making the adjustments in the color wheel. And for now, I think that the texture on this wall is having the perfect colors. So finally, we now arrive to the end of this chapter. Today we learned about the color ramp node, the RGB curves node, and even the invert color node. So I've opened this materials file where in the last chapter we studied about some of the advanced color controls like the color ramp node, RGB curves node, and the invert color. And today let's understand about another important node named as the displacement node. So to see how it works, we'll be creating a new material for this UV sphere. So go to the material properties, click on the plus icon and then on the new button. Then go to the edit mode by pressing tab, and with all the vertices selected, click on the assign button. After this, return back to the object mode. And now let's add the displacement node in the shader editor. So press Shift plus A, then go to vector and select displacement. Let's place it over here. Now as the name suggests, the displacement node is used to displace the surface along the surface normal, and it is used to add more details to the geometry. To explain it in even simpler words, it will basically take a texture as an input, and depending upon the texture, it will create a material that will make the UV sphere look like it has some detailing on it. To see it practically, I will be adding the noise texture node in the shader editor. So press Shift plus A, then go to texture and select the noise texture. Let's place it over here. Now take the factor socket and connect it to the height in the displacement node. After this, take the displacement socket and connect it to the displacement in the material output. And by doing this, you will notice that we are having a texture applied on this UV sphere which is giving it a very detailed look. In fact, I can go to the scale value in the noise texture, and if I try to increase it, then in this case, the scaling of the texture applied will also begin to change as per the scaling in the noise texture. Now you can understand what's happening in this way, that the displacement node is basically displacing the surface of the UV sphere depending upon the noise texture, which also gives it a realistic look as if we have created it with a lot of detailed geometry. Like you can clearly see that it is having a kind of 3D appearance, but in reality, if I change the mode from render to the solid mode, then in this case, we are having a very simple UV sphere with no such detailing. So the displacement node simply created a fake geometry type of thing, which is nothing but a material or a texture only applied on this UV sphere. Now you can use any node apart from the noise texture also to see how the displacement will work. For example, if I go to the shader editor and press Shift plus A, then go to texture, and now suppose I select the magic texture node and place it over here. Now take the factor socket and connect it to the height in the displacement node. Let's also connect the factor socket to the base color, and by doing this, you will get a texture where the displacement of the surface is being done according to the magic texture. In fact, you can even try to change the depth to see the changes in this texture. Also, if I disconnect the connection between the displacement node and the material output node by holding Ctrl, right click and dragging the cursor like this, then after that, if I take the factor socket of the magic texture and connect it to the base color, in the principal BSTF node, then basically this is how the original texture was looking when the factor socket was used. And the displacement node is also performing the displacement based on this texture, which you can also notice when I connect the displacement socket to the material output. Like right now, we have the exact same pattern displacing the surface, giving it a 3D appearance. So this is a very useful node which you can use to create a texture or a material, giving your object a highly realistic and a detailed appearance. Now before moving forward, we'll be saving this material in the material library. So first of all, let's rename it from here, and I'll change its name to magic displacement. And after this, press enter to confirm, and to save this material, go to the scene collection, and in the sphere, select the magic displacement, then right click and select mark as a set, and the material will now get saved in the material library that we created in the chapter number 1. To check that, I'll change this window from the shader editor to the asset browser. And as you can see here, we are having the magic displacement material added in the material library. Also, if you want to download this complete Blender file with all the materials that we are saving in this course, then you can join the Patreon, whose link is added in the description. And now it's the time to use the concept of the displacement node in the retro gaming arcade scene that we started creating in the chapter number 1. So I've opened this file with the arcade scene, and today we'll be modifying this material which is around the screen of the arcade machine. Previously, we created the wood texture for all these parts of the model, but in this chapter, we'll make some changes in it and we'll also use the displacement node. So for this, with the machine selected, select the wood material in the material properties, then go to the shader editor, and to ensure that whatever changes we make get saved in a separate material and not in the wood material, we'll be creating a duplicate of the wood material. So click on this icon, and after this, let's first add the displacement node in the shader editor. So press Shift plus A, then go to vector and select displacement. Let's place it over here, and now I'll take the displacement socket and will connect it to the displacement in the material output. Then for the texture of the displacement, I'll take the factor socket in the noise texture and will connect it to the height in the displacement. And by doing this, the way this texture is looking has completely changed. But right now, the changes will be applied only on the selected machine, and that is because we had created a duplicate material which is right now only applied to the geometry of this machine. So let's first make the changes in the material and then we'll apply it to the rest of the machines. Now it's up to you if you want to change the scale value in the noise texture to change the scale of the displacement in this material or not. But for now, I'll keep the scale value to somewhere around 10, and apart from this, I also think that instead of the wood material, we should be having a silver colored reflecting material with the displacement effect on it for all these parts that are currently having the wood material. And to achieve this result, we simply need to change the colors in the color ramp node. So first of all, I'll select this pointer which is black in color and will change the color something like white, and in a similar way, I will select the second pointer also and will change it to the white or the grey color. So let's increase the brightness and let's also change the color in the color wheel. And by doing this, we are now having a material with only the white color, and this detailing is because of the displacement node. Also, to keep the focus only on this object, simply press the forward slash button in the keyboard, and now we can focus only on the selected object. Now if I zoom in, you can clearly see the detailing that is now added because of the combination of the noise texture and the displacement node. And then because of setting the white color for both the pointers in the color ramp, we get a color like this as the result. In fact, using the color ramp node is not even important right now, and that is because we are only using a single color and not a combination that we can also do directly by the base color option. But for now, I won't be removing this node because who knows, we might want to change the colors in the upcoming chapters or while finalizing the scene. Also, to give it a metallic look, simply go to the principal BSTF node and increase the metallic value, and let's also bring down the roughness value. And by doing this, we have created a material which has a silver color and a lot of detailing and realism because of the displacement node. Let's now apply the same material for the remaining models also. So I'll go to the solid mode first. After this, I'll select this 3D model, and with the wood material selected, click here and select wood.001. Now let's repeat the same procedure for this machine also. Select the wood.001, then similarly for this one also, let's select the duplicate material of the wood. Then for this one, let's change the material to the duplicate in a similar way. I'll also select this machine, then in the material properties, I'll select the wood material and we'll change this to wood.001. In a similar way, let's do the same for the remaining 3 also. Now I'll select this one, then change the material, and at last, I'll select this machine, change the material to wood.001. And with this, let's also go to the rendered view, and I might have made some mistake in applying the material for this particular machine. So to solve the issue, let's change this material that was the original one for the body of the machine, then go to the material properties, select the wood material and change this to wood.001. And finally, this brings us to the end of this chapter. Today we learned to use the displacement node, which allowed us to add some realism, a 3D effect and some detailing to our materials. I I've opened this materials file where in the last chapter we used the displacement node along with the magic texture to create this amazing material, and in this chapter we'll be exploring the wave texture node. So to see how it works, I'll select the UV sphere, then go to the material properties, and let's now create a new material. So click on the plus icon, then click on the new button, and to apply this material to the UV sphere, press tab to enter the edit mode, and with all the vertices selected, click on the assign button and then return back to the object mode. Then go to the shader editor, press shift plus A, then go to texture and select the wave texture. Let's place it over here, then left click, and now if I connect the color socket to the base color, then as you can see, the wave texture node added these procedural bands on the object's material. In fact, we can even change the wave type from bands to rings, and this will give us this texture with the procedural rings instead of the bands. So you can choose any of the two, either the bands or the wings, for the object's material. Then in this node, you also have the option to control other things like the scale value that will change the scaling of the texture. Then you have the distortion value, and if I increase it, then this will control the amount of distortion of these waves. Then you have the detail, and if I increase it, then this will increase the amount of the distortion noise detail. Then you have the option to control the detail scaling that will control the scaling of the distortion noise. So if I zoom in right now, you can see that the distortion effect is hardly visible because of increasing the detail scaling, which in turn increase the distortion noise. So let's reduce it for now somewhere around 1 or 2, and we again have the distortion effect visible on this texture. After this, by using the detail roughness, you can control the blending. Like if I change it to 0, you will get a smoother noise pattern, and if I increase it to the maximum, which is equal to 1, you will get a rough pattern. So by using these different parameters, you can change the way how the wave texture will look on the material. For example, you can control the detailing, the amount of distortion which is added to the texture. If you take it to a very high number, then the material will look something like this because of a lot of distortion in the wave texture. But for now, let's reduce this value to somewhere around 3 or 4, where we can see the band-like pattern properly on the material. So I've kept the distortion value to 2. Then you can even control the scale value in order to fix the overall scaling of the texture. But even after all this, the texture looks kind of very simple, and if you want, we can give it a highly detailed and realistic appearance with the help of the displacement node. We studied about the displacement node in the last chapter of this course, where we used it along with the magic texture and the noise texture node. And today, let's use the same node along with the wave texture. So press shift plus A, then go to vector and select displacement. We'll place it over here, take the displacement socket and connect it to the displacement in the material output. Then for texture, we'll take the color socket in the wave texture and connect it to the height of the displacement node. And by doing this thing, you will notice that we are having a 3D looking highly detailed texture, which is because of the displacement node. So this node basically displays the surface of the UV sphere as per the wave texture applied to the material. Now before moving forward, we'll save this material in the material library. So first of all, I'll bring down the scale value in the wave texture to around 8 or 9, then click here to rename the material, and let's change its name to wave displacement. And to save this material, go to the scene collection, select the material in the UV sphere, then right click and select mark as a set. And by doing this, the material will now get saved in the material library that we created in the chapter number 1. You can even check it by changing this window to the asset browser. And now over here, we have the wave displacement material saved in this library. Apart from this, if you want to download this particular Blender file with all the materials saved that we have been creating in this course, then you can join the Patreon, whose link is added in the description. And finally, let's also understand about the practical usage of the wave texture node in the retro gaming arcade scene that we started creating in the chapter number 1. So I've opened this file with the arcade scene, where in the previous chapter, we created the silver material with the displacement effect that we used to add some detailing, and in this chapter, we'll be using the wave texture node on this material that we have used for the body of the machine. So for this, with this machine selected, let's go to the material properties and select the material that we applied on the machine body. Now to add the wave texture node, go to the shader editor, press shift plus A, then go to texture and select the wave texture. Let's place it over here, and right now, if I connect the factor socket to the color ramp node, then in this case, we'll have the wave texture applied to all these machines with the colors depending upon the pointers in the color ramp. But instead of doing this, I'll press Ctrl plus J to undo, and we'll be using the displacement node to create a 3D effect and add some detailing to this material. So go to the shader editor, press shift plus A, go to vector, and select displacement. Let's place it over here. Now take the displacement socket and connect it to the displacement in the material output. Then I'll take either the color or the factor socket and will connect one of them to the height socket in the displacement. And by doing this, you will notice this band-like pattern appearing on the material applied on the machine's body. In fact, to see the material in a better way, I'll select one of the machines and press the / button to keep the focus only on the selected object. And now you can see the effect of the wave texture and the displacement node on the material of this machine. You can clearly see that it is creating this up and down pattern, which is clearly visible over here and also on this top face, and all this is because of the displacement node that we have used in the material, because it is displacing the surface of the material according to the wave texture. Apart from this, you can change the scale value of the wave texture to change the scaling. Then you can add some distortion to create a zigzag type of pattern, or maybe add some detailing to it, but I won't be making much changes in the texture because right now I think that the texture which is applied on this machine is looking highly detailed and realistic. So for now, I'll press the / button to remove the focus from the selected object. And finally, this is how all the machines are looking with this new material applied to their bodies. And also, this brings us to the end of this chapter. In this chapter, we learned about the wave texture node and its practical usage in this arcade scene. So I've opened this materials file where in the last chapter we used the wave texture to create this material, and now we'll be understanding about the sky texture node. Now as the name suggests, the sky texture node is basically used to add a procedural sky texture to the scene, and the distinct feature about this texture is that it is not used for creating any object's material, but rather it gets applied on the entire scene, or basically the 3D background. So to see how this texture works, go to the shader editor and we need to change the shader type from object to world. After this, I will delete both of these image texture nodes by pressing X, and to add the sky texture, press Shift+A, go to texture and select the sky texture. We'll place it over here. Now I'll take the color socket in the sky texture and connect it to the color socket in the background node. The reason why we can't see any changes in the scene is that we have disabled the scene world in the viewport shading. So let's turn it on, and now you can see that we are having the sky texture applied to the background or the environment. To see it properly, I will select this plane and press H to hide. Now by default, this particular sky texture is very bright, and to control its strength, simply go to the background node and let's reduce the strength from 1 to around 0.1 or 0.2, and this will give us a realistic looking sky texture. Now in this node, you have many settings using which you can control the way this texture looks. For example, if I try to increase the sun intensity option, then we will get a higher intensity of the sun and its effect will be visible on the reflecting side of the object. So if I reduce it down from 200 to somewhere around 5 or 6, then you can clearly see the difference of the sun intensity on the object's material. So for now, I'll set this value back to the default one. After this, you have the sun elevation, and by changing this value, we can change the angle of sun in this texture from the horizon. You can clearly see the change in the angle of shadow on changing the value of sun elevation. In a similar way, you can also make the changes in the sun rotation value, and yes, all these changes will directly impact the reflections, the lighting effect, and the shadows falling on the objects in the scene. After this, in the sky texture node, we also have an option to control the altitude value, and this value will control the distance or the height from the sea level. And to see its effect in the scene, we need to increase this value to a very high number. For example, if I change the value of altitude to something like 5000 meters, then in this case, you will notice that this sky texture is a lot different from the original one. It appears more blue in color because of the higher value of altitude. After this, we have the option to control the density of air molecules, the dust molecules, and the ozone layer. So if I try to increase the value of the density of air molecules, then this will give us an orange or red color on the sky texture. Similarly, you can also try to change the density value of the ozone layer or the dust, and each of these values will give your sky texture a unique appearance. Now let's also understand about making a perfect sky texture that you can use for your scene with the help of the sky texture node. But before that, if you want to download the Blender file containing all these materials and these textures that we are saving in this course, then do join the Patreon of this channel by using the link given in the description. And now to continue with this chapter, let's create a perfect sky texture, and for this I'll open the retro gaming arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the arcade scene, and to create a sky texture with any of the objects selected, go to the shader editor and change the shader type from object to world. After this, to add the sky texture node, press Shift+A, then go to texture and select the sky texture. Let's place it over here and connect the color socket to the color in the background node. After this, to view the results, do ensure to turn on the scene world in the viewport shading menu. After this, to reduce the strength of the background, go to the background node and let's keep the strength to something like 0.1. Now in the sky texture node, we'll keep the sun size value to the default, which is around 0.5 degrees, and also the value of sun intensity will be set to the default one. But for the sun elevation, let's increase this to somewhere around 100 degrees, and then also change the sun rotation value to around 90 degrees. After this, for the altitude value, change this to around 5000 meters in order to have a blue sky texture. Then in the density of ozone, I'll increase this value to the maximum of 10 in order to make the blue color of the sky even more realistic. And with this, we now have a texture for this background which actually looks like the sky texture, and you can also use this for any other scene that you're creating and you want to add a blue colored sky in the background. Apart from this, I'll also reduce the strength in the background to around 0.05 to reduce the effect, and now it looks perfect. In this chapter, we understood about the sky texture and its practical usage, and in the end, we even used this node in order to create a realistic looking sky texture for the scene. So I've opened this materials file where in the last chapter we learned about the sky texture node, and in this particular chapter our target is to understand about a very basic node which is called the wireframe node. So to see how it works, I'll select this UV sphere, then go to the shader editor and I'll change the shader type from void to object. Now we have this material with the wave texture and the displacement applied on this UV sphere. But to create a new material, go to the material properties, click on the plus icon, then click on the new button, and to apply this material, press tab to enter the edit mode, press A to select all, and then click on this assign button. After this, return back to the object mode, and to use the wireframe node, go to the shader editor, press shift plus A, then go to input, and here you have the wireframe node. So I'll select it and place it over here. Now this wireframe node is used to retrieve the edges of an object as it appears to cycles. You will understand this in a much better way when we practically use this node while creating a simple material. So for this, I'll take the factor socket in the wireframe node and will connect it to the base color in the principal BSDF. And by doing this, you can see that we are having a material applied on the UV sphere which looks like the wireframe display of an object. But one more thing that you can notice in this material is that it is forming these triangulated faces. But if I actually go to the edit mode, let's also switch to the solid mode, then here you can see that originally the UV sphere is having only square shaped faces and not triangulated. And this is the feature of the wireframe node. Whenever we use it, it will always create triangulated faces in order to form the wireframe material. Then over here, you have this option to turn on the pixel size, and if I turn it on and wait for a few seconds, then you will begin to notice that it is now appearing as a dot-like pattern which is forming the same pattern. But for now, I'll disable the pixel size, and then we have the size parameter, and by using it, we can control the thickness of these edge lines. So in the end, the wireframe node is a very simple node that can be used to create a fake look of the wireframe display of any object in your scene. Now before moving forward, if you want to download this particular Blender file containing all the materials that we have created in this course, then you can join the Patreon, whose link is added in the description. And now is the time to use the concept of wireframe node that we just understood in the arcade scene that we started creating in the chapter number 1 of this course. So I've opened this file with the retro gaming arcade scene, and in today's chapter, we'll be creating the side walls of this scene, and then we'll use the wireframe node in its material. So to do this thing, let's go to the solid mode, then select the plane, then go to the front or the side view, press tab to enter the edit mode, then press 2 for the edge select mode, select these two edges, and now press E to extrude them in the x-axis, then left click and also return back to the object mode. After this, to create a new material for the side faces, I'll first change the shader type to object in the shader editor, and after this, go to the material properties, click on the plus icon, and then create a new material. Now I'll change the mode from solid to the material preview mode, and here we notice that right now we are having the brick texture material applied on the side faces. So go to the edit mode, press 3 for the face select mode, and we'll now select both the side faces together with the shift key holded. Now select the material in the material properties and click on the assign button. After this, return back to the object mode, and now let's create the material for these walls with the help of the wireframe node. So press shift plus A, then go to input and select wireframe. Let's place it over here. Now connect the factor socket to the base color, and by doing this, we'll get this material applied on the side faces. However, the reason why we are not seeing a large number of faces on this material is that both of these faces in the edit mode has 0 subdivisions by default. So to fix this, I'll first select this face, then right click and select subdivide. After this, go to the subdivide menu and increase the number of cuts to around 16. And after this, you will now have a perfect material created with the wireframe node. Let's do the similar thing with this face also. So go to the edit mode, select this face, right click and select subdivide. Then in this menu, change the number of cuts to 16 and return back to the object mode. So till now we applied our knowledge of creating a very simple looking material with the wireframe node, but now suppose you want to change these colors from black and white to something else, and we can do this thing by using the color ramp node. So to add it here, press shift plus A, then go to converter and select color ramp. Let's place it in between the wireframe and the principal BSDF node, and after this we are having two pointers in which the black pointer will control the color of the black part of this material and the white pointer will control the color of the white part of this material. For example, with this black pointer selected, if I click here and increase the brightness, then you will notice that the color of the black part has now changed. So by using the color wheel, I'll change this color to orange, and in a similar way, you can also set any color for the second pointer instead of the white color. In this way, you can add colors of your own to this wireframe material with the help of the color ramp node. Let's also switch to the rendered preview mode in order to see how the material will finally look in the scene. Now before moving forward, we can also apply some emission effect on this material, and to do this thing, go to the principal BSDF node, and in the emission, we have the option to control the emission color and the emission strength. But instead of manually putting the emission strength, we can directly use this factor socket of the wireframe node. So let's connect this to the emission strength, and by doing this, you will notice the emission effect being added on this material on the side walls, and you can also control its color by going to the emission color, and for now, I'll change this color to light blue. After this, if I try to increase the value of size, then it will not only control the size of this edge pattern, but along with that, it will also control the emission strength. So for now, I'll keep this value of the size to around 0.02, and now it looks perfect. And with this, we now arrive to the end of the chapter number 20. Today we understood about the wireframe node in Blender that we also use to create the materials of the side walls. So I've opened this file of the retro gaming arcade scene, and till now we have created a number of different materials for different objects in the scene. For example, the brick texture for the wall, this tile material for the floor, then we created this wireframe material for the side walls, then we used the wave texture and a variety of different nodes to create these materials for the gaming machines. And now the first thing that we'll do today will be to create some simple seats or some gaming chairs that we'll keep in front of these machines. So for this, let's first add a cylinder in the scene. So press Shift plus A, go to Mesh and select Cylinder. To focus only on the cylinder, press the forward slash button. Let's zoom out, press Tab to enter the edit mode, press S to scale it down, and then to increase its length, we'll scale it up in the Z axis and left click to finalize. After this, return back to the object mode, and this will be used as the bottom part of the seat. Now for the top of the seat, let's add a cube. So press Shift plus A, then go to Mesh and select the cube. Press Tab to enter the edit mode. Let's scale it down in the Z axis and also press S to scale it up like this. Let's again reduce its height, and after making the adjustments in the size, return back to the object mode. Now to convert this cube into the chair seat, we'll be using the bevel tool to make this slightly rounded at the corners. So go to the edit mode, press A to select all, then press Ctrl plus B to apply the bevel tool, then move the cursor away, and to increase the number of segments, we'll be using the scroll wheel. So I'll keep the number of segments to around 7 or 8 and left click to finalize. After this, return back to the object mode, let's move it up in the Z axis and place it over here. After this, right click and apply Shade Auto Smooth, create a duplicate, then right click to cancel the movement, and we'll be using this duplicate cube to create the back of the chair. So let's rotate it in the Y axis by 90 degrees and press enter. Let's go to the front or the side view, press G to move it and place it over here. And with this, we have created a very simple seat that we can place in front of the machines. So let's select all these three parts and press the forward slash button again to remove the focus from these objects. Now to place them properly, let's go to the top view by pressing 7 on the numpad. Let's zoom out, press S to scale this down, press G to move it and place it over here. Let's scale it down again. Let's also change the angles, and right now we should also change the rotation of this chair in the Z axis. So press R, Z and enter 180 in the numpad, then press enter, and with this we now have a simple chair created which is also rotated in such a way that it faces the gaming machine. After this, we'll create some more seats, but before that, let's create a very simple material. So with this cube selected, go to the shade editor, click on the new button, and I'll be adding the wireframe node. So press Shift plus A, then go to input and select wireframe. Let's place it over here, take the factor socket and connect it to the base color. After this, let's adjust the scale value, and I'll keep it to somewhere around 0.1, and now it looks perfect. Then if you want to change the color of the material, then we'll add the color ramp node in between the wireframe and the principal BSDF. So press Shift plus A, then go to converter and select the color ramp node. Let's place it over here, and for the white pointer, I'll change this color to something like blue or purple, and yes, it totally depends upon you that which particular color you want to use for any of the two pointers. Right now, I have selected the light green color for the base material. Moving ahead, I'll now select this particular seat, and to apply the same material, I'll first select this one and check the name of the material, which is material.017. Then select this object, click here and type 017, and then here we'll have that particular material. So I'll select it, and it is now applied to this object also. After this, I'll select the cylinder at the bottom, and let's create a very simple material with a metallic look. I'll increase the metallic value to around 0.7 or 0.8, and let's also bring down the roughness value. Then in the base color, I'll bring down the brightness slider to make the color slightly darker or something similar to the grey color. Moving ahead, I'll also switch to the rendered preview mode in order to see how the scene will look in the final rendered version. So right now, the simple chair that we created is looking perfect in the scene, and so we'll work on creating a few more chairs. So for this, I'll first select all the three parts of the chair, then go to the top view, let's zoom out, and before creating the duplicates, press G to move it and place it over here. Then press Shift plus B and move the duplicate in the Y axis. Let's place it over here. And to repeat the same step a few more times, simply press Shift plus R shortcut the required number of times. And with this, we'll be able to create any number of chairs in the arcade scene. Apart from this, I'll also select a few chairs and will rotate them in the Z axis. For example, with this chair selected over here, I'll press RZ and type 180 to rotate it in the Z axis by 180 degrees. But yes, it's not compulsory to change the rotation in the Z axis by exact 180 degrees. If you want, you can keep the rotation at some random value also. But because of doing that, its position might get slightly displaced as compared to the rest of the chairs. And if that happens, you simply have to move it back at the original position like this. Moving ahead, let's do the same with another chair that we'll randomly select out of all these. For example, I'll select all the objects related to this chair like the seats and the cylinder, and let's rotate it in the Z axis by 180 degrees. Apart from this, I'll also make a few adjustments in the image textures that I've added for these gaming machines. For example, the front screen of all these machines is having the same image, but what I'm gonna do is that I will assign some random images that we downloaded in the chapter number 7 by learning about the image texture node. Also, I'll drop the link of all these images that I'm using in this project in the video description. So right now, I'll press tab to enter the edit mode of this particular machine, select this face which is for the screen, and currently it is having the material.011 applied, but I'll change this to the other material on which we used the warrior image. So with this material selected, I'll click on the assign button to apply this material. Similarly, I'll select this one also, press tab to enter the edit mode, select this face, and for this machine, I will apply this material on which we have used the image of Mario. So click on the assign button to apply this image and return back to the object mode. But yes, it might be possible that you want to change the scaling and the position of this image on the selected face. And to do that thing, we need to use the UV editor about which we learned in the chapter number 7. So press tab to enter the edit mode, and with the face selected, I'll change this window from shader editor to the UV editor. Now we'll select these 2 points over here, press G to move them in the X axis and place them over here. Then left click and return back to the object mode. Now in a similar way, let's randomly apply different images on the front screens of the gaming machines. So for the selected machine, I'll again use the Mario image, and in the UV editor, I will select these 2 points and will move them in the X axis like this. Let's return back to the object mode. After this, I'll select this particular gaming machine, tab into the edit mode, select this face, and for this we'll use the material.012 on which we applied the warrior image texture. Click on the assign button, and after this, return back to the object mode. After this, let's also change this window back to the shader editor. Then with the machine selected, I will go to the material properties and select this original material that we applied to the machine bodies. And instead of using this light blue color, I'll change this to some other color. And for this, I'll go to the color ramp node, select this light blue pointer and change the color by clicking here. So in the color wheel, you can choose any color that you want, but for now, I will select the pink color in the color wheel. And after this, our scene is now looking almost ready. So let's go to the camera view by pressing 0 on the numpad. Let's zoom out, and before seeing the rendered preview, let's make some changes in the camera object. So I'll select the camera in the scene collection, then go to the object data properties, and in the viewport display, change the passive partout value from 0.5 to 1. By doing this, we'll only see the region that is within the camera view. Now to adjust the camera view, click on this lock icon and then use the scroll wheel or the combination of the middle mouse button and the control button in order to change the camera view. After this, we'll disable the lock camera to view by clicking on this lock button and then go to the rendered preview mode. And finally, this is how our retro gaming arcade scene is now looking in the rendered preview mode. So first of all, with this camera view, let's render a sample image by going to the render option and clicking on render image. Then this window will appear where we are seeing the lighting effects because of the scene lights that we added in the scene, and we can also see this portal object that we have hidden in the 3D viewport. So to adjust all these things, let's first cancel the render by closing this window. Then in the scene collection, here we have that portal with the name circle, and to disable its presence even in the final render, simply click on this camera icon. After this, the reason why we can't see the effect of lighting in the 3D viewport is that we have turned off the scene lights and the scene world. So I'll turn both of them on in the viewport shading menu. After that, I'll select this default light that is present over here and press X to delete. After this, most of the region in this arcade scene is pretty much dark. However, the reason why we have so much light on this bottom part is the presence of the sky texture that we added in one of the previous chapters. So to fix this, I'll go to the shader editor, change the shader type from object to world, and to remove the sky texture node, hold on Alt, left click and drag it away. Then in the background node, I'll change the strength to default 1, and with this, the arcade scene is now completely dark. So we can now work on creating some lights and placing them at different positions for the arcade scene. And to do this thing, let's first go to the solid mode. Now press Shift plus A, go to light and select the area light. Let's move it up in the Z axis. Let's also scale it up by pressing S, and after this, we'll move it in the X axis. Then go to the top view by pressing 7 on the numpad, and we have to make this light point towards the gaming machines. So press R to rotate it in the Y axis like this. Let's change the angle, and here you can see that this area light is now pointing towards the gaming machines. Let's also rotate it slightly in the X axis and left click to finalize. After this, go back to the top view, let's zoom out, move it slightly in the Y axis, and now let's go to the render preview mode in order to see if there is any effect of the lighting added in the scene. And right now, you can clearly see that there is hardly any effect of this light on the scene. And that is because the power of this light is very low by default. You can change the power by going to the object data properties. So I'll change this from 10 watt to something like 150 watts. And now you will notice some light added in the scene. Apart from this, you can also set any particular color for the light by changing it in the color option. But for now, I will choose the original white color for the lights. Now with the area light selected, we'll create its duplicate by pressing Shift plus D and move it in the Y axis like this, and then let's also rotate it in the X axis and we'll make it point towards the opposite direction. After this, I'll select both of these lights by holding the Shift button, and to create the duplicates, press Shift plus B, let's move them in the Y axis and place them over here. Similarly, for some more lights, let's repeat the same procedure again by using the shortcut Shift plus R. Now let's change the angle, and currently our scene is having a decent lighting where we can properly see the basic details. However, to improve this, we'll be adding some more lighting. So I'll go to the solid mode, let's change the angle, and we'll select all of these lights by holding the Shift button. After this, we'll create the duplicates by pressing Shift plus B and move them down in the Z axis like this, and left click to finalize. Then go to the rendered preview mode in order to see the effect of the lighting in the scene. And finally, this is how our scene is looking with a very basic lighting setup. Now before moving forward, I'll also make some changes in the silver colored material that we applied on these boundaries of the gaming machine. So with the machine selected, go to the shader editor, change the shader type from world to object. Let's also go to the material preview mode and select that specific material that we used on these faces. And yes, it might be possible that you are not able to search for that exact material that we used, and if that happens, simply go to the edit mode and select that particular face on which we have applied the material. By doing this, that specific material will automatically get selected in the material properties. Now return back to the object mode, and what I'm going to do is to convert the color of this material from white or silver to something like gold or the yellow color. So I'll go to the color ramp, and with the first pointer selected, let's change the color to the yellow color. After this, I'll select the second pointer, and for this one also, I will choose the yellow color. And because of this, our material is now looking like the gold metal. After all these adjustments, we are now ready to render this scene. So for this, go to the render menu and select render image. Then this window will open where we have the image of the arcade scene being rendered in cycles. You can also check the sample count on the top here. For now, I'll close this window, and this also brings us to the end of this chapter. Today we understood about making a very basic lighting setup for the scene, and we did some final adjustments for this retro gaming arcade scene. So we are back in the scene where in the last chapter, we made some final adjustments like the lighting setup, adding some simple chairs, changing some materials, and rendering an image of the scene. And in this particular chapter, let's work on creating two simple animations by using camera tracking and other techniques. So right now we are in the solid mode. So for the first animation, my basic idea is to place the camera in such a position that it gets the view of only some specific part of the gaming machine, and then the camera will begin to move in the y-axis, and after that, when it reaches the end, it will zoom out and present the entire arcade scene. So to create this animation, we first need to change this window from the shader editor to timeline. After this, click on this lock button to activate the lock camera to view. Now let's zoom in and change the camera view by using the middle mouse button and the combination of control and the middle mouse button, or the shift key and the middle mouse button. So for the frame number 1, we'll set the camera in this particular position where it will show the opposite game controls for these two gaming machines. Now to create the animation, we first need to insert the keyframes for the camera's position at different frames. So for this, go to the scene collection, then select the camera, and to insert the keyframe, press I and here we have the keyframe inserted at the frame number 1. Now I'll take this pointer to around frame number 40, and with the camera selected, we'll move it in the y-axis like this. So let's move it in this direction until we reach the last gaming machine. In fact, for the frame number 40, let's keep the camera's position to somewhere over here. So I'll left click and press I to insert another keyframe. Now let's take the pointer back to the frame number 1, and if I press the spacebar to play the animation, then here we have a basic animation created where the camera moved in the y-axis. After this, I'll take the pointer around frame number 55 or 60, and then we'll move this back in the opposite direction. Then left click, press I to insert another keyframe, then take the pointer to around frame number 90 or frame number 100, and this will be the last frame for the animation, where we'll have the entire scene being displayed in the animation. As a result, with the pointer at around frame number 100, I'll simply zoom out, and after that, I'll adjust the camera view according to the complete scene. Let's change the view a little bit more until we have the best position of camera for capturing the entire scene perfectly. You can also switch to the rendered preview mode in order to see the scene in a better way. Now I think that this position of the camera is looking perfect for the frame number 98. So press I to insert a keyframe, and right now let's go to the material preview mode so that I can play the animation smoothly without any lag. So let's take the pointer to the frame number 1 and press the spacebar to play the animation. And now this is how we created a very basic animation with only the movement of camera in the scene. And so now we should also convert the animation that we created into a video format by rendering it to save it in our PC. So to do this thing, let's first disable the lock camera to view so that we don't make any changes by accidentally changing the view. Then to render the animation, go to the output properties, and in the frame range, we have the frames starting from the frame number 1 till the frame number 250. However, the total length of an animation is somewhere around 100 frames only. So instead of having 250 frames, let's reduce this to something like 120, or you can also set this to exact 100 frames. After this, to choose the location where you'll save the file, you can use the output path option by clicking on this folder icon. It will ask you to choose that particular location where you want to save the required animation. So suppose I choose a particular location, and here I type animation 1, then the video that we create will get saved with the name animation 1 at this particular location. So click on accept, and after this, change the file format from PNG to this FFmpeg video format. Then go to the render properties and do ensure to select the Cycles render engine. Then in the maximum samples, you can keep it to something like 128, and in fact the samples of around 50 will even work fine in most of the cases. Then I'll disable denoisy for now to get a realistic animation with some noise added to it. And after this, we are now ready to render the animation. So you simply need to click on the render button and select render animation. Then this window will appear where the animation is being rendered frame by frame. And once it renders all the frames, you can close this window and then check that particular location where you decided to save this animated video. And yes, you can also take a look at this animation that I created after making a few adjustments in the lighting effects and some compositing effects. And after this, let's now work on creating one more animation of this scene where we'll have the color of this text changing from one color to the other, and initially we'll have the camera zoomed into this particular text, and then it will zoom out in order to show the complete arcade scene. But before that, I'll also delete all the keyframes that I've added here for the previous animation. So press A to select all in the timeline editor, press X and select delete keyframes. Now I'll take the pointer back to the frame number 1, and to create the animation of the changing colors of this text, I'll first change this window from timeline to the shader editor. Let's also expand this window like this. And if you remember, while discussing about the separate and combine XYZ nodes in the chapter number 15, I told you that if I try to change the value of Y parameter in the combine XYZ node, then we'll notice a change of color between red and green, which are the two colors that are selected in the color ramp node. So basically, at the frame number 1, we'll set the color as red by inserting a keyframe for this particular value of the Y parameter, and then after moving some frames, we'll show a change in color to the green color by inserting another keyframe for this value of the Y parameter. So to do this thing, I'll first change this value to +6, which is giving us the red color. So right now, I've adjusted the value of this parameter to 9.5, and with my cursor over this particular parameter, if I press I, then you will notice that it turns yellow in color, and this will represent that we now have a keyframe inserted at the selected frame for this particular value of the parameter. Let's also view this in the timeline editor. So for this, I'll take my pointer at the bottom of this window, then this double-headed arrow will appear. So right click and select horizontal split. Then I'll bring this line slightly above and change this window at the bottom to the timeline. Now I'll select the combine XYZ node, and after this you will notice that here we have a keyframe inserted at the frame number 1. Now I'll take the pointer to around frame number 40, and I'll change the value of Y to something in negative so that we get the green color. After this, with the cursor again over this parameter, I'll press I to insert a keyframe, and now it's the time to view the animation. So I'll take the pointer to the frame number 1 and press the space bar. And here we notice a change in color from red to green. If you want this transition to be slower, then you simply need to select this keyframe and move it to some other frame. For example, if I place it at around frame number 80 or frame number 90, then in that case, the animation showing the change in color from red to green will be slightly slower. After this, I'll again take the pointer to around frame number 100 or 105 and then select the camera in the scene collection. Now we already have this final position of the camera ready in the scene from where we can clearly see the entire arcade scene. But if you want to make any adjustments, then click on this lock button and make the adjustments accordingly. But for now, I think that this view looks almost perfect for rendering the animation. As a result, with the camera selected in the scene collection, I'll press I to insert a keyframe at the frame number 105. Then I'll take the pointer to the frame number 1, click on this lock icon and we'll zoom the camera into the text. Let's adjust the camera view properly so that we properly zoom into the text. Let's zoom in even more, and after this, press I to insert the keyframe. Now if I press the space bar to play the animation, then here we have a basic animation where the camera is showing the zoomed out view and we also see a color change in the text. Now before moving forward, I'll disable the lock camera to view, and for this particular animation, I will hide all these chairs that we are having in the scene. And yes, this is only my personal choice to hide these chairs in the animation. If you want, you can keep them here in the scene and directly render the animation. But for now, I will select all these objects that are here for the seats or the chairs. Let's select the ones on this side with the shift key holded, and after this, let's also select the ones on the opposite side. So with the shift key holded, let's select all of them like this, and after that, we also need to select all these cylinders present at the bottom. So I'll select all of them, and now we have to hide, or basically remove all these chairs from the scene. So go to the scene collection, let's scroll down, and here we have all the objects selected in the scene. So to hide them from the 3D viewport, I can directly press H. However, they will still be visible in the final animation that we create until we disable these camera icons for the selected objects. And instead of left clicking for each of these individually, you can simply hold the left mouse button and drag the cursor like this. This will disable the camera icon for all these objects. After this, we are now ready to create the rendered animation. So for this, let's go to the render properties and I'll change the frame ending to around 120 or 125. Then in the file format, I'll again select the FFmpeg video format, and to change the output path, click on this folder icon and select that particular folder where you want to save the animation video. Then I'll type the name of the video, which is animation 2, and press enter to confirm. After this, in the render properties, do ensure to select the cycles render engine, and also in the maximum samples of render, I'll change this to 128 and also disable the denoisy option. And after this, we are now ready to render the final animation. So click on render and select render animation. Then this window will open where we have the frame number 1 being rendered, and once all the frames of this animation are completely rendered, you can open the folder that you chose in the output path to save the animation video. And you can also take a look at this animation that I have created after making some minor adjustments in the lighting setup and some compositing effects. And finally, this brings us not only to the end of this chapter, but also to the end of this course. Throughout this course, we learnt about a variety of different concepts related to the materials, textures and nodes, and in total, we have covered over 45 different shaders in the different chapters of this course. Then in today's chapter, we even created two very basic animations of this retro gaming arcade scene.